One. Okay. It says we're live. I got to get the go ahead from chat. I got to let them tell me that we're good to go. I'm checking. And it's going to have all this in there. So they're going to be irritated about that too, as they tend to be. But such is the nature of the beast. As I keep saying today. There we go. Excellent. Hello and welcome, my gentle and of course very modern apes. Welcome to my channel. This is Gutsick Gibbon. My name is Erica. I'm like a primatologist and a fifth-year doctoral candidate, and I'm really interested in science, communication, and evolution. And if it's your first time here, you've met with a wonderful fate, haven't you? You found yourself in an annual show that myself and my colleague and friend here, Will Duffy, have been doing for several months now, where we're essentially going over the support for evolution. And the reason we're doing this is because Will Duffy, who is known from Final Experiment fame, took a bunch of flat earthers to Antarctica, showed them that the earth is in fact not flat, and came back, received some flack from some of his fans because he's not an evolution guy. He's sort of been, originally at least, gained a reputation for being a young earth creationist. And so sort of keeping in mind with the character that he's maintained throughout the Final Experiment, he was like, well, I reject evolution in the age of the earth because I don't know a ton about it. And so I'm going to learn about it. And so we sort of were connected by a mutual friend so that we could do evolution, learn evolution. And I'm basically just giving him a modified version of the class that I taught for 1 year to honor students as biological anthropology, and then as a lab for 3 other years. So it's fun. We're sort of working our way through. We're about a little under halfway through, I think, or this might be the actual halfway point, but we have to give or take there because we're moving dates around and things like that. But I'm ready to go today. I'm excited. I'm having fun. Will, how you doing?
I'm doing great. Also having fun. Got a lot of cool things to share with you guys about my trip. So
yeah, you guys are going to be pretty blown away. So I actually don't know a ton of the details. I got a little bit of a sneak peek via email, but other than that, I don't know the nitty gritty of Will's experience. He went on a pretty envy-inducing whale watching trip and whale swimming trip. So I'm really excited to hear about that. Let me think if we have any housekeeping things. The only thing is, if you want a super chat to ask myself or Will questions, the money for those super chats goes towards our respective charities, which is Exodus Road and World of Literacy. And essentially, we're both of these are really good causes, and we wanted to have like we wanted to mutually have some networks that we're supporting in doing this that sort of reflect the values of this type of collaboration. So that'll be sort of at the end, all at once, big ticket. That's what I decided on doing because, like I said, I have to calculate all these super chats up, and it's just an absolute nightmare. So without further ado, the way that we normally do these things, if maybe you find yourself here for the first time, is the way we begin these is Will will kick us off with sort of a recap on what we talked about last time, the things he agreed with, the things he disagreed with, sort of where he's at generally, and then we'll jump into sort of the lesson for today, which today we're talking about very briefly the evolution of some mammalian orders, but primarily we're talking about bird evolution today. And I'm really excited because I didn't know a lot about bird evolution before I started researching for this. I guess I thought I knew a lot about it, but it turned out I did not know a lot about it, and I learned a ton, and I'm excited to share. So, Will, shall we get started?
Yes, my screen is shared. Waiting for you.
Excellent. Oh my gosh, look at that.
All right. So yes, as is the theme here, I share pictures that I took. So this was a breach that I was able to get a picture of. There's actually a humpback whale on the left-hand side as well, right here. And you know what? I didn't see this until this second. There's a flying fish right there. So what are the chances of that? Super cool. Yeah. So before we talk about my trip and before we look at whale photos and discuss whale evolution, I actually wanted to tell your audience I ran into a familiar face in downtown Denver a few weeks ago and happened to get a picture. So there we go.
Yep. So this is a really funny story. So Will and I and our respective spouses, we managed to touch base in Denver because I was in Denver in March for the annual American Association of Biological Anthropology meetings. So that's like the human evolution, paleontology style meetings that happen every year. And this year it was in Denver. And so since I was going to be there, I was like, Will and I, actually, I think Will reached out to me first. And he was like, hey, I know you're going to be in Denver. Like, if you want to grab lunch or dinner or something, then we should totally do it. And I was like, how could we not, right? Like, we've been doing this series for several months. What a phenomenal opportunity to kind of just like have a meal, break bread, get to know each other a little bit outside of this. It was an absolute ball. You guys, Will took us to this Brazilian steakhouse that I genuinely think I've never eaten more meat in one sitting in my life. Maybe one other time. I was telling Will and his wife this. My husband and I went to a restaurant called Carnivore when we were in Nairobi once, and it's like a big sort of meat style eatery where there's like, they got a lot of exotic meats there, like ostrich and crocodile and ox testicle and things like that. And so that was the only other time that I've eaten like a lot of meat in one sitting. But this was next level. Everything was seasoned to perfection. They have this honey cheese that they served at one point that I'm never going to be able to get the taste out of my mouth because it's so good. And I've been thinking about it. It's actually come into my mind several times since this dining experience. It's actually, I do have to say, and I think I mentioned this to Will, not the best choice of lunch for like having to go to a conference for the rest of the day. Because I was sitting there with the meat sweats and all of these talks just keeling over in these conference halls, and it was worth it, I think. But it was really fun, and Will and his wife are wonderful. It was a blast. So, and he treated us. Just letting you guys know.
Yeah, we had a great time. My wife enjoyed it as well, both you and Luke. So thanks again for that. That was fun.
No, our pleasure.
All right. Well, let's talk about my trip. It was, I was actually nervous. For those of you that don't remember, I look for whales every single year in the kind of December, January, February, March timeframe because they travel south from near the, up near the Arctic, all the way down, kind of getting close to the equator. And this year I had kind of like my worst year since I've been doing this, which goes back to 2020. So it's my like 6th or 7th year. So I decided to go back. I decided to go this time to the Dominican Republic. And I was worried because I went the last week of the whale season, which is kind of the first week of April, and ended up having the single best whale trip of my life. So cool. Here is a fluke picture that I got. And it's not a great picture, but it's good enough. Some of you may not know this, but if you get a good fluke shot, you can upload it to happywhale.com and they will match it with people who have taken a picture of the exact same whale. So the humpback fluke is like a fingerprint. Every single one is different. And so I've already uploaded this one. They've already matched it to a named whale that is already known in existence.
What's the name?
That I don't remember. I've got four now. The coolest story I have is I took a picture. I got a good fluke shot last year, submitted it. That whale had not been photographed since 1992.
Oh my gosh.
Yeah. And it was photographed up near, I think, Nova Scotia, Canada.
How cool. What a cool program.
It's really neat. It's really neat. The purpose of it is, number one, whale tracking, but number two is to check conservation and how well these measures are doing. Clearly, they're doing well. So these whales are being seen for many, many years. They're being seen where they're supposed to be. So it's really fun. So this was a good shot. Then this was one of my favorite moments of the trip. So we were about 100 miles out to sea. So we were on what's called a live aboard, where you live aboard a ship for the week. And so when you're out there, all there is blue. Blue sky meets blue water. That's all you see all week. I was on this little boat and I looked down and I saw dark on the left side of the screen there. You can see it. I immediately freaked out a little bit because it was a lot of dark, but I knew it was a whale. So there was a whale directly below our boat, and then it happened to surface right next to the boat. So this whale, I pretty much could have reached out and touched. That's how close this is. You'll notice some defensive wounds down here, some red there. That's some blood. Males fight for females. And so there was a lot of that going on. We actually had a competition pod next to our boat at one point that we estimate was 12 whales. So that'd be 11 males fighting for one female. And I was loving it, but I'm always trying to get like a good picture or something. So I stuck my GoPro upside down in the water, and I got this shot. So there are 6 humpback whales here. Yeah. There are 6 humpback whales here of the 12, but this I'm particularly proud of. The boat was moving, the competition pod was moving, and so I was holding on to this GoPro as hard as I could. The boat driver ended up talking to me after this, and he said, "Will, he's like, I thought for sure you were going to snap your GoPro pole in half because he's seen that happen when you stick it in the water." But I held on very, very hard, and I ended up getting a really cool shot. We also got in the water with the whales. So this was a mother and a calf that were circling our boat, super curious about what we were. And also, presumably, the mother wants to teach the calf about what's in the ocean. So when you get the green light, you can hop into the water with the whales. And this particular pair was circling me in the water. And I could see the eye of the calf, and the calf would look at me with one eye and then roll and then look at me with the other eye while mom is just circling me. And it's amazing because the calves stay attached to the hip of the mother whale. It's like a magnet. It's really a beautiful thing to see. And then this shows how close you get to them. There is no issues with getting hurt or anything like that. Whales are incredibly intelligent. They're incredibly relational. This was another mother and a calf that were really close to us. For this one, they were getting so close to me. I wasn't afraid, but I just wanted to make sure I could get a good picture and also be able to back up. So I was actually holding onto the boat with one arm and taking the picture with the other one. Right. And as you can tell, I still couldn't get everything in one shot. So anyway,
how humbling.
Yeah, it was an amazing trip. This is not a story for the public, but some things happened, and who was originally supposed to go with me on this trip had to back out last minute. So I actually ended up able to take my son, my 15-year-old son, and he had just like the time of his life. It was incredible. He'll never forget that trip for the rest of his life. So
yeah, I can imagine. I mean, goodness, and how lucky too to get that kind of experience. I mean, I don't know very much about competition in whales, but I mean, I study sexual dimorphism in primates, so it's like dimorphism is a consequence of male competition usually, or female aggression for resources, one or the other. So I wanted to ask, how do male humpbacks compete? Like, how do they fight? Do they just like
fight? Yeah. So I don't think we really fully understand. So here's how it works. A male will convince a female to be her escort. And so he'll find a female with a calf, and whatever they do to communicate, will say, "I'm going to be your escort." She agrees. She consents to that. And then they eventually head back north, and now he is to protect her and the calf
from infanticidal males.
Yeah, and from predators. And by the way, I don't have any pictures of this, but I didn't know this until I was going through my videos and my pictures afterward. But when I was looking at my videos of the mother and the calf, you can see the escort down below.
Oh, he's like just out of frame watching.
This actually might be his fin right here. That white thing right there actually might be his fin.
Oh, behind. I see. Oh,
behind the fish. Yeah. So anyway, what happens is if a male really wants a female, and the female already has an escort, they become known as a challenger, And so they'll come and say, "Hey, I'm going to now fight you for this female." And so there's a lot of, like hitting each other. There's a lot of like trying to get on top of them when they're coming up to take a breath. And there's
okay.
there's definitely a lot of blood as well. They've got acorn barnacles on them. I have pictures with a decent amount of blood on these whales that were competing, and so it's really at that point when are you going to give up? And so one of them will give up and leave because they don't want to fight anymore, and then that male gets to now become the escort for the female. So what's really cool is this competition pod. We found out that of the entire whale season, this was the largest one that they had seen with 12. And there's a reason for that. The guy that owns the company joked it's 2:30 and the bar's about to close. So whale season's ending. They don't have
Last chance.
They don't have a female. And so they were all, if there was one female, they were all converging on her, trying to get one last minute to escort back up north. So anyway, really fun to be up close and personal with these amazing creatures. Yeah. All right. Shall we dive in?
Dive in. I get it.
I you know, it's funny. I did not intend that. I do like puns, but I didn't intend that. So
you better be careful. This isn't a pun-friendly place, Will, but that's all right. Yeah, for sure.
I have learned that. Okay, whale evolution. After our last session on whale evolution last month, I decided to do something that I've been intentionally trying to avoid doing, and that is I reached out to a creationist on the topic. Now, who did I reach out to? I reached out to Dr. Carl Werner. I don't know if many people are going to be familiar with who Dr. Carl Werner is. There's a reason I reached out to him, and that is because I know who he's interviewed and what kind of work he has seen on fossils. I will say this, Erica, and this is not directed at you at all. There's a very strange, because I reached out to him, I went to kind of the debunking channels. I went to your channel as well to find out if anybody's talking about Carl Werner, and could find almost no mentions of him. And for some reason, you are definitely on the very bottom end of this. There's a strange obsession in the creationist debunking world with Kent Hovind. And so I don't exactly know what that is, but there was no limit of videos about Kent Hovind, which I don't understand, and nothing about Dr. Carl Werner. So anyway, the reason I reached out to him is because I knew that he has personally interviewed the paleontologists who discovered many of the fossils from Erica's whale presentation. But more importantly, he has also seen the original fossils. So he's the only person I know of that has interviewed these paleontologists in person and has seen the original fossils. That's why I reached out to him. In hindsight, after conversing with him over email, reading materials he gave me, I do not regret doing this, and I'm actually really glad I did. What I learned was literally jaw-dropping, and I haven't been able to stop thinking about it. And I do think this information will be new to most, if not all of you watching. So let's start with Rhodocetus. In 1994, Nature announced the discovery of Rhodocetus, which was discovered by paleontologist Philip Gingrich in Pakistan. And Rhodocetus was claimed to be a 46 million year old whale that walked on four legs on land, but swam with the undulating up and down tail motion of a modern whale. Here's the original press release from 1994. It says fossils of a 46 million year old whale that walked on four legs on land, but swam with the undulating up and down tail motion of a modern whale have been discovered in Pakistan by paleontologist Gingrich. Yeah.
Hey, real quick, you're kind of glitching out a little bit. I don't know why. Do you want to maybe refresh really quick? I just want to make sure I'm not missing any information.
Yes. I just noticed something about my internet, so hopefully that's better.
Okay, sweet. Yeah, continue.
Okay.
I'll let you know if it messes up again.
Okay, thanks. There's two other interesting quotes in this press release. One of them, Gingrich said, it retains primitive features seen in land mammals, but also exhibits derived characteristics found only in later ocean-dwelling species. He also said, this shows that tail swimming similar to that of modern whales, evolved early in cetacean history, Gingrich said. Now, after this discovery, Rhodocetus was displayed for years as a bald whale with a fluke and flippers. Here is an example of how Rhodocetus was displayed in a museum. I think this is the Paleontology Museum at the University of Michigan, but I don't recall where this picture was taken. So let's fast forward to 2001. Carl Werner traveled to the University of Michigan to interview Philip Gingrich and see the Rhodocetus fossil firsthand. And he noticed a massive discrepancy between the actual fossils recovered and what was being portrayed in the drawings. So as you can see here, there were no bones found of the tail or the flippers. So Carl Werner did what any normal person would do and asked Philip Gingrich why he came to the conclusion that Rhodocetus had a fluked tail and flippers. And his response is nothing short of shocking. You have to hear this with your own ears. And I got permission from Carl Werner to play this short clip. So here we go.
What was the reasoning that the scientists think there was a fluke on Rhodocetus based on the other pieces of anatomy?
Well, I told you we don't have the tail in Rhodocetus. So we don't know for sure whether it had a ball vertebra indicating a fluke or not. So I speculated it might have had.
Okay, so he speculated it. Now I understand that evolution is highly speculative, but this just goes too far in my opinion. I have no idea how many textbooks, articles, and museums portrayed Rhodocetus with a fluke and flippers over the years preceding Carl Werner's face-to-face interview with Philip Gingrich in 2001. But it does appear that the narrative was not corrected until Carl Werner brought this to light. A second Rhodocetus fossil was found, which confirmed that it did not have flippers either, but rather limbs. The flippers portrayed on Rhodocetus were also pure speculation. So everything in the drawings that is whale-like was false, essentially. So without a fluked tail or flippers, Rhodocetus does not appear to be a whale transitional fossil. Next is Ambulocetus. Also in 1994, science announced the discovery of Ambulocetus in Pakistan by paleontologist Hans Thewissen. Ambulocetus comes from two Latin words and means walking whale. And interesting to note, Hans Thewissen's doctoral advisor was Philip Gingrich. Now, Ambulocetus is portrayed as a walking whale with a blowhole. Without the blowhole in the models, the skeleton would not look like a whale at all. Fast forward to 2013, Carl Werner traveled to Ohio to interview Hans Thewissen and see the Ambulocetus fossil in person. And once again, he noticed a massive discrepancy between the actual fossils recovered and what was being portrayed. So Carl Werner noticed that the front half of the snout was missing from the skull. This is a picture he took with the fossils and Hans. And so the question is, if that part of the skull was missing, why is Ambulocetus portrayed and displayed at museums all over the world with a blowhole, which it still is to this day? So Carl Werner asked Hans Thewissen why Ambulocetus is classified as a whale and not a land mammal. And so Hans proceeded to show him the ear of a bowhead whale. That's Hans' hand right there. And I believe that's either a replica or an actual ear from a bowhead whale. He explained that a whale ear is bowl-shaped with a large cavity in the middle. His finger's in it on the left. You can see the cavity on the right. Here he's pointing to the involucrum, which is the thick side of the whale's ear. And this is the thin side of the ear, which contains the sigmoid process. So that little finger thing that his pinky is touching is the sigmoid process. Hans then pulled out the Ambulocetus ear bone and said this is why he believes it's a whale, but there is no visible cavity and there is no clear sigmoid process. So this isn't even the biggest problem with Ambulocetus. The eyes of Ambulocetus are on the top of its head, which does not make sense if it's at all in the whale lineage. Philip Gingrich acknowledged in his interview with Carl Werner that this doesn't really fit in the whale evolution progression. He said it's very strange. It has its eyes raised up on top of its head in a very strange way, and it's unusually large for an early whale. But mostly the eyes up on the top of the head seems like an unusual specialization. Maybe it's not on the main line, meaning maybe Ambulocetus is not on the main line of the evolution of whales. So without a blowhole, a questionable involucrum and sigmoid process, and its eyes on top of its head, Ambulocetus does not appear to be a whale transitional fossil. And then we have Pakicetus. So in 1981, Philip Gingrich published a report stating he found a fossil that could walk on land and swim in the sea. This fossil is known as Pakicetus, and that name is derived from its being discovered in Pakistan. Now, in 1983, Pakicetus made the cover of Science. So there it is. And you'll notice here, this is a live link. You can go to this link. This is exactly what it says right now. You'll notice it says Pakicetus provides the first direct evidence of an amphibious stage in the evolutionary transition of whales from land to sea. Now, once again, Pakicetus was portrayed with a blowhole, even though that part of the skull was not recovered. And once again, it was portrayed with paddle-like hands and feet, but none of those bones were recovered either. 18 years later, more Pakicetus fossils were discovered, allowing scientists a much more complete view of what Pakicetus was. And Pakicetus was changed from an amphibious whale to a land mammal capable of running. And so there is how science portrayed it in 1983. And here is how the Smithsonian Museum portrays it in 2026. I actually had somebody go take that picture for me last month at the Smithsonian Museum. So very, very different. Finally, the genetics of whale evolution, tying whales to hippopotamuses as their closest relatives. This actually seems to be a problem for evolution. Philip Gingrich again says this: we still have the problem if we are talking about whales evolving from these even-toed, hoofed mammals. They are all plant eaters. Whales today are all carnivores. The reason all of the original ancestors of whales were speculated to be carnivores was because whales are carnivores. And so when the genetics came along and it said hippos, that was a surprise and also doesn't really fit the narrative. Then this one's interesting. Dr. Daryl Domning says this: to a paleontologist, this is nonsense, meaning whales coming from hippos, because whales have been around in the fossil record about 5 times as long as hippos have. Hippos were very late on the scene, at which time whales had already been around for tens of millions of years, and to associate those two is really an absurdity to anyone who takes the fossil record seriously. Now, this guy is not a creationist, and it's interesting to note Howard University actually funded Philip Gingrich and Hans Thewissen for their digs in Pakistan. So that is my thoughts on whale evolution.
Oh boy. All right. There's a lot to get into on that. So I am probably for the first time in this series a little bit disappointed with that as a response, because almost all of that I feel like I covered in my presentation. And I showed like pictures of a lot of the crania that we have and pointed out specifically when that blowhole emerges, which it doesn't emerge until really late in Basilosauridae. That was in my presentation. I talked about how the involucrum in and of itself is the whale diagnostic feature, not the sigmoid portion of it, but that thickened portion of the inner ear. That's the thing that's whale specific, and that's what's found from these land mammals all the way to modern cetaceans. I also talked about how no one's like proposing that all of these guys are specifically in the direct line along to whale evolution. So I'm a little confused on that, because I feel like I covered all of those objections during the presentation. And I also feel like a lot of the transitional species were just completely skipped. And I know why that is. And that's because Carl Werner doesn't touch on a lot of them. Now, I have all of Carl Werner's books.
Wow.
They're in my closet over here. And well, this isn't a secret. I've been vocal about this for a long time. But I've been going through all 5 of his books, paying special attention to the human evolution stuff, because that's obviously what I'm formally trained in. But I've also been reaching out to all the people he interviewed. And I'm only about halfway through his first of 5 volumes, reaching out to those interviewers. And I've sort of mentioned this offhand only once, but that's because I'm kind of working up to a big video on it, because I think, and I'm going to say this to you now just because I've been planning on doing this for quite some time. You can find other videos of me mentioning this. But I have very little respect for the work that Werner has done in particular. And the reason is because in the area that I know better than anybody else in this sort of circle, which is human evolution, he gets stuff wrong a lot. And I find that his portrayal of some of the stuff is a little bit dishonest. And that doesn't really matter. Like, I can dislike Carl Werner and you can really like him and come to this and find his arguments compelling. But even just in the examples that you talked about here, like, and the clip that was mentioned about, speculation with regard to the tail, there's a concept called phylogenetic bracketing, and I can include something about that in the next lecture, sort of as we work up to it. Because I honestly think I'm going to have to, at the beginning of the next lecture, like, go through this point by point so I can show you the pictures of like where he's wrong on that, because Werner's just incorrect on the nature of these fossils. And again, that doesn't really touch on anything of what I said is the through line, right? Like that thickened involucrum does like factually exist in Indohyus and in Pachycetus and in Ambulocetus and in all the protocetids and in all the basosaurids and no other mammal, right? Like, it's just those guys, just as we would expect from evolution. In addition to that, we find progressively less functional hip bones as you move through the geologic column, which I've never seen Werner mention. He never talks about the hooves that you find, like the toes that have hooves on them, like hoof caps on them, in these nearly completely aquatic cetaceans in Georgicetus and in, Myocetus. He doesn't talk about the land mammal type birth that Myocetus was engaging in, nor does he talk about the fact that Myocetus was capable of fully terrestrial locomotion, albeit awkwardly. Now, I'm fine with the idea science changes. You know that better than anybody else. I don't have to tell you that. Science changes. Of course it does. And I don't find it compelling in the slightest that Pachycetus was originally presented as more amphibious than it was later found out to be. In addition to that, though, it wasn't a capable runner. And I sent you the, Werner's just wrong on that. I sent you the textbook after our last meeting. There's I think, at least don't quote me on this. If it's, I will check directly after this conversation just to make sure. And if it's not, I'll find the paper that it was in so that you can for sure have it. But like, Pachycetus was notoriously like clumsy on land, due to the nature of its limb proportions, but also due to the fact that it had these extremely dense bones because it lived a lifestyle that was very similar to hippos, which is what you would expect if they share a common ancestor in the past. None of that is mentioned. It seems like the main thing that you focused on in this was the blowhole, which I never said was something that emerged earlier, right? Like, I said that in the presentation. I had it pulled up. I was just making sure that I didn't say that incorrectly while we were going through this. So I got to be honest, I don't find, oh wait, I have 2 more points here. One, it's definitely not a problem, like for sure not a problem that whales are carnivorous and hippopotamus aren't. Because one, hippopotamus do eat meat like kind of often, right? That's not their primary adaptation, but like most herbivores, they're opportunistically omnivorous. But also within the evolutionary framework, we see carnivorans diverge from herbivores and vice versa, and omnivores diverge from both all the time. In fact, that's necessary. I don't understand why that would be an issue. And I will be tracking down that full quote because in fact, I probably won't even track down the quote. I'll probably just email Gingrich and be like, hey, did you say this? And if so, what was the larger context? Because, and this goes around to the beginning as to why I've been going through Werner's books, the other about 8 or 9 times so far that I've emailed the people that he's interviewed, I have not gotten positive responses with how they were portrayed and how their points were potentially taken out of context. So I do think that some of what you said is worth going over again. And I'll put something at the beginning of my last one just to make sure that we touch on it, because I think this is a really, really important point. And I want to ask you, if I can make those clarifications, like, would you then find it compelling?
So yes, let me just kind of give you my overview. It appears from my research that Rhodocetus has kind of been thrown out as part of the whale lineage. Ambulocetus, it seems that many secular scientists are like, we don't think so because the eye's on top of the head. That's really big. The involucrum, here's where I struggle with that. When I was doing this research on the whales, I watched a video. I forget what channel it is. It's a really big channel, millions of subscribers.
Maybe eons or something like that.
Yeah, I don't remember. I could find it. But he said that the appendix has evolved independently 34 times. And he called it convergent evolution.
True.
So,
but why do we know that it's emerged independently like that many times? Because it exists in multiple different extant groups. In this case, the statistical, I feel like you have to ask yourself this really honestly. What's the statistical likelihood of this singular structure that exists today exclusively in modern whales and progressively more terrestrial animals as you move back through the geologic column, along with a dozen other features that are moving in tandem in the animals that these features are found in? You see what I mean? Like, that feels like special pleading to me.
Well, here's what I'm going to say. Here's what I'm going to say is if there's some discovery made, hypothetically speaking, and they're like, okay, never mind. We were wrong. This is fine. This is how science works. This actually isn't in the whale family. Then evolution would just say the involucrum is just convergent evolution, just like the appendix. So that's the issue that I have. It just kind of seems like having your cake and eating it too.
Hold on just a second. The appendix has evolved several times. Yes. So the appendix has evolved 32 times across 361 species, unlikely to be a useless evolutionary accident. I agree with that. I'm totally fine with that. However, let me see if I can find this quote here. These appendices are not identical. They're all, they're not all the same type of appendix. I'll send this to you afterwards. They're not all the same type of appendix, which is what lets you know that it's not, that these animals, that's not through common descent. You see what I mean? Like, if the involucrum showed up, I 100% believe this. If the involucrum showed up exactly as it is in cetaceans, and exactly as it is in basilsaurids, and in protocetids, and in ambulocetids, and in remingtonocetids, and in pachycetids, and in Indohyus, and it evolved in like a carnivoran exactly the same way, absolutely 100%, people would not immediately be like, oh, it's just convergent evolution. They would be like, what is going on here? Because this is a totally unique structure just to cetaceans. And again, it's found in tandem with countless other features that are changing in turn. The reduction of those hind limbs, the thickening of the cortical bone to let these guys move underwater better, the reduction in the complexity of the surfaces of the teeth, the movement of the blowhole up the snout. I find it really, that's another thing that I thought was weird when I was reading, because like I said, I've read through Werner's 5 books, but then I'm re-going through them a second time to take notes and reach out to the people. And I find it surprising, and I'm going to ask this of you. When you go back and like reconsider some of this stuff, pay very close attention to what he doesn't talk about. Because these presentations that I've designed, I've tried my hardest to cover everything. The stuff that is really, really supportive of evolution, and the stuff that's kind of confusing to evolution, or at least it doesn't make sense just yet. But in my opinion, at least with regard to the human evolution stuff and what I remember, because I've read through it fewer times with the other volumes, his first and second, and then a little bit of the third volume for non-hominin evolution. There's so much information that is just completely omitted, right? Like, I'll give you an example. There's this cranium, a skull for Homo habilis, that Homo habilis is a famous transitional species that sort of connects the base of genus Homo, our genus, and these ape men looking things, Australopithecus. And Dr. Warner mentions it in his book, and he says this is a cranium that exists, and it's a complete cranium. So like there's no reconstruction that had to be done to put it back together, because that's one of the main things that he likes to touch about on hominin evolution, is to say that this reconstruction was incorrect, or it was done erroneously, or in the case of Philip Tobias, he likes to softly pitch that it was done intentionally to favor evolution. But this is a solid cranium. And he has like 2 paragraphs on it. In the entire 3 volumes that he spends on human evolution, one of the biggest fossils that's considered to be transitional to link these 2 major groups, he spends 2 paragraphs on it because there's nothing he can say about it, right? It's a complete cranium. I have a model of it. It's the second one. It's that one behind my finger there. So I would take care, you have to make your own opinion on that, on what you find convincing and what you don't. But I found it surprising. I would really appreciate it if you would side by side, because I hope you do have his book. If you don't, I'll send you a copy.
I do now. I have a PDF.
Okay, good. That's actually better because you can make notes. Pull up his section on whale evolution. Pull up my PowerPoint. Go over them side by side. Look at what's mentioned in both, and look at what's missing in mine, if there is anything missing, because I don't have a photographic memory. Maybe he does talk about stuff that I missed, and I'm just not remembering it. And pay attention to the stuff that he doesn't mention, because I know there's quite a bit of that.
Yeah, let me tell you this. This might help you a little bit. Is I didn't just assume that what he was saying was right. So I actually learned this from somebody you don't like probably, which is Stephen Meyer. And it's a brilliant quote, which is beware the sound of one hand clapping. There's always another side. And that's why I searched your channel first and then the other debunking channels for Carl Werner. And I'm telling you, it was silence. So in that situation, the silence was deafening. I could only find one mention one time, and I believe it was on Joel Duff's channel, and that's it.
I mean, that's appropriate. Did you watch Joel Duff's video?
I don't remember. Probably not.
The reason, I mean, that's actually a classic example as to, and this is like kind of horrible to say, a lot of the reason why I think he's not gotten a lot of attention, and I've been working on this. You can find clips of me talking about going through these books page by page, going back 1.5 or 2 years, because he's got 5 volumes. I've been trying to be the one to do this subject justice because he's making a really big claim. I mean, his claim is that the entirety of the fossil record is an increasingly convoluted series of dupes and mistakes. And I know some of them are accusatory of intentional forgeries and things like that, because he said as much in at least the human evolution volumes. So I thought it deserved a response, but I want to do my due diligence, because one of the things that he does is he cites all of these interviews with all of these people. And so I thought, who better to check with than the horse's mouth, and to individually reach out to these people. But as you know, that's very time consuming. In the case of this beaver video, the video on Joel Duff's channel with Carl Werner, that is perfectly emblematic with, I think, the type of research he does and why you should be wary of it. So the TLDR of his role in this is that a fossil was discovered roughly 2 or 3 years ago that was nicknamed the Jurassic beaver, right? It's this mammal. It's like, yay big, and it's nicknamed the Jurassic beaver because it's got this paddle-like tail, and it's argued to be a swimmer, right? So Dr. Werner includes this in his list of out-of-place fossils. He's like, this is a beaver found in the Jurassic. It's an out-of-place fossil. Another reason why we shouldn't believe in evolution. It's because there are so many of these out-of-place fossils that they don't know what to do with, and they're completely stumped on. But as Joel pointed out, and as the New Creation blog pointed out, which is a blog by young Earth creationists who I have a lot of respect for, Peter Paleologos, as he goes by here online, Todd Wood, they run it, and a bunch of young up and comers. They did an article about Dr. Werner's misrepresentation of this, because he's presenting this as if we found a literal beaver or beaver-like animal in the Jurassic. That is not at all what was discovered. What was discovered was a mammal that had a paddle-like tail. Beavers also have paddle-like tails. So do platypuses. So do some reptiles, right? Like, that doesn't mean it's a literal beaver, and it certainly doesn't mean it's an out-of-place fossil. If it were, it would need to have the characteristics of a beaver's dentition, like what rodents have, which is big incisors, a diastema or a gap between the teeth before you get to the molars, features of the skull and face that are found only in rodents, because rodents don't appear until like way later than that. That would be an out-of-place fossil. But the publication has that skull and face material, and the teeth are primitive. They look like every other mammal that's walking around at that time. So it's very clearly not an out-of-place fossil. It's a primitive mammal that has a paddle-like tail. But why then was it pitched as an out-of-place fossil? I think it's worth noting that other creationists pointed this out as inappropriate. Mm-hmm. So I'm just going to encourage you to be vigilant about that.
Well, no, I'll tell you, I'm excited, and I'm not surprised that you are already working on responding.
Well, I'll get here. I want to make sure that, hold the phone.
Okay.
I just want to make sure that you believe me here.
I do.
So one of my things is that I buy a lot of creationist books to go through them. One that I did on my channel for a really long time is this one called Contested Bones. I've gone through every page of this. It's the biggest response to the hominin fossil record by creationists by Sanford and Roop, and I've gone over each chapter on my channel. But then here are Werner's 3 on human evolution, and then I have the PDFs, kind of like you do, on my Kindle of the first 2 books. I think, awesome. I mean, goodness, I even got this one's just references, which is really helpful because you can track down all the references and see what's what there. I take this really seriously is what I'm trying to say. I want you to know that it is not a coincidence that I seem a little bit prickly about Dr. Werner because I've been stewing about this topic for a little bit of time, but it's very much on my back burner. So what I'm going to do is this. I am going to, in a rare moment, take specifically what you said in the beginning here, and I'm going to have a little bit at the beginning of the next time we meet to address it, because I think it's worth it. Is that okay?
For sure. Okay. Definitely.
And do you know what else I'm going to do? I'm going to be reading Dr. Werner's bits on tetrapod evolution and preemptively including stuff to deal with that, because I'm annoyed. I am annoyed that he's popped up before I've managed to put my big thing out about him. Because he's done quite a few interviews. You should ask Donnie his opinion too, by the way.
Okay.
I don't know his opinion, but I think it would be interesting. All right, let's talk about bird evolution. Is that okay?
Absolutely. Excited.
Okay, good stuff. I'm sorry if I'm heated there.
It's okay. I didn't know any of that, and so like I said, I'm legitimately excited because I care about truth. Yeah. And again, I don't want to just listen to one side, so I'm excited to hear what you have to say.
I'm certainly gonna do my best. I think it's definitely appropriate. Okay, let's.
And for what it's worth, I don't know anything that he said on human evolution, and so I will.
Oh, now that's the thing that you got to know about me, Will, is that the human evolution stuff. We're spending 3 PowerPoints on that. I mean, we've got a lot on human evolution, and that's the kind of thing that I can do on the fly very easily. That is my area of expertise. Okay, let's see here.
Awesome.
Hopefully I can get this up and running. And I don't know. It's far be it from me to sit here and, let's put it that way. I don't like to toss shade at people that I've not actually engaged with myself. Because, why is this not noticing my PowerPoint? Maybe if I minimize it, sometimes it likes it when you do that. Share screen. Actually, I never have problems with this. There it is. Excellent. All right. And actually, hold on, Will. No, actually, don't hold on. We'll worry about that next time. What I was going to say is that I don't like throwing stones at people who I haven't directly interacted with, right? Because there's I like to imagine that I have a reputation for interacting with a lot of creationists. I had a debate on Donnie's channel with Peter Line last week. I've spoken with Jerry Bergman. I've spoken with Rob Carter. Like, most of these guys I've reached out to or interacted with in some way. Carl Werner is not one of them. And I don't think he's going to like me by the time we do interact. But, I I hope that you can understand or appreciate knowing a little bit about me, that I don't lightly cast aspersions like that. But I'll set that aside for now.
Yeah,
Okay.
just the fact that you have his books speaks volumes. Okay.
I'm just saying, man, like I'm glad that you think that, because I mean it when I say that I don't like to say things about people that I don't feel like I have formed a good opinion on. Like, for example, the other one that I just set down, contested bones. Where is it? What did I just do with it? Where did I put that thing? Oh, I'm tripping. It's right here. Contested bones. This thing I have a lot of problems with, but there's also, I'm going to say, in my opinion, more correct information in this than there is in these other 3 volumes, in my opinion. Okay. Anyways, okay. Decompress. Get my stress levels down. Get my cortisol from spiking. All right. Today we're going to talk about the evolution of some major mammalian orders. We're going to talk about the evolution of birds, and we've punted mammals to next time. I optimistically made this at the beginning. So a little bit about me for people who might not know. I'm a science communicator, and I'm a 5th-year PhD candidate in biological anthropology. So I study human evolution. That's my bread and butter. But this, in general, is a course to teach Will and anyone watching what evolution is and why the scientific community is convinced by it, as well as how it specifically applies to humans. This is a hybrid course, so I've added a little bit to it. Some is the same, some is different from last time. And as always, it's not meant to be a creationism debunking series. In fact, there is none of that, I think, in today's presentation. Here's where we are today. We're talking about some major mammalian orders and birds. Let's do a little bit of a recap from last time. So previously, we discussed the nature of nested hierarchies and the classification of organisms. So like, why do we classify critters the way that we do? The reason is to convey information. Right? So we can all sit here and say, okay, humans belong to the species Homo sapiens because we have the characteristics that define a human, from genetics to physical characteristics. Humans also belong to the family Hominidae because we have the characteristics that defines hominids. We also belong to the order primates because we have the physical characteristics and the genetic nesting pattern of critters that are primates. Likewise, we belong to the class Mammalia. But pause, because we're still primates and hominids and humans in addition to being mammals. We fall into the phylum Chordata, and we fall into the kingdom Animalia, and we fall into the domain Eukarya. So we are simultaneously eukaryotes, and we are chordates, and we are vertebrates, and we are mammals, and we are primates, and we are hominids, and we are humans. This is classification in increasing specificity. And we do this with all sorts of stuff. We also discussed the nature of genetic similarity and how phylogenetic trees, or family trees at the population or species level, match the family trees across genetics and physical characteristics typically. And the genetics family trees also match the family trees that we get from historical records. So I touched a little bit about this paper that experimentally bred colonies of bacteria forward. So we had a known pedigree for these guys because we watched them reproduce through time, and then we sequenced their genome and they matched. The genomically sequenced phylogenetic tree matched the known family tree. And of course, organizations like Ancestry.com make a lot of money doing the same thing. I had a sidebar on the molecular clock, but I'm going to punt it to next time because I want to sort of cement, I want to sort of, what's the word I'm looking for? Seed it within what we're actually talking about. We also talked about what we should expect if evolutionary theory is true. So we have these 6 things here that I've repeated over and over again. If evolution is true, and say tetrapods or 4-legged land critters like this little amphibian here at the top right descend from Sarcopterygian or lobe-finned fish, then number 1, mechanisms need to exist to explain the emergence of those new variations. We need to be able to see this happen over immense periods of time because evolution doesn't happen like, super duper fast. So the time needs to be there for this change to happen. We need to see a nested hierarchy actually form in the functional and non-functional regions of the genome alike. We need to see the paleontological emergence of those new characteristics that define the modern group, differentiated from the older group as we move through the geologic column. We need to see traces of that ancestry in the living critters today, so their development and their anatomy needs to support it. And we need to be able to pinpoint genetic changes or like specific genetic pathways that could theoretically or experimentally show how we get these traits. We need all of these to be able to make the case that tetrapods descend from Sarcopterygian fish, at least to make it, true in a scientific sense. As a casual reminder, evolutionary mechanisms are very powerful, but a lot of the time they're working with what's already present. I think that's especially important in the context of whale evolution that we discussed last time, because we applied those 6 characteristics to what we know about cetacean evolution. And I think quite handily, we showed that these are all checked, right? The mechanisms of evolution, mutation, natural selection, genetic drift, and gene flow, all of those in existing experiments can take organisms and change them pretty drastically, whether we're talking about color changes, the addition or loss of limbs by repeating sections of the genome, or even the evolution of brand new proteins, as in the case of our antifreeze ice fish. We also showed that looking at these guys, they form a nested hierarchy in the functional and non-functional regions of the genome, sharing not just physical characteristics with their closest living relatives, the hippos, but also nesting with them genetically. We showed developmentally that cetaceans seem to emerge or seem to descend from land-dwelling ancestors because while they're developing, they start developing little hind limbs, which then disappear later on in their development. Something that's, interestingly enough, recapitulated in the literal fossil record that we look at, right? Their limbs, which start off as fully fledged hind limbs in something like Ambulocetus, get smaller and smaller as we move more recently into the past until they're long gone by the time we reach the Neocetes. But they're still there and small in Basilosaurids. And that's another thing that I'm irritated about. I don't think Carl Werner mentions the fact that Basilosaurus has the ankles of a deer. I don't know why. Anyways. We've shown that we have immense amount of time for evolution to actually occur. We've shown that paleontologically, the forms that exhibit this change show up through geologic time, not all existing contemporaneously at the same time. And we showed many of the genetic changes specifically that need to actually happen to create these changes, right? Like we talked about specific papers that showed how you lose limbs in these cetaceans, or the types of genes that are responsible to allow sperm whales to dive to intense depths. So now we're going to talk about some other mammals. Virtually all major mammalian orders evolved during the Cenozoic, over the course of about 65 million years. The very earliest mammals existed alongside the dinosaurs during the Mesozoic, but most of them were really small. They didn't get much bigger than like a badger. They looked a little bit like that guy, the very first ones. After the non-avian dinosaurs go extinct, a ton of different niches or ecological roles open up for mammals to diversify into. We're going to focus on the evolution of a couple of the stranger ones outside of cetaceans. Now, during the Cenozoic, which is the past 65-ish million years, the world temperature fluctuates like quite a bit, but typically, as you can see in this graph here, it starts out warmer early on and it cools off as we come to present day. This idea is supported by the geochemical work with like stable isotopes, but also by the types of fauna and flora that we find in the fossil record at each of these sites. The continents more or less look the same as they do now. Super early mammals look really generic, while later and modern mammals look a lot more specialized. So you can see here on the left, this is by Nick's Draws on Tumblr. Here are some drawings of some early mammals from the very earliest portions of the Cenozoic. There's Arctocyon, one of the skeletons that that specific guy is based off of. And you can see that early mammals are pretty generic: 4 legs, 5 digits, a tail, ears, a mouth, teeth, etc. Whereas in the Holocene right now, we have a ton of diversity amongst mammals. But not all transitions are equal. We talked a little bit about this last time, but going from like a shrew-like mammal in the Cenozoic, or excuse me, in the Mesozoic, to a modern-day rat, not super difficult. You're not having to change a lot. But going from that little guy to something like an elephant or a whale or a tiger or something like that, that's going to require a lot more change and a lot more specific pressures. So mammals can be divided into 5 major groups. The monotremes and marsupials, these are the guys that are mostly living on Madagascar. The afrotherians, this is going to be a group that we're going to talk about in just a second, that are like a really weird hodgepodge of guys. The xenarthrans, these are going to be armadillos and sloths. The euarchontigliers, this is rodents, rabbits, primates, tree shrews, and flying lemurs. and the Laurasiatherians, which are like carnivorans and odd and even-toed ungulates and bats and cetaceans. Mammals are really diverse. So here's a little skull from a sort of proto-mammal or an early mammal. But it's going to be pretty different from some of the diverse groups that exist today. So here we have, going sort of counterclockwise, we have a manatee or a dugong, and then we have a proboscidean, like an elephant and a monkey, and then 3 perissodactyls in the form of a rhino and a horse and a tapir, and then a whale and a dolphin, a dog and a cat, and a giraffe and an antelope. And like all of these guys seem really different at face value. But what I want you to appreciate is that they all have the same basic setup, right? They all have generally the same bones. They all have generally the same 4 limbs attached to a vertebral column, a rib cage, a skull, teeth. So really, we're changing a pretty basic formula here to get this type of diversity. So let's talk about a couple of these major mammal groups. First, I want to talk about Afrotherians. Genetically speaking, this is insane. Sirenians, proboscideans, hyracoids, tubulodentadans, macrosolicitans, that should be macrosolicitans, and afrosoricitans form a group called Afrotheria. What that means in plain English is genetically, elephants, elephant shrews, aardvarks, tenrecs, hyraxes, and manatees and dugongs form a group together. They are like a little family tree. That seems weird because these guys seem really different. Now, typically, it seems weird at face value, but like when you look at their actual anatomy, things start to make a lot more sense. Typically, to be a member of Afrotheria, you have to have a high vertebral count, so lots of different vertebrae. You have aspects of placental membrane formation that unite you. You have specific features of the ankle bones that unite you. You have the late eruption of your permanent teeth. And, perhaps most strikingly, all of these guys have undescended testes. Now, this group here, the Afro-insectivilians, are united by something that's probably pretty obvious. They mostly eat insects, and they have characteristics that sort of unite them and help them do that. But the other group, the Painungulatans, seems to be the weirder group, and they're united by a couple of features that are surprising too. So, these 3 guys all have a single pair of nipples that are located up on the chest that they use to feed their young, or at least that's their primary feeding pair. Hyraxes, elephants, and sirenians. And they also have the same feet. They have nails on top of their little digits that have this broad, flat cup shape to them and are composed of the exact same stuff chemically. Now, I think this is particularly interesting because if you were to take a sirenian, like a dugong or a manatee, specifically I think it's the manatees that have the most prominent nails here, and you were to actually look at that and say, what's this the most similar to out of everything on the planet? The correct answer, morphologically speaking, is actually elephants and hyraxes. So what we're seeing here is physical characteristics, again, uniting these guys along genetic lines. So taxonomically and developmentally, by physical characteristics and by their genetics, they do seem to make sense with one another. But we got to go a little further than that. We got to know how these weirdos actually evolved. I want to talk about sirenians first because they're really similar to cetaceans. And in fact, that's another great evolutionary prediction. What would we expect to see if these guys evolved from land-dwelling ancestors? Probably a similar setup to what we saw with the cetaceans. So first, can they evolve? The characteristics that unite the sirenians are that same sort of fusiform bullet-shaped body. They don't have any hind limbs. They have unique features of their skull, and they have really dense bones, just like hippos do, just like all of those cetaceans do. These features involve very specific genes in some cases, and in others, they're actually convergent with the genes that we see in whales. And we know what genes those actually are. This is a cool paper called Sirenian Genomes Illuminate the Evolution of Fully Aquatic Species within the Mammalian superorder Afrotheria. So we know that the genetics is at least characterized enough to appreciate what actually causes the changes that need to happen to make a sirenian, essentially. But we also need like a fossil to kind of show that transition. And I'm being very truncated here because I really want to get to the birds, and also because, you know, there are too many mammalian orders to go over all of them. This is a dugong and a manatee, and this is Pisosiren from 50 million years ago. You don't have to be an anatomist to appreciate that this is just a manatee with legs, right? This is a manatee straight up with legs. it's a pretty easy sell. And not only does it have legs, it's got these long legs, and in addition, it's got dense bones, just like a hippo does. It actually occupies a really similar niche, which sort of sets us up for understanding why something like this would eventually become fully aquatic in the first place. They're already spending a lot of time in the water to graze on seagrasses. But there's actually another link that links Pisosiren to the modern Sirenians, Sobrasiren. Sobrabasiren, I should say, who looks very similar to Pisosiren, but the legs are slightly shorter and the bones are slightly denser, and the head is slightly more derived towards what we see in modern dugongs and manatees. So paleontologically speaking, we do have some of these steps to actually put us there. Proboscideans, just again keeping ourselves moving forward, similar situation. The closest relative of the proboscideans at present is, again, those dugongs and manatees and then the hyrax. And we have a last common ancestor of the two of them, at least in the case of the Sirenians and the elephants, that looks like a pretty good candidate. It kind of looks like a mixture of these two guys in the form of Moeritherium. And Moeritherium is represented by this skeleton over here and has one like kind of telltale proboscidean characteristic or whale characteristic, or excuse me, goodness, now I got whales on the brain, elephant characteristic, which is they have small tusks. I'm going to highlight with my cursor here, right here on either side. And these tusks, which are longer than their other teeth, are derived from the lateral incisors, which the tusks in modern elephants are also derived from their lateral incisors. So we know that this thing is a primitive proboscidean because proboscideans are the only animals, to my knowledge, that derive their tusks from those lateral incisors. What's cool, though, is we can see these other characteristics emerge too. So modern elephants are big. They have trunks. They have these weirdly tall skulls with these really flat faces. They have polyphyodont teeth that are also hypsodont and loxodont. What this means, put simply, is that they have several sets of these gigantic molars, as you can see here. They're huge, the molars. That's one molar that person is holding there. They have huge sets of these molars that come in one at a time. The molars are really tall to help their teeth from wearing down to nubbin so that they can keep eating throughout their lives. And the teeth have these cross hatches on them, these loaths that are so extreme that we consider them to be loxodont. None of these traits are completely absent in that guy here, Moeritherium, who I just talked about. This guy has little lateral incisors, but they're not that much bigger than what we'll see, or excuse me, they're not that much bigger than those central incisors. It has a prototrunk, which we can get a decent idea of as to the, because of the concavity of that maxilla area. They have the large-ish bodies, those tall-ish skulls compared to some of the other guys that are living around that time period, and they do have some hashing on their teeth. But we don't have to guess at this because there are over 160 species of proboscideans living across the past 60 million years. For the Sirenians that we talked about a little bit ago, there's I don't know how many species there are, but not 160. Proboscideans are really, really, really well represented. Here are a couple of them. There's Moeritherium, pretty small guy, Paleomastodon, getting bigger, Gomphitherium, getting bigger still, Dinotherium, absolutely huge, and mammoths as well, in addition to countless others that I haven't mentioned here. But looking at their skulls, this transition is pretty evident. You can see these lateral incisors grow longer and longer. You can see that the skull sort of create this concave area here, again, for that tusk to sort of flop over. They've got this massive nasal aperture or nose hole because they're, again, breathing through that massive trunk. The skull is getting taller. The teeth are becoming more adapted towards their given lifestyles, and so on and so forth. There's Moeritherium, again, Paleomastodon, Gomphitherium, Dinotherium, and mammoths. Here's a cool paper that shows you kind of what I mean as to like how we know whether or not a trunk was there. Because it seems like, how could you possibly infer that? It's kind of cool, but trunks are maneuvered, they're manipulated by several muscles of the head and face. And so the muscle attachment sites of these fossils can tell us a lot about whether or not an animal had a trunk. Now, I can't tell us for sure how long the trunk was, so there's going to be some variability in like whether or not Dinotherium's trunk was like this long, or maybe a little bit longer, or maybe a little bit shorter. But certainly these guys had either a very prehensile upper lip or like a fully fledged trunk because they've got the musculature for it. You can see their teeth grow complex through time as we move from Moeritherium all the way up to our modern proboscideans. And the genetics behind this is like pretty dang characterized, like all the way down to the genes that are responsible for giving woolly mammoths, or more accurately, hairy mammoths, their hair. So I think we can say decently that we've got a good case for proboscidean evolution because they're super well represented. They do form a nested hierarchy. Like we have the DNA from mammoths and mastodons, and they form a nested hierarchy just like we would expect in the functional and non-functional regions alike. In fact, interesting fact, mastodons and mastodons and modern day elephants are more different from one another than humans are to chimpanzees, genetically speaking. These guys share all of the same bones and teeth, although they are in different shapes and sizes. We do see the emergence of the characteristics that define modern groups show up as we move more recently or more distantly into the past through the geologic column. And genetically, we can pinpoint many of the characteristics that define elephants and characterize them. We can know what genes need to change to actually get a modern day elephant. So we've shown decently that several Afrotherians have a pathway for evolution. I'll note too that we already discussed last time the artiodactyls and the whales, as well as the carnivorans. So I'm going to shift gears a little bit here and talk within Laurasiatheria about these odd-toed ungulates, the perissodactyls. So perissodactyls are odd-toed ungulates. What that means is that they're hoofed animals that have an odd number of toes. They might have one, as we see in the case of the horse. They might have like 5, as in the case 3 to 4 to 5, as we see in the case of living and extinct rhinos and tapirs. And this is their phylogenetic tree. Horses are the odd man out, with tapirs and rhinoceroses being more closely related to one another. Generally speaking, these guys are defined by having hindgut fermentation. So unlike most artiodactyls, which have like 4 stomachs and they ferment all their food in their bellies up at the front, these guys are hindgut fermenters. So they ferment most of their food in their large intestine. They have big stocky bodies, and they have an odd number of toes, as I said, usually in the front rather than the back. At least on one foot, they have an odd number of toes. And then more specifically, horses have 1 digit, rhinos have large horns, tapirs have small trunks, and all 3 of these groups have really unique teeth. So, first things first, they do form a nested hierarchy with one another, genetically speaking. Just again, as we would expect, going back to Linnaeus, we've recognized that these guys are the most similar to one another, and this is confirmed by genetics too. But it's important to note that they also all have the same bones and organs and teeth, right? They're just, again, in different shapes and sizes. So as we learned in all the way back in the mutation section, you know, you're really changing existing information here. You're not having to add a whole lot of new stuff, except maybe in the case of the rhinoceros with this unique horn here. But horns are derived from hairs, and all 3 of these guys already grow whiskers or vibrissae on their faces. So horse evolution was one of the first evolutionary sequences that was considered to be really well documented. There's a group of guys that are sometimes called Orohippus or Eohippus or Hyracotherium. I've sort of included them all here together as a group. And what they effectively look like is a little horse, except for their feet, where they have more than 1 toe. In fact, they've got 5 full toes down here. You can't see the other one on this one, but there's 5 toes on this little guy. You can see it over here in the lowest portion of the Eocene rock. And they also have relatively simple, short molars. Found a little bit more recently is Mesohippus, who looks almost identical to Hyracotherium in the general body, but it's reduced those toes down to 3 toes. And that middle toe should look pretty familiar, because this is going to be the toe that modern-day horses end up keeping. Their molars are a little bit taller, and the surfaces of those molars are a little bit more convoluted. Even more recent in the past is Merycohippus, who, just like these other guys, or just like the prior Mesohippus, has those 3 toes. But what's really cool about this guy is you can literally see those toes are in the process of going away. They're smaller and they don't touch the ground like they did in Mesohippus. They're like up the ankle, or up the wrist, I should say, in this guy's case. Likewise, just like the previous transitions, we see an even taller, more hypsodont molar that's even more convoluted, specifically in the direction of modern horses. And what's really cool about this is that modern horses can experience a mutation that causes them to develop extra toes. Allegedly, when I was researching about this, Alexander the Great's horse was like this, and supposedly it had like a cool connotation to it, like, you know, your horse is going to be like extra fast or extra strong or something. We see the same exact thing as we move through rhino evolution, with this change in the surfaces of the teeth and in the general body shape and in the presence of larger and larger horns or different types of horns. Rhinos are really, really well represented in the fossil record, as you can hopefully see from these crania here. And finally, tapirs, the same thing. And actually, tapirs are cool because just like we saw with the whales, you can see this nasal bone migrate up the skull to make room for that trunk. And we know that this is what is going on here, that this is a trunk, because those muscle attachment sites are present in them, just like they are in modern tapirs and also in elephants. What this means, and what I think is sort of, I guess, important to point out here, is that all three of these guys are one another's closest living relatives, with rhinos and tapirs being the closest and horses being the odd man out. And this means if we move backwards in time, as they go back towards their last common ancestor, they should start to look more and more similar. These are the three common ancestors. This is the first horse, the first rhinocerid, and the first tapir. And they look almost identical. And that's because, as with any evolutionary lineage, as you go back in time, you're basically converging on something that looks really, really similar between all of the descendants. Kind of like how if you take two really closely related dog breeds and you go back in time, those two dog breeds are going to start looking more and more similar to one another until you converge on their shared ancestor, which in some cases looks like a mix of both. And that's what we're looking at here with Orohibis/Eohibis/Hyracotherium, and these other two guys here. Again, three different skeletons: early equid, early rhino, and early tapir. What's neat, though, is that digit loss occurs in the same way in three-toed, or in animals that have digit loss in general. So over here, we're looking at a three-toed jerboa and a horse, and you can see that that digit loss is occurring in basically a similar fashion, embryologically speaking. They start by developing those extra toes, and then as they continue through development, the development of those toes ceases, and they resoar back into the body, except when they don't. And that's when you get those horses with the extra feet. In real life, we're using the similarity between horses and rhinos to create fake rhino horns using horse hair. And these dealers who are buying rhino horns, usually as like an aphrodisiac, they can't tell the difference. And that's because horse hair and rhino horn are made of the same stuff. They're made of the same keratin, and they're such close relatives that even if you were to like try to DNA test it, unless you're doing the entire genome, you're not going to be able to tell the difference. And we have some really cool living fossils, if you will, in the form of tapirs, who have an odd number of toes on their back foot and an even number of toes on their front foot, because these toes are disappearing sort of one at a time. So Afrotherians and Laurasiatherians are supported by the data in this very brief bird's eye view, supported by the data. We're going to talk about monotremes and marsupials a little bit next time with the origin of mammals. We're going to talk about euarchontigliers when we talk about human evolution. And we're going to maybe touch a little bit on xenarthrans, but it's a very small group. Its fossil record's pretty poor, and we don't have a lot of time. So put an asterisk next to them. We might talk about them later. Mammals are very diverse. Again, here's all of our living forms. But as we move back in time, they simplify. They get less like their modern counterparts and more like the last common ancestor of all of them. And when you go back to the very first member of all of these groups, you find that they're even more similar to one another still. So what I've just shown here is these are living groups. Here's a common, like an early version of all of those living groups. So we've got an early Saurinian here, an early Proboscidean, an early primate, 3 early odd-toed ungulates, an early cetacean, an early carnivoran, and an early artiodactyl. And then you go even earlier than that to the common ancestors of some of these groups share with each other. And again, they look more and more similar to one another as we converge, and also more similar to that last common ancestor, that generic mammal. That should not be the case if these guys don't share an evolutionary history with one another. This fossil record is about as ordered as you could expect, in my opinion. So, all of that being said, let's talk about bird evolution. Birds, first of all, this is my favorite bird. This is a bearded vulture. I think they're really pretty. Birds are super diverse, right? We have flamingos that filter feed. We have birds of prey that can soar over mountaintops. We have tiny hummingbirds that operate like helicopters and little songbirds that sing beautifully complicated tunes. We have wading hunters like this stork and beautiful peacocks that display for one another. We have completely flightless birds that live in the desert like ostriches, and other completely flightless birds that live in the Arctic, or in colder regions, I should say, generally, like penguins, because I think they come from the Antarctic, not the Arctic. And then we have chickens in the middle. But birds among living animals are united by many, many features. First, birds have hollow bones. This is a picture of a bird bone sliced in half. Bones are hollow. Second, they have 3 very rarely clawed fused fingers and a specialized wrist bone called a semilunate carpal. The purpose of the semilunate carpal is it allows them to tuck their wings, which is important for birds. They have 4-toed feet, as you can see in this chicken, with 3 turning forwards and 1 turned backwards in this case. They have, in this chicken, a keeled sternum. So the sternum is the breastbone, and in chickens and other birds that can fly, it's got a keel on it because you've got to attach those breast muscles on either side, the pectoralis muscles. That's what allows them to fly, or at least helps them fly. They have a rigid spine. They need to keep that back really stable and rigid so that they can, again, maintain their flight. Their pubis bone is facing backwards, so that's here in red. It juts backwards. They have an S-shaped neck, as you can see here in yellow. They have a really mobile shoulder. That makes sense if they're flapping their wings. They have a reduced tail, a pygo style, which you can see here. They have no teeth and a keratinous beak. They have a furcula, or a wishbone, and they're bipedal, covered in feathers, and usually they can fly. These are the characteristics that generally unite living birds, physically speaking. Outside the skeleton, birds lay hard-shelled eggs, and most incubate these eggs in nests. Other animals lay hard-shelled eggs, a little bit more about that later, but birds specifically incubate them in the little nests that they have. Birds also breathe unidirectionally. So they breathe in a way that's really different from us as mammals. When we breathe, we take a breath in, and then we exhale it. And if you hold your breath, you're not doing any gas exchange. So you very quickly start to feel anxious, and you need to take another breath. For birds, they have these anterior and posterior air sacs. So when they breathe in, that air goes to the posterior air sac where it just kind of hangs out. Then when they breathe out, air is shunted into the lungs. They breathe in again, more air comes to the posterior air sac, shunts the air that's in the lungs to the anterior air sac, and the air that was in the posterior air sac goes into the lungs, and then another exhale pushes everything out again, and this cycle continues. Basically, this makes sure that they always have fresh air in their lungs. And it means that they are, historically speaking, very difficult to drown or suffocate because they've got so much oxygen exchange, so much gas exchange going on all the time. This is a very cool system. They're endothermic, or warm-blooded. They have a 4-chambered heart, and they have a gizzard that helps them break down food. So birds don't have teeth. So one of the things that's very helpful to them is you've probably heard of this before, but birds will eat rocks. And the reason they eat rocks is because those rocks sit in the gizzard, which moves around, makes all these contractions to help digest food. And the rocks that they swallow kind of act like internal teeth, and it helps them break down their food. Lots of birds do this. Chickens are notorious for it. So evolution sets up the usual predictions from here. If birds evolved from dinosaurs, then we should have the mechanisms and we should have the time. Check and check. We've gone over the mechanisms plenty of times. We've talked about how much time we have, a lot. But we need to show the rest of these. We need to see the nested hierarchy. We need to see the developmental traces and the traces in their anatomy. We need to see the emergence of these characteristics through geologic time. And we need to be able to pinpoint the specific genes that are responsible for them. So far, so good?
Yes.
Check. Feel free to hop in at any time if you have questions or comments or anything like that.
Okay, I did think of something on the whales, if you want to just jot a note on it.
Tell me.
I just lost it, of course.
Oh, I hate that.
Hold on. Oh,
It's gonna
yeah.
come.
I don't see how genetic drift would happen with a whale that's in the ocean that travels from the equator to the Arctic and Antarctic.
Drift. I think it probably depends on the species in question. So it probably functions differently for like spinner dolphins that live in really huge pods versus solitary dolphins. But you would probably know this better than me. In solitary whales, they do convene, do they not, for competition and for calving and things like that?
Yes. But
So that's
but when like humpbacks specifically, humpbacks in the Atlantic never go to the Pacific. Humpbacks in the Pacific never go to the Atlantic.
so genetic drift is just the random changes that accumulate that aren't under the effects of selection. So if they're reproducing at all, then genetic drift's going to be at play.
Okay.
You see what I mean? Genetic
Yeah.
drift is still, do you mean gene flow maybe? Like the exchange of alleles between populations?
Well, I was trying to imagine you were giving examples of like a river separating a population, an allopatric speciation.
Yeah.
And
So
I put that under genetic drift.
So you're thinking, how would that happen? So genetic drift, to be clear, is a mechanism of evolution that's the random fluctuation of alleles. I think you might be thinking of gene flow here, which is when
Maybe.
barriers show up to separate populations and then let them speciate.
Yeah.
In water-dwelling critters, the way that happens a lot of the time is by change in the pH, in the chemistry, in the temperature. Did I say that already? Whatever, characteristics of the ocean that drive animals to new locations. So they sort of separate themselves out. In the case, like I saw a really interesting example earlier today about Pacific and Caribbean shrimp, which used to be a single shrimp population until the Isthmus of Panama formed, which separated them out. And now they can no longer interbreed with one another, right? So they live in the ocean. It's kind of hard to imagine how a geographic barrier could emerge to separate them, but a geographic barrier emerged and separated them. And they didn't go all the way around. And I'm sure it's different with whales because they're global species.
Mm-hmm.
But they do have behavioral patterns. So they have like general migrations, but those migrations aren't they're not identical between every individual every single year. And they're found globally. Am I wrong?
Humpbacks are, but
Okay.
with all the tracking I know of, which is done through pictures of their tails, it's done through shooting them with a crossbow with a tracker, and it's done through suction cup trackers with drones. They drop drones on the whales when they surface.
Yeah.
As far as I know, they've never gone to a different ocean.
Let me look into it,
Okay.
and I'll include it at the beginning next time, because
Perfect. Thanks.
you might be right. I don't know. I don't know how gene flow functions in animals that have global habitats. The only thing I can think of is that occasionally behavioral differences show up and they just don't want to mate with one another, which would be a social barrier to reproduction, which does happen and helps speciation occur, especially in animals that have rituals and songs and dances and things like that. But I'll have to look into it to be sure.
All right. Thanks.
All right. If birds evolve from non-avian theropod dinosaurs like this T-Rex, just like with whales, it should be obvious genetically and from the fossil record. So, genetically, all birds nest within a group called the archelosaurs, with birds and crocodiles being more closely to one another than either is to turtles or the testudines. Already, that would make zero sense under anything other than birds have a reptilian ancestor and are reptiles themselves, right? If anything, birds should be the outgroup here, but they're not. The genetics of bird evolution, or excuse me, of archosaurs in general, and then archelosaurs more generally, is really clear. Birds and crocodilians, sister groups with one another. But we should see more than that, right? Like, it shouldn't just be the genetics, like with whales sharing modern characteristics or sharing ancient characteristics even with artiodactyls, like how basilosaurids had the ankle of deer, of pronghorn antelope. We should see similar like archosaurian characteristics that unite birds and crocodiles even today. And we do. Crocodiles, like birds, have 4-chambered hearts. Crocodiles, like birds, have gizzards, and crocodiles, like birds, breathe unidirectionally. These three characteristics, again, alone are enough to suggest that there's a pattern here. So let's walk, just like we did with whales, from the present into the past and see if we can't uncover some kind of connection here. So modern birds are a part of a group called Neornithes, and they share the characteristics that we already talked about, right? All of these birds have the same hollow bones and the same non-toothed keratinous beak, and they have feathers and so on and so forth. But going into the past, like several million years, tens of millions of years, we find birds that have these same characteristics. So all three of these pictures I took from the Fossil Butte page from National Monument in Wyoming, from the government website. These are just pictures of fossils that they pulled from here. And you can take a close look at these guys. Some of them are shoreline birds, some of them are landfowl, some of them are roller birds. They're all from about 52 million years ago. And all of them, they have all the characteristics that just define a bird. Like they're regular old birds, make sense. This is the bracketing for Neornithes. The oldest member of the group we find around 67 million years ago. So the oldest bird that's a member of the modern group was around before the extinction of the dinosaurs, or the non-avian dinosaurs, I should say. That bird is named Asteriornis, and as you can see in green here, and from this little cranium, it has all of the same characteristics that defines a bird. Here's a modern bird skull, just so you can see for comparison. This thing's a bird. Non-controversial. I don't think anybody would look at this thing and say it's not, especially when you see the full skeleton. Good to go. Pretty typical. So let's move back a little bit more to a broader group called Ornitherae, which show up at the earliest around 100 million years ago. Now, this is a little bit different from what we looked at with those cetaceans, right? Like we're looking at a little bit different of a pattern for bracketing these guys. Here's what we did for our cetaceans, where we had our modern whales bracketed in red here, and then the range for basilsaurids, for protocetids, for remingtonocetids, for ambulocetids, for pachycetids, and then for rowellids here. But I'm going to organize this a little bit differently to show you what it is that we're doing with birds. Because with birds, we're nesting them. We're creating them, we're organizing them in their nested hierarchy by characteristics that they share through time. So if we were to do this for whales, here's how we would do it. Same timeline that we just looked at, same Neocetes, living from that same range from 34 million years ago to present. Here is the earliest appearance of all of those other groups. But all of those other groups have the characteristics that define modern cetaceans, like the involucrum, for example. So they all fall within the larger group Cetacea, with pachycetids branching off the earliest, followed by ambulocetids, followed by remingtonocetids, and then protocetids, and then basilsaurids, and then our Neoceti group. Critically, again, none of these guys directly beget the next guy. And I should say they could have, but we can't know that, which is why most of the graphics that you see won't propose that, just as I've done here. Likewise, Cetaceomorpha, or animals that have a handful of cetacean characteristics, but not the primary ones, that involucrum with specific characteristics, and the astragalus and those thickened bones, things like that. Rowellids are a part of Cetaceomorpha, but they're not technically cetaceans. They are outside of that group Cetacea. But all Cetaceomorphins are members of a larger group called Artiodactyla, or those guys that are defined by having that double pulley astragalus. All of these fossil whales have, and all hippos have, and all deer have, and nothing else does. So they're nested in a hierarchy here. All Neocetes are cetaceans, all cetaceans are Cetaceomorphins, and all Cetaceomorphins are Artiodactyls. So that's what we're doing with our birds here. All modern birds are members of a group called Neornithes, but all modern birds are also members of a group called Ornitherae, because Ornitherae has characteristics that modern birds have. Ornitherae begins roughly 100 million years ago at the maximum, and it's represented by this guy here, Ichthyornis, and by this guy here, Hesperornis. Do you think those are birds? I just want to ask.
They look like birds.
I think so too. I don't think anybody would disagree that they're birds. They've got bird characteristics in the form of hollow bones. They have those three, I say rarely clawed here because remember, Ornitherae includes modern birds, and some modern birds have claws. They have four-toed feet. They have a keeled sacrum. They have a fused pelvis. Their pubis juts backwards. They have a really mobile shoulder. But they have a keratinous beak that's filled with teeth. They also have a reduced bony tail, an S-shaped neck, a wishbone. They're bipedal. They have feathers. They can fly. But they also have this feature called gastralia. Now, gastralia are weird. I'm going to talk about them in a second. First, let's talk about the teeth. Teeth exist in the earliest members of these groups, but they seem to reduce over time. So there's Ichthyornis, that guy that we saw on the left. There's the skull. There's the teeth. There's Hesperornis, who also has the teeth, but you'll notice that that front portion of the beak in both has fewer teeth, and then even fewer teeth in Hesperornis until we compare them to a modern seagull, which has no teeth. Now, we know that both of these guys also had beaks because they have these little pock marks in their premaxilla that are for blood vessels. And only animals that have beaks have these blood vessels directly to the surface of their premaxilla because the keratin of the beaks needs a blood supply. So that's how we know that they had beaks, because all living birds have this feature. All living birds have beaks. So when we find it in extinct animals, they probably had beaks too. And sometimes the beaks are fossilized, as we'll see as well. But in addition to having teeth, some members of Ornitherae, like this obvious bird Ichthyornis here, have gastralia. Gastralia, as you can see with my little cursor here, are these tiny little rib structures. They're called belly ribs that are down at the bottom portion of the chest. And belly ribs exist in another group, the crocodiles, the crocodilians specifically. Again, they don't exist in turtles, and they don't exist in lizards, and they don't exist in snakes, but they're here in crocodilians, and they're also in birds. But only these toothed ones so far. No living birds have gastralia that I know of. Now, it's important to note that no living birds have teeth as adults. None of them do, at least, again, as far as I know. But normal bird chicks still have the genes for teeth. And we can turn those genes on and they'll start to develop teeth, just as a more primitive bird might. But interestingly, the animal that these teeth look most like today is crocodilians. To quote from the paper, we compare the formation of teeth in Talpid 2, the Talpid 2 mutant, with that in the alligator, and show the formation of decidedly archosaurian or crocodilian first-generation teeth in the avian embryo. And likewise, no living birds have snouts. They have that same keratinized beak. But if you disrupt the gene that is the protein coding genes, that are responsible for forming the beak, which are called FGF and W and T, bird embryos develop dinosaur-like snouts instead. From this paper, a molecular mechanism for the origin of a key evolutionary innovation, the bird beak and palate, revealed by an integrative approach to major transitions in vertebrate history. You can see here's their chicken on the left, normal chicken. Here's the chicken that they turned the genes off in, and here's an alligator of the same age. And that experimental chicken is smack dab in the middle of the chicken and the alligator. The authors state themselves, here we've shown that a relatively minor, though novel, additional region of gene expression at a sufficiently early stage can precipitate changes that result in dramatic morphological transitions of two distinct skeletal structures. So that paragraph is saying a lot. But to sum it up, a small change that's unique, right? If you turn this off in birds when it's normally not off, all that change is an additional region of gene expansion. So a gene that's already there is expanded. Small change results in massive skeletal changes in the face and in the neurocranium, or the skull itself, the portion that holds the brain, that causes them to look more reptilian. And because they're expanding this region that I suppose was truncated, normally truncated in birds, you get a more primitive condition. What's cool is that here's an X-ray of some of these, or it might be a CT scan of these features inside the cranium as well. And you can see the bird versus the experimental versus the early dinosaur. And then here is this is called a principal component analysis. So what that means is that it's a graph that's plotting shape. So you take a 3D scan of something usually, and you put a bunch of landmarks on it, and then you feed all of those landmarks into statistical software like R, and then R will plot them as to how similar they are in 2D space. You can get a good idea as to which shapes are most similar to which other shapes. And what they show here in figure 5 is that in gray, here's a bunch of dinosaur skulls, and then in blue, a bunch of modern bird skulls, and their experimental skulls fall in the area that overlaps between modern birds and non-avian dinosaurs, along with just a handful of proposed transitional species that link birds and dinosaurs. Taking another step back, there's a group above Ornitherae called Pygostylia, and the oldest members of this group are from 136 million years ago. And I just want to take a second to emphasize again how important time is in all of this, because it's not like these are guys that we're finding all in the same strata. The oldest members are always more primitive than the youngest members are. You see this morphologic change occur through time, because that's what evolution would demand.
Sorry, you lost me there. If I found a chicken and I found a T-Rex, I would be like, that chicken is way more primitive than the
Really?
T-Rex.
I find that surprising, because when you look in the fossil record, you find T-Rexes way, 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 way earlier than chickens.
I'm just sorry, maybe I misunderstand what you mean by the fossils are more primitive in the older layers. I thought we were talking about how they look.
So the way that you define whether something's primitive or whether it's derived or like modern is dependent on how different it is from the earliest forms that are proposed to be related to it. So for example, let's take dogs, for example, again, right? You have wolves and modern dog breeds. If I have a poodle and I have a husky and I have a wolf, the husky has characteristics that look more primitive compared to the poodle because it shares more characteristics with their common ancestor than the poodle does. Does that make sense?
Mm-hmm.
Okay. Let me know if you have any more questions. If it doesn't make sense, let me know, because I might just be explaining it bad and I want to make sure that it's clear.
Okay.
All right, so, and I should say this. If you were to find a chicken in the same layer as a T-Rex, and you never found a T-Rex older than that, I should phrase it like this. If you were to find a chicken in the same layer as the earliest dinosaur that we know of, that would be pretty solid evidence against evolution. You know what I mean? Like, because you have the ancestor, the earliest version of that ancestor found at the same time as a very later descendant.
Mm-hmm.
But we have not found that yet.
Okay, now something tells me if we did, that the mainstream science would just be like crazy. The chickens have been or have lived that long. Isn't that what they would say?
I don't know, because it hasn't ever happened. But I think my honest opinion is that if that happened, you're totally right. At first, they would be like, there has to be a way to explain this. And they would test the rocks to make sure that the dates are all correct. And they would scour that area to see if maybe there's been an intrusion or something like that. If it was truly inexplicable and they were able to check off every box, then that would be an actual game changer. I think that's true. Because I think all of these lines of evidence are treated. You know how it seems like we keep hearing that they found really good evidence for life on Mars?
Mm-hmm.
Have you noticed that? It seems like every year they're like, this time for real, you know?
Yeah, I never buy it.
I don't either, but I think that's because so many times it's been really close and then they've been like, shoot, we found out it was actually just this. You see what I mean?
Mm-hmm.
Like, the reason we don't buy it is because they say, this is consistent with life, and then they find another explanation for it. So this would work the same way. If they found it, people would be like, whoa, that's crazy. We have to rule out everything else because this is so contra to the paradigm. You know what I mean? Like, it would be similar to like if I dropped a pencil and it suddenly fell up. Like, would that instantly debunk gravity? Probably not. Probably what we would say instead is, okay, I dropped my pencil right here and it falls up. That's one instance of gravity being defied out of trillions of instances of it not being defied. So can we rule out a random gravitational anomaly right here? Can we rule out, divine intervention? Can we rule out aliens? Can we rule out something quantum? Because it would just be, it's so against the glut of the evidence. You know what I mean?
Yeah, I'll find the link and send it to you. Is it John stated clearly?
Mm-hmm.
I'm pretty sure I heard him right. He made a recent video and he said an out of place fossil would not falsify evolution. It's too robust.
I disagree with. Well, it wouldn't outright falsify it. It would be tremendous evidence against it. In the same way that if I drop this pencil and we couldn't find a gravitational anomaly, like if I drop it and it falls up, then we could rule out gravitational anomaly. We could rule out something quantum. We could rule out divine intervention. We could rule out aliens. If we could rule out all of those things, does that mean gravity is debunked? No, but it means something really weird is going on. And if we started to find it all the time that it happened, then that would start building up the evidence in favor of, gravity being debunked. You see what I mean? Like,
Yep.
It's not that an out of place fossil wouldn't be evidence, like a severely out of place fossil wouldn't be evidence against evolution. It's that a single data point rarely, if ever, debunks an entire idea.
Okay.
You see what I mean? Like, especially one that's established. Like, you need to build a case to it. But if we suddenly found series after series of fossils that were like humans with dinosaurs, or with trilobites or something like that, I think if you found enough of those, that would do it. You would just have to be able to show it was robust.
Okay.
And I should mean evolution by common descent, not the mechanisms of evolution. Okay, back to this. Do you have any questions about those experiments? I thought those were really cool.
No, I gotta process them.
Roger, Dodger. Let me know if you need the links or if you can't access them. Okay, Pygostylia. This is the next group. So just like last time, all neornithines, all modern birds are members of this group Ornitherae, which is modern birds plus those other two toothed guys that I showed you. And then all of those guys, Ornitherae, like including the modern birds and those toothed guys, are all members of Pygostylia. Pygostylia includes a couple of other groups of critters that are not a part of Euornithes, or they're part of their own group, including a group called Enantiornithes, whose name means opposite bird. Here are a couple of skeletons from some Euornithes, or like true birds, and then opposite birds. And when you look at these guys, they have hollow bones. They have 3 occasionally clawed fused fingers, as well as that semilunate carpal, that wrist bone that lets them tuck their wings. They have 4-toed feet. They have a keeled sacrum, that big breastbone that anchors the pectoralis, at least in the case of Euornithes they do. They have a mobile shoulder that they can move really flexibly. They have teeth. They have a keratinous beak. They have a longer pygostyle. So that tail that's really, really short in birds that attaches the tail feathers that helps them maneuver through the air and do these really quick turns. It's a little bit longer in these guys. It looks a little bit more like a tail than it does like an anchor for tail feathers. They also have an S-shaped neck. They have that wishbone or furcula. They walk upright when they're on the ground. They're covered in feathers. They usually fly, except in the case of like this guy down here, who's like an early ostrich-looking dude, Patacophteryx. And they also have those belly ribs, those crocodilian belly ribs. Another member of this group is a group called Confucius Ornithidae, goodness, from 131 million years ago. And these guys are really, really cool for a couple of reasons. One, they're covered in feathers, just like all of our other guys were. They have the hollowed bones. They have these 3 always clawed fused fingers. They have 4-toed feet, but they don't have that keeled sacrum that basically all modern birds have, that most modern birds have. Instead, their sacrum is flat, which means they would have been less powerful flyers than like a robin or a songbird or a hawk today. Their pelvis is fused, as we see in modern birds, and that pubis, which is this bone right here highlighted by my cursor that kicks backwards, it does kick backwards in these guys, but the symphysis of the pubis is actually fused together in these guys instead of open like we see in modern birds. Also, their shoulder is a little bit less mobile than what we see in later birds. So when they flapped, they couldn't quite pull their arms all the way up above their head to do that downstroke. They also have this closed eye socket in the back, which is a characteristic that you see in a lot of dinosaurs. But they still have a fully modern pygostyle. They have an S-shaped neck. They have a wishbone. They're bipedal. They're covered in feathers. They do fly for sure. And they do have those belly ribs. One thing I really like about these guys is that you can see in these fossils, like these just gorgeous feathers. I mean, you can imagine that these guys must have been really, really pretty when they were alive, especially with these little two twin tails that comes off of these guys. But when you look at that skull is pretty dang different from this bird's skull right here. That cranium is definitely unique. But what's cool is that these guys, I should have said this too, because you see I have a toothless keratinous beak here. Oh, I'm so stupid. This is a comparison of a Compsognathus cranium. So this cranium, this skull that you see highlighted by my cursor, this is me pointing to what the closed eye socket looks like. Whereas in a bird, they don't have this bar that is highlighted. Hopefully you can see it there. No bar in a bird, but there is a bar in these members of Confuciornithidae. This is a dinosaur skull, just to be clear. These guys did not have teeth. So what's cool about these guys is that they've got these beaks, but these are not the direct ancestors of birds. The beaks that these guys have, we think convergently evolved, just as we were talking about with convergent evolution of the appendix earlier. And the reason we think that they were convergently evolved is because the beak that they have is not identical to the beaks that we have in modern birds. Just like the beaks of modern birds aren't identical to the beaks of turtles. They're a uniquely developed beak. In this paper, on a disassociated, that Rhamphotheca just means beak, a fossil bird Confucius ornis, informs early beak reconstruction. They say Confucius ornithids display Rhamphotheca, or beaks, similar to modern birds in some ways, caudal extent, shape in most, and completely contrary in others. They have rostral projection, shape in IVPPV, the specific specimen there. This supports the hypothesis that similar mutations across Dinosauria triggered the initial formation of beaks before differing minutiae in their development. And so if you can see this little phylogenetic tree down here highlighted by my cursor, Ornithothraces here, here, these guys are a sister group to all of these dudes that we're talking about, like the one seen here. So these guys are not direct ancestors to modern birds, but they evolved their own beaks all the same. And according to this paper, it was in a similar way, albeit not identical. Here are a couple of cartoons showing the skeletons of these guys. And, you know, I showed you the skeletons in and of themselves a couple of slides before. This is just for clarity. So compared to modern birds like this chicken over here, highlighted by my cursor, and this is a chicken skeleton too, just with the arms in a different position. Because that's one thing that you're going to notice as we continue to go through these, is that sometimes these organisms that are proposed to be close relatives of birds, sometimes their arm is positioned like this bird is here, and sometimes it's positioned down more like what you would see in like a dinosaur. So what I want to show is that they can put those arms in either position, and that is helpful to understand how they're similar and how they're different. So I wanted you to see both views here. Here's Ichthyornis. There's Sulcavis, who's a member of one of those opposite birds, or Enantiornithes, and then here's Confuciornis. Compared to modern birds, guys like Ichthyornis have teeth and crocodile belly ribs. And compared to modern birds, stem pygostylians like this guy and like this guy, they have a non-keeled sacrum, so they don't have that big bird keeled sacrum. They have longer pygostyles, or tails, than what you see in a bird. They have 3 digits on each wing that have claws on them, and some of those claws can grasp. They have more primitive skulls filled with teeth. They have gastralia, and they were also poorer flyers. Outside of pygostylia, there's a group called Avialae. Avialae is represented by this guy here, Anchiornis, from 160 million years ago, the famous Archaeopteryx lithographica from roughly 151 million years ago, and Rahonavis from about 70 million years ago. And these guys are all really, really interesting. I want to start with Archaeopteryx because it's so famous. George Mivart in 1871 was a big opponent of Charles Darwin. And when he was arguing with Charles Darwin, one of the things that he said that sort of become famous is, what's the use in half a wing? How can you explain the evolution of something like flight if half a wing can't help you fly, and it probably slows you down and makes you a less efficient runner or climber or swimmer or whatever? Let's talk about that. Archaeopteryx lithographica was first discovered just 2 years after Darwin's On the Origin of Species came out, and it was found in a limestone quarry. Here are some of the first specimens attributed to it. There's a lot of specimens of Archaeopteryx. First, there was an isolated feather that was found in Jurassic sediment. And then we had a relatively headless specimen, or definitely a headless specimen. And then this full Berlin specimen, which is just it's a beautiful, complete skeleton. Both of these specimens matched each other, and they shared similarities with a small dinosaur that had been discovered around this same time called Compsognathus. So in addition to the growing non-avian dinosaur fossils that we were finding, like Compsognathus and like, these big theropod dinosaurs, not T-Rex, but big clawed carnivorous dinosaurs kind of like them, all of these guys were being discovered and sort of pulled up out of the ground at the same time, and their anatomy was being compared to living animals, because dinosaurs are obviously extinct, and these guys were like, well, what are they related to? Are they related to anything? And 3 different scientists, Thomas Huxley, Charles Gegenbauer, and Edward Drinker Cope, all 3 were kind of together proposing this evolutionary link. They said something akin to maybe modern birds evolved from something that was similar to dinosaurs because they seem to share so many anatomical characteristics. Here are some of the Archaeopteryx fossils shown from smallest to largest here, and with relative completeness filled in. So if you can see the bone, they have it in that specimen, and if you can't see the bone, they don't have it in that specimen. So what are those characteristics? What traits does Archaeopteryx have? There's 14 really solid specimens of Archaeopteryx lithographica, and that's just one species. Archaeopteryx is a genus, so there's other specimens too. Archaeopteryx had hollow bones. It has 3 clawed, non-fused fingers and a semilunate carpal, so it could tuck its wings just like a bird. It had a pelvis that was mostly fused, but not all the way, and its pubis was variable, but most similar to modern birds, having that kickback look to it. And when I say it's variable, I mean it's a little bit different in Lithographica versus some of the other species. In Lithographica, it's pretty bird-esque here, as you'll see in a comparison in a moment. They have a pretty dang mobile shoulder. They were definitely capable of fully putting their arms up for a downward flap, not as upward as modern birds, but certainly upward enough to achieve that downward flap. They had a no beak and a mouth full of teeth. They had a really long tail, like a dinosaur does, but this tail was rigid, so it didn't quite have that same flexibility that something like Compsognathus would have. It has an S-shaped neck. It has a wishbone. It walks upright when it's on the ground. It's covered in feathers. It's capable of flying or gliding, and it has those same crocodilian belly ribs. So as you can see here, there's the foot with that backwards facing toe. Or I should point out here, it's not quite fully backwards facing. So here we have the left foot of Archaeopteryx compared to that of a pigeon. And you can see that it's slightly more forward than what we see in modern birds. So it does have that kicked back toe, but not as kicked back as in modern members. Now, Hoatzin are modern birds that have clawed digits that are capable of limited movement as chicks. Because as you see oftentimes, there is immense debate. This is what I'll say about Archaeopteryx sort of in creationist circles. They can't decide whether this thing is a dinosaur or a bird. You have some members who are saying it's a dinosaur, and you have some members that say it's a bird. And you have some organizations like New Creation Blog who say birds are dinosaurs, but they didn't evolve from dinosaurs. Birds are dinosaurs in the same way that not all mammals are related, but they're still mammals, which I think is the most reasonable position a creationist can take on this. But when you talk to creationists who are like, Archaeopteryx is a dinosaur, has these dinosaur characteristics, sometimes they'll say something to the tune of, well, the clawed fingers don't make it necessarily closely related to dinosaurs because some birds can have clawed digits, like the Hoatzin. So here's an adult Hoatzin, and here's a baby Hoatzin here, a chick. These guys live in South America, and they're born with 2 mobile digits, not 3, 2 mobile digits. And these digits help them climb. The fusion of the second and third metacarpal, along with several carpals, forms a bone in most adult birds called the carpometacarpus. And that's what keeps modern birds from being able to actually flex their digits. In baby Hoatzin, they don't completely have that fusion, but it occurs as they age. So in baby Hoatzin, here's what their little wing looks like. They have this first claw here, they have a second claw here, and then this is where that third claw would be, but the third claw is not mobile. It doesn't seem to have the musculature to actually allow it to move. So it could move 2 digits as a baby, and it loses that ability as it ages, which kind of makes it an interesting stand-in for some of these transitional birds. Over here, we have a couple of comparisons. At the bottom, Deinonychus, which is a velociraptor-looking guy with these big grasping claws, a fully fledged, nobody disagrees this thing is a dinosaur. Then we have Archaeopteryx. Both of these guys have 3 grasping digits. Then we have Nothura here, which is a ground, I think it's a tinamous, or tinamu here, which is like a little ground-dwelling bird. And you can see that those fingers are fused. There's the third one fused with the second one, and the first digit is fused with the wrist bones down here. Then you have a baby Hoatzin here at the top, and an adult Hoatzin at the bottom. So where does Archaeopteryx fall on this? Well, it is more dinosaurish than the Hoatzin, even the baby Hoatzin, because it could move all 3 fingers, and all 3 fingers were capable of grasping. And it kept that ability into adulthood, because we have many specimens of Archaeopteryx, and some of them are adults. So we know that it kept that ability as it grew up. So the way that these things' hands looked is just absolutely a dead ringer for a raptor, for a dinosaur. Likewise, Archaeopteryx had asymmetrical flight feathers. So when feathers are symmetrical, they don't form a foil, so they're not as good for flying. But Archaeopteryx had modern-looking asymmetrical feathers that allowed it to fly. It had a shoulder that was more mobile than raptors that came before it, but not as mobile as birds that would come later. So here's Deinonychus again by my cursor, and then there's Archaeopteryx, and then there's a modern bird. And in Deinonychus, you can see that socket opens downward for that forearm or that humerus. And in Archaeopteryx, it opens directly out to the side, and it has this little sort of divot at the top and bottom, which would have allowed it to do a limited upward-downward motion. Whereas in modern birds, it's a fully saddle shape. So birds have that full modern range of motion, whereas Archaeopteryx had most of it, but not complete. Finally, here's a comparison of a velociraptor skull, Archaeopteryx's skull, and a modern bird skull. It looks more like a dinosaur than it does like a bird, but it certainly has that tapered snout that birds are known for, and fewer teeth that are not nearly as menacing looking as what we see in earlier dinosaurs. I really like to include this because this is Compsognathus, a dinosaur over here on the left. And then here's a chicken over here on the right. And then here's 2 different drawings of Archaeopteryx. One where it's holding its arms like a dinosaur, and one where it's holding its arms like a bird. And it could do both, as I said. Both of these are valid representations of Archaeopteryx's anatomy because it was capable of both. There's the skeleton of Compsognathus. There's the skeleton of Archaeopteryx with its arms like a dinosaur. There's with its arms like a bird. And there's a chicken. So Archaeopteryx does seem to fall into this middle ground point where it's got characteristics of modern birds and characteristics of dinosaurs. But there's more to it. So flight is interesting because the evolution of flight happens way after the evolution of feathers. Feathers show up way before flight does in the fossil record. And we know because to fly, you have to have a bunch of different musculoskeletal characteristics that are missing in feathered dinosaurs that are definitely covered in feathers. So this confirms for us that these structures didn't evolve for flight, but were co-opted for that purpose. And we're going to talk a little bit. Yeah, go ahead.
Hey, Eric, I'm so sorry. Did you just say there are dinosaurs covered in feathers?
Yes, 100%.
Okay, that I've not seen.
I can't wait to show you.
Okay, great.
So these guys, well, I guess it's going to depend on what you count as a dinosaur, but I think you'll be convinced. I think, would a T-Rex covered in feathers convince you?
Yes.
Okay. It's not a T-Rex, but it's very similar.
Okay.
So what are feathers for, right? Like if feathers didn't evolve for flight, because evolution doesn't have foresight, at least as a mechanism. Some people would propose that it's guided intentionally. That's fine. I don't have a beef with that. But as a mechanism in and of itself, it's not trying to evolve anything. So how do you get flight without trying to evolve flight? There are a couple of different interesting hypotheses. We're going to talk about why feathers evolved here in a minute, but I want to talk about flight first. So if you have a dinosaur that has a couple of feathers, how do you get flight from that? How do you get the keeled sternum? How do you get that mobile shoulder? How do you get the asymmetrical feathers? How does this kind of stuff come about? There's 3 hypotheses that exist for this. One is called the ground up hypothesis or the cursorial hypothesis. The second is called wing-assisted incline running, or WARE, and one's called arboreal, the arboreal hypothesis, or trees down. In the cursorial hypothesis, feathered dinosaurs evolve flight because flapping your wings while you're chasing prey lets you go a little bit faster, and it helps you jump to leap on top of the back of your prey, which is something that these guys were already doing. And they all already had hollow bones. As we're going to see, hollow bones is something that exists in T-Rex. So they were already very light animals. The WARE hypothesis argues that flight evolved because modern day birds flap their wings to help them climb nearly vertical surfaces, which, as you can imagine, is really helpful if you're a little critter trying to evade a predator. If you can run basically up the side of a tree trunk by flapping your wings, that's a massive survival benefit. And the last hypothesis argues that feathered dinosaurs used these feathers to help them glide or parachute. So essentially, they would climb up trees the regular way, the dangerous way, and then to escape predators or chase prey, they would jump. And by having feathers that they could spread, they could slow their descent, or they could even glide from tree to tree. All three of these set up some interesting hypotheses. First, all three of them have really interesting support in modern birds. So I took this picture from a pretty gruesome video of a raptor, a modern day bird, a modern day raptor, killing a monitor lizard. And what this bird does is it's trying to stay on the back of this lizard to pierce the monitor with its talons, but this lizard is moving and writhing underneath it. So to keep its balance, the bird flaps its wings. It's using its wings not to take off, but to stay on the back of this thing and to maneuver around on its back and kill it with its talons. Likewise, baby chicks use their wings, especially if they're tree dwellers, to parachute out of the tree long before they can fly. This is an ability that if you could do even before the evolution of flight would be super advantageous, because birds fall out of trees all the time. We used to have house sparrows set up in my childhood home, and every year these guys would fall out of the nest. And they would always be alive on the ground, downy and covered in little feathers, and they couldn't get back up into the tree. They survived the impact to the ground. There's some cute videos you can see of ducklings doing this too. But the funniest of these hypotheses is this one called the WARE hypothesis, the wing-assisted incline running, where scientists took baby chicks who also can't fly, of chickens and pheasants who are notoriously poor flyers, and they recorded them trying to climb up vertical surfaces, and they noticed that every time they use their wings, and that their wings are massively beneficial for them to climb up the side of these vertical surfaces long before they can actually fly. So all three of these provide really large survival benefits if you've already got the feathers present. So you need to have feathers to evolve flight, but flight follows pretty naturally from all three of these acting in tandem. And we would also expect to see fossil dinosaurs capable of doing all three of these things too. I would say, at least. The current hypothesis seems to be that it's a combination, that flight evolved due to a combination of all of these things, because the first feathered dinosaurs that we have in Archaeopteryx and some of these raptors are living in these really forested environments, and some of them can fly and some of them can't. So we're going to talk about Anchiornis here in a second, but this is a raptor that has feathered forewings or forelimbs, feathered wings, and then also feathers on its hind limbs. And it doesn't have that full upstroke. So it was definitely not capable of powered flight. It couldn't do it, but it was a killer glider, right? This thing could basically hold its arms and legs out and just go for miles. Whereas Archaeopteryx was capable of powered flight, but it wasn't very good at it. It could fly about to the level, what I saw when I was researching this is that it flies about as good as pheasants or quail do, which is to say pheasants and quail can't soar. They fly when they're flushed, when hunters are trying to kill them or predators trying to get them, and they go off for a little while, and then they land and rest somewhere. They're not going for more than 20, 30 seconds at a time. So the idea currently seems to be that flight emerges from a combination of all of these characteristics, all of these benefits acting in tandem. And I'll add, if you recall from talking about mutations and then natural selection afterwards, even a 1% survival benefit can select for a characteristic insanely quickly, let alone something like this, which would be a total boon for any animal living in these environments, especially when there's T-Rexes walking around. So there's Anchiornis. It's got those dead ringer feathers on the hind limbs, dead ringer feathers on the forelimbs, feathers all down the tail, feathers all down the neck, feathers all down the chest. And remember, this thing has all of the characteristics, or many of the characteristics, I should say, that define modern birds. It's got a wishbone. It's got the semi-lunate carpal. It's got that bipedal stance, the hollow bone, you name it. But it's not flying. It doesn't have that capability. There's Archaeopteryx, classic specimen. So while I was researching this, I saw an argument that I thought was interesting that I'd never seen before. And it argues that flight is irreducibly complex because in living birds, there's this structure called the triosseal canal. And the triosseal canal is this canal that's formed in the pectoral girdle, so in the confluence of all the bones in the chest and shoulders. And it's this little canal that the tendon of the supracoracoideus muscle passes through to attach to the top portion of the humerus here. So basically it threads through this needle to help birds pull their arms up and down, to help with that power stroke. Except this triosseal canal doesn't exist in several modern birds, including many of the flightless birds, and it exists partially closed in several fossil birds / dinosaurs, like in Archaeopteryx or these in Antiornithians here. That's my drawing to show you where it threads through. So Archaeopteryx and Anchiornis, all of these guys are members of a group called Avialae. And Avialae is characterized, generally speaking, by hollow bones, 3 clawed, non-fused fingers. This is a characteristic that no modern birds have. No modern birds have 3 clawed, non-fused fingers. And a semi-lunate carpal, which all modern birds do have. They have 4-toed feet, a non-keeled sternum. Sometimes it's bony, sometimes it's cartilaginous. All modern birds at least seem to have a bony sternum, whether it's keeled or not, depends. Their pelvis is mostly fused, but the pubis is variable. The shoulder's kind of mobile, especially in Archaeopteryx, but it's not mobile enough for powered flight in Anchiornis. They have a keratinized beak in some cases, but all of them at least have teeth and jaws inside that beak. They have a longer but more rigid bony tail, which no modern birds have. They all have an S-shaped neck. They all have a wishbone. They're all bipedal. All of the ones that we seem to find have feathers on them, unless somebody can tell me that, like, these structures aren't feathers, which I really don't think I've ever seen anybody try to do. They're all capable of either flight or gliding, and they all have those crocodile belly ribs or gastralia. So, compared to modern birds, stem avialans like Archaeopteryx or Anchiornis or Jahelornis have a less mobile shoulder, grasping clawed hands, a variable sternum and pubis, teeth, belly ribs, and long tails. They were also fully feathered, flight or gliding capable, and they all had hollow bones. Do you think they're birds?
That's a good question.
It's a great question. It's one that's like it's a really challenging one to answer. And this is why, you know, in my experience, when you look around to get sort of creationist perspectives on this, they're all over the place. Like you'll get people who, despite having virtually all the same characteristics, will tell you that these 3, some of them are birds and some of them are dinosaurs. Some of them will say all of them are dinosaurs. Some of them will say all of them are birds. But from an evolutionary perspective, they're both. They're birds and dinosaurs.
Yeah, where I'm struggling is I'm trying to think of modern day animals that we have an understanding of. And if we didn't and found their fossil, just their skeleton, what would we assume and what would we write about? What would we be wrong about, you know?
For sure. But the thing about these guys is that the bones themselves, the structures are the structures, right? Like how they use the structures can vary, but like what the bones are what the bones are. Like it's really hard to argue that an animal that has so many characteristics that define modern birds, including feathers, which used to be the characteristic that defined modern birds, but they also have hollow bones, a backward pubis, 4 toes on each limb, you know, a very paedomorphic looking face, but it's full of teeth, an S-shaped snout, and all the same bones, but just some of them are unfused in the hand and wrist. Again, that is statistically unbelievable if they're not related, especially because they appear sequentially through that geologic column.
Mm-hmm. Yeah, it's also hard to see size right now, so that's an important factor as well for me.
Yeah, that's the thing. Archaeopteryx is the size of a raven, but Anchiornis is like the size of a small dog.
Mm-hmm.
So these guys, but none of these guys are like car sized yet. We're not there yet, but we will be. So, avialans might be birds, might not be birds. Let's talk about Maniraptorans next. Here are some skeletons of some Maniraptorans. These you for sure know, right? You have Therizinosaurs, these gigantic, tall, menacing-looking animals with these huge arms topped with like meter-long claws. You have Dromaeosaurs like Velociraptor, and you have Oviraptors, who, the egg thieves, who have independently evolved this beak here, and they've got these grasping hands. They used to be known for being egg thieves, but actually it just turns out they're really good moms. So, what are the traits that define Maniraptorans? Maniraptorans have hollow bones, just like birds. Just like Archaeopteryx, they have 3 clawed, non-fused fingers, and some of them could tuck their wings. Others couldn't. They have 4-toed feet. None of them have a keeled sternum, but some of them have a sternum that's bony, like in Velociraptor, and some of them don't seem to have a bony sternum, but a cartilaginous one. The fusion in the pelvis is generally partial, so they don't have the bird condition in the pelvis. And the shape, the direction of that pubis is bird-esque, but not quite there yet. These guys could not flap their arms. None of these guys that I know of are capable of powered flight. They also have a really long bony tail, an S-shaped neck. Every single one of them's got a wishbone, just like birds do. They're all bipedal. At least in my discovery or my investigation of them, the overwhelming majority of them seem to have feathers. I couldn't find an example of one that wasn't proposed to have feathers. They walk on the ground, and they have belly ribs like a crocodile does. So
hold on a second. You're saying every Velociraptor found has feathers?
Every Velociraptor found has a forearm bone that has these quill knobs on them that only exist in modern birds to anchor feathers, to anchor, however you say it, panaceous feathers, these long feathers for display. Okay. I was unable to find any other explanation for them either. Like the secular literature just seems to be like they definitely had feathers, and I don't see very much. Actually, this, you might get a kick out of this. There's a creationist organization. I think it's out of AIG actually, who is now saying Velociraptor is a bird because of this in part. I can send you the talk later.
Yeah, it just seems weird to me because Jurassic Park, I know it's a movie, but they went out of their way to make known the dinosaur-bird link. So it's kind of weird that they wouldn't put feathers on the Velociraptors.
We didn't know at that time.
Oh, okay.
This was a much more recent thing. So can you see this bone right here? How this bone is like kind of beat to hell? Yeah. So a lot of bones are in really bad condition. And the reason is because, as you probably noticed if you've ever picked up a bone from like the forest or anything like that, the soil and bugs and the elements will eat away at that outer coating of cortical bone and slowly start to degrade it. So not every bone is in excellent condition. Some of them are really scrappy looking. I mean, I've done work out in West Kenya, and sometimes you'll pull out, the middle portion of a long bone, and it's just beat to hell. But when the surface of the bone is preserved, as they are in many, many, many Velociraptors at this point, they preserve these quill knobs. And not just Velociraptor. This one here is Dinobellator, who also has it. And then this little guy here, Epidexipteryx, who's a Maniraptor too, has not just these back feathers, but along its tail, it has these 2 giant plumes. To our knowledge, that I could find, all Maniraptorans had feathers. So this is Bapiosaurus. You can see there's the head. That is a dead ringer dinosaur head right there. There's the neck and the shoulder, and there are those feather quills coming right off the back of the head like a big crest. Bapiosaurus was not small. There's Velociraptor, and here's a close-up of those quill knobs that I was just telling you about. Those exist in modern birds only. There's Microraptor. I think that one speaks for itself. Gigantic feathers off the back of the arms and legs of Microraptor. And this is Sinornithosaurus, who is, it just looks like a little velociraptor with feathers that go all the way down its back. And also you can see the little feathers coming off of the arms there too. These guys also have that semi-lunate carpal. So it's not just that they had feathers on their arms, but they could tuck those arms. Even if they couldn't fly yet, they still were capable of tucking those arms like wings. So here's what the semi-lunate carpal looks like in modern birds. That's that carpometacarpus. So that's the basically like the fused wrist bone for these guys. And you can see it's got this pretty unique shape to it. And then here is a comparison of where that semi-lunate carpal shows up in Dinosaurs-to-birds and Deinonychus, who looks a lot like Velociraptor. There it is, right there. In fact, it shows up even before that. All Maniraptorans, except for this most primitive one, Falcarius, seem to have a fully fledged semi-lunate carpal for tucking their wings. I really like this study. Throughout evolution for birds, like from non-avian dinosaurs, the pelvis undergoes a lot of change. So the ilium, or the blades of the pelvis, has to get really long. The pubis shifts from being like kicked forward to being kicked back. And then there's a lot of fusion in that pelvis too to help stabilize the sacrum, or the sort of portion of the vertebral column that for us is like right where your lower back is. Or I should say right where your tailbone is. So this paper here is insane. So this paper is called "The Developing Bird Pelvis Passes Through Ancestral Dinosaurian Conditions." So in the egg, they're arguing that you can see the baby bird's pelvis pass through the stages during development of previous forms of ancestral dinosaur conditions, which is like interesting because this is an echo of ontogeny recapitulates phylogeny. So here's a raptor, or excuse me, here's Herrerasaurus, a really primitive dinosaur. Here's the pelvis. You can see my cursor, right?
Yes.
Okay, so there's the pelvis highlighted by my cursor. It's got that nice V shape there. And then here's the next one. That's T-Rex, should be really familiar. You can see that that pelvis has kicked backwards a little bit. There's Velociraptor, which has really, that pelvis is, or that pubis is like really kicked back. And then there is a modern chicken where the pubis is just completely fused with the back portion of the pelvis. And Rhahonavis, one of those early birds that I was talking about, where it's close to fusion, but not quite. So you literally see that pubis go from forward, directly vertical, kicked backward to fused through these dinosaurs, or rather Dinosaurs-to-birds. And then during development, here are scans, embryological scans of baby Japanese quail to show how that pelvis, here's the B is the baby quail, to show the orientation of the pelvis and how it goes through each of these dinosaur stages until eventually it arrives at the bird stage and then it's ready to hatch. I thought this was an insane paper. This is what I'm talking about like stuff that I didn't know that I had learned. This kind of blew my mind that you see this. And I should read this. The Japanese quail chicks undergo dinosaurian phases during development comparable to major preceding groups, suggesting the evolution of the avian pelvis was one of additive steps. So that's kind of an important point, because what the authors point out is that if this bird pelvis goes through these dinosaurian-like stages while it's in the egg, then that suggests that the way that you get a bird pelvis from a more basal dinosaur pelvis is you're just adding steps to development. And it's not nearly as complicated as it seems. And they've got a lot on the genetics as to what's actually expressing and where to get that form. This is a pretty recent paper. But what's neat is that they also have dinosaurs, like bona fide, like Maniraptor and dinosaurs, have behaviors that look like bird behaviors. So over at pterosaurs, like this guy, Citipodi, who's big, right? Like I hope you can see, well, that's actually Caudipteryx. This is Citipodi over here. These guys are like very large dinosaurs, like as tall as a door frame in some cases. But Citipodi was found brooding over her eggs over here. Like she was found literally in a hunched bird position, brooding over her eggs like a mother hen. And Caudipteryx, which is also very large and has this gigantic fan of tail feathers here in the back, doesn't just have these feathers on its back and also at the tip of its tail. You see this big wrinkly looking thing in its guts here? Highlighted by my cursor.
Yeah.
That is its gizzard, and it's full of gastroliths. So the only reason that this is preserved, the gizzard is obviously gone, but it's preserved because when it died and was fossilized, all the rocks in its stomach were fossilized with it because they were already rocks. And so this thing behaved like birds in the sense that it ate rocks to help it digest, which makes sense because it also has a beak. I think this one also blew my mind. It was pretty new. So this little raptor here, and a maniraptor named Maylong, a part of the group Troodontidae. So they're related to pretty closely related to velociraptors. They slept like modern birds do. So this is the fossil that they found of this baby dinosaur. It's not in an egg. This is just how it was sleeping. It was already hatched. And so it sleeps with its little head tucked up behind its growing, developing wing, and its little tail wrapped all the way around it. And we found more than one sleeping like this, which I thought was crazy because seems so rare, but we have at least 2 of them. And this is how modern birds sleep, with their little heads tucked behind their wings like that. So here are some comparisons compared to modern birds. Stem maniraptorans, spelled wrong down here, have a more rigid shoulder, grasping clawed hands. They had a variable sternum and pubis, as well as a big mouthful of pretty sharp teeth, at least for the dromaeosaurs. They have those belly ribs, and they have these big, long, flexible tails. They're also fully feathered, as far as we can tell, and equipped with hollow bones, as is everything else that we've already talked about. But it's important to note that these guys they don't just have some bird traits, they have a lot of bird traits. The next group is Theropoda, which is from 233 million years ago to present. This has some really sort of sexy classic dinosaurs in them. Within Theropoda is a group called Tyrannosauroidea, or the Tyrannosaurids, and this includes a dinosaur called Dilong, Tyrannosaurus rex, of course, and another dinosaur called Eutyrannus. Theropods have hollow bones, just like birds do. They have 3 clawed, non-fused fingers in most cases, with no semilunate carpal. So these guys could not tuck their wings. The raptors that were to come, they could, but these guys could not tuck their little arms or their little wings. They have an unfused pelvis, and their pubis is kicked more forward. They have a rigid shoulder. They've got big jaws with big teeth. They have a big, long, bony tail. But just like birds, they have an S-shaped neck. They have a wishbone. They have a bipedal stance. Some of them have feathers. Not all of them, but some of them have feathers. They're grounded, and they have those belly ribs. What's neat about their feet is that you can actually see moving through dinosaur evolution. Herrerasaurus is like a pretty older dinosaur fossil, and then Allosaurus is a bit younger, and Tyrannosaurus is younger still. And you can see the disappearance of that inner toe, or of that outer toe, and then that inner toe gets shorter and shorter and shorter until you see it's teeny tiny in T-Rex. This is an interesting bit that I've thrown in here. It's a little bit complicated. Basically, for a long time, there was this digit paradox in bird evolution. So dinosaurs seem to have 3 claws, and these claws seem to correspond to digit 1, 2, and 3. So if you were to compare them to us, it would be your thumb and your pointer finger and your middle finger. But modern birds seem to developmentally have digits 2, 3, and 4. So the question is, what happened here? Why do they both have 3 digits, but it seems to be the different set of 3 digits? To solve this, a hypothesis was proposed called the frame shift hypothesis that argued that one shift in expression genetically caused birds to sort of move the development from 1, 2, 3, and then you have a genetic mutation that it goes 1, 2, 3. And then you're expressing those next 3 just by a shift in expression. This was shown to be partially correct via experiment. In this paper called Evidence Against Tetrapod-Wide Digit Identities and for a Limited Frame Shift in Bird Wings. In this abstract here, they note that what actually happened is that you had this basal condition here with 5 digits, and then you have the dinosaur condition. And instead of being 1, 2, 3, and then switching it to 1, 2, 3, hopefully you're looking at my hands here because that's helping to make the point. What actually happened is you had 1, 2, 3, and then you had a shift that simultaneously got rid of the second digit. So it ends up being actually these 3 digits that are expressed in birds. So it was a knockout of this pointer finger digit. That's what they showed developmentally in bird chicks. And that's they argued that it's not a very difficult at all change to get. Do theropod dinosaurs have feathers like T-Rex? Yes. This is Sinosauropteryx. You can see it's got a mane of feathers headed down its back, all the way down to the tip of its tail. And I've included a close-up so you can see these little feather fibers headed down its back. D-Long, who down here is like a medium-sized T-Rex looking kind of guy, has these feathers preserved all across its body. This guy over here, Siriomimus, that's it, Siriomimus. I'm not even, Albertsdorferi, I can't say that, Siriomimus. Its name means squirrel mimic, and the reason is because it's probably obvious, it has this really long-looking squirrel tail, and this thing preserves feathers all along that tail, as you can see in this close-up here, these long, fibrous, little feather-looking things. The crown jewel, I think, for feathered dinosaurs is Eutyrannus. So Eutyrannus is like the size of a slightly smaller T-Rex. Like it's not quite the size of a T-Rex, but it's really, really big. And the fossils of Eutyrannus show us it's covered in little downy feathers. Not like flight feathers, like the kind that you see in an adult bird, but like fluff, like the kind that you see in a chick. And so the question was like, why is it covered in all this down, right? And the reason is because Eutyrannus lived in areas that experienced a full-on winter with snow and everything. These guys lived in conditions that had blizzards. And so this down actively kept these guys warmer, just as it does in living birds. Birds that don't have down die of exposure. Birds that do have down, chicks I should say, live. And so this down is covering Eutyrannus so that it can insulate itself from the cold, which is crazy. This is like the biggest dinosaur, as far as I can tell, that we have that had feathers. And it's like, again, it's not quite T-Rex size, but it's really, really big.
How are we determining feathers versus hair, like in the first one?
So feathers and hair have a different type of keratin, and they also have a different microstructure. So if you look at a hair and even a simple feather under a microscope, they're different. And they're also chemically different. So you can take chemical samples from some of these, and I'm going to talk about that in a second too. And you can actually recover the melanosomes that tell you what color they were in some cases. But the simple answer is that it's not hair because it doesn't have the physical structures that hairs do with like a keratin sheath along a long single strand. Instead, it's got these little tufty barbules that come off of it. And it's chemically beta keratin, if memory serves.
So we have like original biological material here?
Yep, I talked about that in our soft tissue discussion.
Okay. That's good. It presents a new problem, but it's good.
Hey, not when we talk to Fuzz. So, why evolve feathers in the first place? Like, why do these guys have feathers if feathers doesn't help them fly, right? Like, if feathers are for flight, why evolve them? And the answer is that feathers aren't for flight. Again, evolutionarily speaking, every step along the way has to be beneficial. You're never going to evolve something that has like a detrimental step in the middle. It has to be helpful to the organism in that moment the entire time. So we can ask the question, if feathers show up in the fossil record way before flight-capable dinosaurs do, why did they show up in the first place? And to get clues, we can look at living flightless birds and see, okay, well, like, what are they using their feathers for? And ostriches don't fly, but they use their feathers for display to each other, for sexual display and for threat displays. They also use them to shade their chicks. And in penguins, they use feathers to keep warm, like really tight, downy feathers are what keep them warm in brutal Antarctic conditions. Same thing in kiwis. So like feathers exist for a lot of different reasons and stick around in a lot of different reasons, even in flightless birds. But how do they actually like mechanically evolve? First, I have to share with you a couple of insane experiments. Scales, hair, and feathers all derive from the same basic cellular structure, placodes, which are these thickened patches of embryonic skin. It's weird, but they kind of like, if you see this little patch down here, that's the skin surface, And then you've got these little placode patches all across the surface when you're developing in the womb or in the egg. These thickened patches experience chemical signals as the organism is developing, and those signals are what tell them to become scales or to become hair or to become feathers, depending on, according to this paper, morphoregulatory models. These are biochemical signaling cascades that, as I said, are jump-started when the sperm meets the egg. Thus, the evolution of each of these boils down to, as they've outlined in this paper, very few actual changes. The difference between a scale and a feather and a hair are not that great. In this paper titled Transient Agonism of the Sonic Hedgehog Pathway Triggers a Permanent Transition of Skin Appendage Fate into Chicken Embryo, what they did is they turned off just a handful of genes and turned on a handful of genes, and they were able to turn the scales on a chicken's leg into feathers. Easy peasy, they say. They go, our results indicate that an evolutionary leap from scales to feathers does not require large-scale changes in the genome composition or in expression. Instead, a transient change in the expression of one gene, sonic hedgehog, can produce a cascade of developmental events leading to the formation of feathers instead of scales. And that's all she wrote. Like, a relatively few amount of changes gives you feathers, even if they're like relatively simple feathers, as you can see in this chicken's foot here, and in this mutant chicken with a specific chicken breed that is bred to have feathers on its feet all the time. What's cool about this is this sets up a pretty simple evolutionary pathway for those dinosaurs that we just talked about, like Eutyrannus, where you have all these dinosaurs that are living in an area that has cold regions to it. And all it takes is one of them to have a single mutation in its scales, which it already has, to develop into tiny downy coverings. And all of a sudden, that animal can handle way colder conditions. And it can go way further north than any of the other dinosaurs, hunt the prey that's there already, if there is any prey there already, or establish a territory there, get bigger, have more kin or have more offspring with more individuals, and then all of its offspring might have that characteristic too. And that's how you jumpstart these changes. To test this in an even cooler way, a different set of authors decided to take the feather genes that you find in chickens and put them in the closest living relative of the chicken, or of the bird group in general, which is alligators. And when you take the feather gene and stick it in an alligator, they develop proto-feathers that look like the simple downy coverings that you find in things like Eutyrannus. They form the simplest type of feather, which are these just little barbule strands that you can see here, and they express that beta keratin just like feathers do. They go over it in depth here in this abstract, so I'm going to read just a little bit here. They say, we identified feather-associated genes, and then they inserted them into, alligators, as you can see in the picture over here. And they go, in addition to molecules known to induce feathers on scales, we identified novel scale feather converters, which induce one or more regulatory modules guiding these morphogenetic events. Some morphotypes resulted in filamentous feathers, like the types found in feathered dinosaur fossils, whereas others exhibit characteristics of modern avian feathers. We propose these morphoregulatory models were used to diversify archosaur scales and to initiate feather evolution. The regulatory combination and hierarchical integration may have led to the formation of extant feather forms. Our study highlights the importance of integrating discoveries between developmental biology and paleontology. So, we can make a really simple prediction here, right? The earliest feathers that we find in the fossil record should look like those really simple feathers that we find in Eutyrannus or in the crocodile-induced feathers that we created in a lab. And they do. In this piece, this primer titled Feathered Dinosaurs from 2020, they go through each stage of hypothesized feather evolution. Mind you, these stages were proposed before some of these feathered dinosaurs were even found. And they go through how these guys are separated by space and time, and how the emergence of the modern feather appears slowly through these feathered dinosaurs. And I'm not going to go through them one by one because it's just a lot of reading, but there it is for you to check it out. And they've got these nice close-ups of the feathers. So you can see like they're definitely feathers, and some cool like chemistry on them. So some theropod dinosaurs had feathers, but what other bird traits do they have? Well, just like birds, theropods like T-Rex had hollow bones, they had an S-shaped neck, they walked upright, and I think most interestingly of all, they had a wishbone. T-Rex had a wishbone just like a bird does. So this is T-Rex's wishbone, this big boomerang shape on the bottom. And then directly above it, there's a chicken wishbone on the right and a duck wishbone on the left. It's a dead ringer. Oh, and this is proposed to be like a raptor. Or no, I think this is supposed to be a T-Rex, a bit of T-Rex long bone here on the left compared to an ostrich. So the traits that are bird traits that define theropod dinosaurs are actually the same traits that make them unique from other dinosaur groups. So when we say birds are dinosaurs, the reason birds are dinosaurs is because they have the characteristics that separate things like T-Rex from long-necked sauropods or from stegosaurs. Just like T-Rex, they have a wishbone, they walk upright, they have four-toed feet, they have the hollow bones, and they have the S-shaped neck, which are unique to theropod dinosaurs found in some. And birds, because birds are theropod dinosaurs. But there's more, because remember how we spent a lot of time talking about gastralia, those belly ribs? Belly ribs are found in crocodiles, and then they're found in every dinosaur and almost every bird until you get up to modern birds where they start to disappear. But it's like, if you want to say Archaeopteryx is a bird, it's got belly ribs, just like a T-Rex does. If you want to say Ichthyornis, the very first bird-looking thing that's extinct that we looked at, it's got belly ribs like a T-Rex or like a crocodile does. There's another cool prediction we can set up, though, because compared to modern reptile relatives like crocodiles, modern birds have fewer sacral vertebrae. So the sacral vertebrae are down here, vertebrae, I should say, are down here. The sacrum, again, is the sort of back portion of your pelvis. Here they are in the crocodile. I'll highlight them in red so you can see them. Sacral verts there, sacral verts there. The most primitive dinosaurs have 3 sacral vertebrae. Modern birds have 11 to 23 sacral vertebrae. So if birds descend from non-avian dinosaurs like T-Rex and its kin, we should see that sacral vertebra number increase as we move through the evolution of these groups, right? We should see it tick up and up and up. There's our modern birds with 11 to 23 sacral vertebra. There's our stem ornithorans with 11 to 23, just like birds, no problems there, except for the fact that they have gastralia and teeth. Then there's our stem pygostylians with 7 to 10, we've already reduced. Then stem avialans like Archaeopteryx who have 5 to 6. Then stem maniraptorans who also have 5 to 6, so Archaeopteryx and Velociraptor have the same number. Then T-Rex and its kin who have 5 to 6 too, meaning that we see the emergence of the bird condition through the evolution of dinosaurs to modern birds. I mentioned that soft tissue earlier. Here's those 2 papers. I pulled this slide directly from our conversation of the age of the Earth, so you could go take a look about it for yourself. Molecular evidence of feathers with direct evidence from fossils. This is Anchiornis again here, this little raptor-looking guy. We've been able to pull melanosomes from some of these feathers from these guys. Same with preservation of corneous beta-keratin proteins in Mesozoic feathers, to the degree that we've been able to recreate the color that some of these guys were, because melanosomes preserve pigment, right? In the same way that that hair preserves pigment. And so we know the actual color of the feathers of some of these dinosaurs. And like, for what it's worth, there have been some scientists, mostly Alan Fiducia, who over the years have proposed that some of these feathered dinosaurs, when they were first coming out, that the feathers weren't actually feathers, but they were collagen, like just decayed like collagen fibers. And the reason is because he pulled up some fossils like ichthyosaurs, which are like swimming, marine reptiles, and sharks and things like that. And he pointed to some fuzziness that you could find on these fossils. And he was like, how do we know these feathers are feathers instead of just frayed collagen? And so the researchers were like, really good point. Obviously, they weren't doing that in the case where you could see the full feather, but in the case where there was like just a little bit of fuzz. And so they were like, good point, let's test it. And that's when they found out that these things carry melanosomes, because it's like collagen doesn't have pigment in it, only feathers do. So that's how they figured out in part that we were looking at actual feathers here for some of these more ambiguous ones.
Now, can you go back?
Yes.
Two things. If we're talking about the two, well, I guess three that are pictured there, those look like birds to me, not dinosaurs. And do you know, is Alan Fiducia still pretty ardently against this idea of birds from dinosaurs?
He thinks they come. Yeah, I think he is, but what he has done is that he's admitted that there are feathered dinosaurs.
Okay.
But what he does is he says if it has feathers, it's a bird. So he thinks Velociraptor is a bird. He thinks that like all of those guys, all of I'm gonna like take us way back. All of these guys here that are shown to have feathers, all of these Troodonts, Bambaraptor, Velociraptor, these things that are just like really obviously dinosaurs. If they're found with feathers, he says they're birds because he uses the presence of feathers to define a bird, which like, I don't think it's surprising that when I looked, I have not seen him talk about Eutyrannus because that's going to be a pretty hard sell, or Caudipteryx, for example. I mean, this guy is huge and it's really hard to, do you think this is a bird?
What's the size?
It's like the size of a doorway or bigger.
Yeah, that'd be tough to think that's a bird with that being that big for sure.
Let me, at the end, I'm going to pull up some size pictures just so you can see. Like some of them are flipping huge. Yeah, Eutyrannus, that's going to be a hard sell. Oh, D-Long too. Anyways, what I was saying is that some people like Alan Fiducia will make the argument that he can still say that birds don't descend from dinosaurs, but some other closely related archosaur. But the problem with that is that like he published this really recent paper. I actually used one of the figures from one of his papers in this presentation. One of them was on hips. And in it, he's like, birds, we know that birds are not dinosaurs because birds have a partially open acetabulum or hip socket, and dinosaurs always have it fully open. And it's like, if that's what you're hanging your hat on, I don't know where we're at. Like, because birds do, like, that would just mean a chicken is a dinosaur, but like a rhea isn't. You know what I mean? Like, it's a weird deal. And I think he still holds to that. So I think the question is really clear here. And this is my challenge to you for the next one. I would like to see you, if you don't think that birds are dinosaurs, I would want to hear from you. How can you define a theropod dinosaur in a way that does not include birds? Because all of these guys have hollow bones and an S-shaped neck and four-toed feet, and they all have a wishbone, and they all have warm blood, and they all, for the most part, have feathers, with the exception of some theropods. But birds are also, actually, we'll put a pin in that for a second. This is what I wanted to ask. Which of these groups are birds and which of these groups are dinosaurs, right? Like, I think that's the challenge for somebody who doesn't think birds descend from them, because you have to be able to draw the line. I think that's reasonable. I would also like to point out that there's another step, which is that birds aren't just theropod dinosaurs. They're also dinosaurs generally, because the way that we define dinosaurs, or members of the group Dinosauria, is like so. Dinosaurs are distinguished from other archosaurs like crocodiles or turtles by having an open hip socket or acetabulum. This is a crocodile over here highlighted by my cursor. There's the acetabulum. It's closed. That means if you look into the hip socket, you can't see through it to the other hip socket, right? The two femora aren't looking at each other or are separated from each other when they're in the hip socket. Like, we have a closed acetabulum. Then this is a big sauropod long-necked dinosaur. That's that big open acetabulum. You can see it. It's marked by the letter A. And this is a bird acetabulum here. Open, a chicken, just like in a long-necked dinosaur. Birds also have their legs below their body, which is a characteristic that defines all dinosaurs. They don't have a sprawling stance compared to a crocodile whose legs are kind of out to the side like that. And all dinosaurs have at least 3 sacral vertebrae, which obviously includes birds, who have 11 to 23 of them. So birds are dinosaurs in the same way that whales are mammals. That's it. That when we say that birds are dinosaurs, we're saying they're dinosaurs in the same way whales are mammals. Because the way we define a mammal is a mammal has hair and 3 bones in the middle ear and mammary glands to feed its babies in females. Whereas in dinosaurs have an open acetabulum and they walk upright and they have at least 3 sacral vertebrae. So do birds. That's what's being said here. So if birds evolved from non-avian dinosaurs over 150 million years, we should be able to check off all of these, and I think we do. The closest living relatives of birds are crocodilians and turtles. Many birds share features with non-avian dinosaurs, but the non-avian dinosaur traits can often be seen developmentally, like their little hips just go through evolution in the egg. We also see the emergence of the traits that define modern birds in the fossil record over geologic time, and we can pinpoint the specific genetic changes or pathways for the evolution of key characteristics that define modern birds by modern theory or by direct experiment. We can induce proto-feathers in crocodiles. I think it's obvious genetically and from the fossil record. This is a really, really great graphic that was provided to me by a friend of the channel. I don't want to dox him because I haven't gotten permission, but he sent an email when he found out that I was doing bird evolution. And he provided this example of the evolution of birds with the characteristics emerging at these little hash marks along the side that define each group. And he shows the microevolution from species to species, and then the macroevolution at sort of the big scale, like a zoom out. So the characters of bird that define modern birds appear slowly over time, accumulating as groups specify. So finally, I'm just going to say, if birds didn't evolve from non-avian dinosaurs over 150 million years, it really looks like it. In the same way that, like, it's hard to explain why extinct whales have the ankles of deer, or why ancient little deer have the ears of whales. It's hard to explain why birds have so many T-Rex traits and why T-Rex has so many bird traits. Last thing I'm going to touch on here is like what happened to the non-avian dinosaurs, because they're extinct, they're gone, they're not here anymore. And yet, like, avian dinosaurs are still here, the birds are still here. So conventional science, as you probably know, argues that non-avian dinosaurs went extinct about 66 million years ago. And the current literature says that this is due to a combination of major impact event, so like a big asteroid or comet hits the surface of the Earth, as well as mass eruption events in the Deccan Traps of India. These two things sort of go hand in hand, but certainly the impact played a large role. And the survivors of this mass extinction are like almost exclusively tiny-bodied, which is like small-bodied burrowers. So animals that spend time in the mud at the bottom of rivers, animals that spend time in burrows made in the earth or in the sides of mountains, things like that. And the reason we know that is because, like, they have these characteristics, and sometimes they're found in their burrows right after the dinosaurs go extinct. What is the evidence for this? I was so interested in one of our first meetings when you said that you'd heard that there's no picture of the Yucatan crater, of the impact crater. Because I was like, I feel like I've seen pictures of this crater before. And I have, but it's complicated. And the reason it's complicated is because the impact crater is underwater and also underground, because it happened 66 million years ago. The way that we found it in the first place was when oil drillers were drilling in the Gulf of Mexico here, and they kept pulling up this material called shocked quartz. And quartz only takes on this shocked condition when it is suddenly exposed to massive amounts of heat and pressure. So when they found the shocked quartz, they were like, this is really weird, and like we keep pulling it up. That spurred that sort of confirmed the Alvarez hypothesis, which was that, okay, well, maybe what we're looking at here is a crater. So that forced people to start to pay attention to the Yucatan Peninsula. After that happened, and over the years, the crater has been mapped by, this is a picture of it here, using subsurface scans, so using like seismic sonar, using geophysical techniques, including like looking at gravitational anomalies in the area and using magnetic scans, as well as taking big cores, drilling down into the earth and taking cores and mapping how the cores change as you move in and then outside of the crater. And all of that together creates a really good picture of exactly the size of this crater, where it is, and what it looks like. But I think it's the most clearly modeled just by this subsurface scan. So this is a complex crater, and the reason why I say it's a complex crater is because it's got this bullseye pattern. which is exactly like this Euler crater on the moon, which is also a complex crater that has a bullseye pattern. As far as I know, and I did the thing that you said you did well, where I specifically sought out creationist explanations for the Chicxulub crater, because I was like, this looks like a picture of the crater. How do they deal with this? And what I found is that a lot of them, including Andrew Snelling, I think, are just like, it's a crater. But that doesn't mean that it's responsible for the dinosaurs to extinction. Like there have been impact events in the past 6,000 years. That doesn't necessarily mean it's the one that did the dinosaurs in. Tim Cleary argues that that it looks a lot like a crater, but maybe it's different features are explained by other things, but he doesn't propose what he thinks those things are. I hear you wanting to say something. Please, by all means, try not to.
No. I'm glad you looked into this. I haven't looked into it, but I just heard what I heard, and it was fascinating to me.
I was curious.
And by the way, I'm not nitpicking this at all, but I wouldn't consider that green and blue thing a picture.
Really, it's a seismic scan.
Yeah.
I find that curious. You don't find this kind of subsurface scan except anywhere else except for in craters.
I'm not saying it's not a scan. I'm just saying it's not a picture.
I find that surprising, but because to me, that looks like a picture of a crater. But I have a couple of more things that might be a little more helpful.
Well, sorry, I'm not even trying to push back that it's not a crater. I'm just saying I wouldn't call it. I'd call the moon one a picture, but I wouldn't call the green and blue one a picture.
Okay, maybe this is where the disconnect is. So my dad's an interventional radiologist, and for me, when CT scans are explained or like X-rays are explained, it's like taking a picture inside your body. You know what I mean?
Mm-hmm.
They're not actually pictures.
Yeah.
But they're pictures. You know what I mean? Like you're using geophysics to take a photo. You're using the way that sound and gravity works to get an image of what it is.
Mm-hmm.
But let me do you one better, because I think, to me, for me, straight up, I find that convincing enough, but I actually think it's more convincing to look at like the non-actual crater itself lines of evidence, which is mainly this gigantic layer of iridium. So this is an element called iridium right here. It's this really pretty shiny metal, and it's really rare on Earth, but it is very common in meteors, like in crazy high concentrations in most meteor types. And this iridium is found in a concentration like, I can't remember if it was 30 or 300 times the background level in this layer that is universally found across the entire world, this layer of iridium. And underneath the layer of iridium is the entire Cretaceous, and there is not a single dinosaur bone found above this layer that I could find. And I looked in the literature. So you have an element that is found not only, but almost exclusively in meteorites. And you have a layer of it found globally that separates out the last dinosaurs from everything else. There's somebody else pointing at it there. Mm-hmm. What's also interesting is that found within this iridium layer, and then also at dinosaur sites, are these little beads of superheated glass called tektites. And tektites form when molten earth is thrown up into the air and cooled really quickly in sort of the space of the atmosphere. And then it falls back down. I was unable to find any other way that we get tektites. And yet these tektites are found in this iridium layer and all over dinosaur sites dated to really right at that mass extinction time frame. And then I found this paper that dated specifically rock from the Chicxulub crater, the melt rock from the crater, and the tektites that are found in the iridium layer all over the world. And they all date to the same time. And that time is like 65, 66 million years ago. That's like about as smoking gun as you can get for this being an impact event. I mean, here you have ones from Haiti, ones from Mexico, and ones from Saskatchewan, Canada, and they're all giving the same date with multiple analyses and multiple labs running this analysis. So I'd love to hear an alternative hypothesis for this one.
Yeah, this that is a good argument that I would want to look into. What I don't understand is why the avian dinosaurs survived. That really doesn't make sense.
The very first birds that we find in the fossil record after the mass extinction event are about the size of like a quail, and they're aquatic. So they're found like little tiny aquatic, partially aquatic, like almost like duckish looking things. And their ecology, as I understand it, reconstructed from their paleo environment, is that they lived inside burrows in the sides of rivers. So I don't know if you do like a lot of river walks, but like sometimes if you walk along the river, especially rivers that have tree roots that like penetrate around the side, you'll find hollows and cavities that little animals and little critters live in. And I thought that was really interesting. So I was reading a little bit more about it because I'm thinking to myself, okay, you know, you've got this mass, you've got this insane amount of heat and destruction. Like, how's a little bit of dirt going to protect you? Except we find like burrows of mice, like little mice and rat critters, rodents, at like testing sites from when we were developing nuclear weapons. And just a tiny bit of earth shields virtually all of the heat and radiation out, just by virtue of the direction of where the heat and radiation is sort of moving. And I thought that was insane. And also, the only other place you find shocked quartz that we find at the Chicxulub impact crater is at nuclear testing sites. So like, I couldn't find examples of us finding shocked quartz in like volcanic eruptions. You know what I mean? But you can get them from nuclear events. So like that, I don't know. I thought that was interesting. I don't think that necessarily says anything, but I thought it was interesting.
Is the hypothesis then that the birds stopped flying for the rest of their lives?
Well, they weren't. No, they could still fly, but they weren't
because this event this event affected the air big time, and so I think that would have killed them. Like that, like we have the phrase "canary in the coal mine," because birds are going to die if something's wrong with the atmosphere. And this theory is that it affected the atmosphere of the entire world, which is how that iridium layer was spread everywhere.
True, but it's not like it's not poisonous. You know what I mean? Like, it's not something that it can choke you to death for sure. Like, if you breathe it in, it can choke you to death. And we found fish like sturgeon and gar in Hell Creek, and in Hell Creek, I think it's actually in Tanis or Taunus, however you say it, like the site near Hell Creek. And they're found with tektites, those little glass beads in their gills. You know what I mean? They're too close to the impact event, and it wiped them out. But I think that if you're in a burrow for that initial impact, in the same way that a rat can survive, you know, the a Manhattan Project, like the Trinity test, in the same way a rat can survive the Trinity test by being underground and then coming out afterwards, I think you're good as long as you survive the initial event. And we know that they did survive the initial event because the fossil record is so rich, because so much stuff is dying from right around this time period. And there's so many catastrophic events that this impact event triggers. I mean, it's to put it into perspective, the asteroid impact that created Chicxulub crater, to create a crater of that size, it was about the size of Mount Everest. I mean, we're talking about a rock the size of Mount Everest that slams into the surface of the Earth going the speed of a bullet. And when it does, it vaporizes basically the second it hits the surface, which is why you also don't find a meteorite. It's just the impact. When you simulate this kind of thing using what we know about meteorites today, it immediately vaporizes, which is how you get iridium all over the world. I mean, I don't know if you know about actually, yeah, you do. You know about like Mount St. Helens. When Mount St. Helens erupted, we got ash all the way in the Midwest from that. Mm-hmm. And so if you have something like this, you're going to get, just by virtue of the atmosphere turning, you're going to get iridium all over the world. And how creatures survive is that if you can survive that initial blast, everything is dead basically when you come out, except for really, really small insects, which incidentally are what small mammals that were living around the time of the dinosaurs ate. We know because they have the type of teeth that are used for puncturing exoskeletons, which is why they survived, because they were burrowers and insectivores. But the other thing that survived was ferns. Ferns are weirdly robust. And so critters that were capable of eating and exploiting ferns in portions of the earth that weren't immediately in that impact zone survived too. Now, none of them could be very big because it wasn't like entire forests survived. But you have these copsy little patches of ferns that were capable of withstanding it, which we know, and withstanding the aftermath, I should say, which we know because we have sites that preserve this even after the impact. And the only animals that are in the site are like tiny. Like everything that survived was like, it took hundreds of thousands of years, if not millions of years, for life to get big again after this mass extinction. It's really crazy.
Well, you've definitely tickled my catastrophism fancy.
It's a catastrophe. This is a catastrophe for sure. In fact, there's I made a video here on YouTube about the 5 biggest mass extinctions, because there's 5 times that have been like this, that have just been as bad as it gets. But I think you have to think from a creationist perspective, from a young Earth creationist perspective, I should say. How do you make sense of this? If you're an old Earther, sure. I mean, you'll find Discovery Institute, Reasons to Believe. They're like, yeah, obviously this is an impact event. Yes, this wiped out the dinosaurs so badly that God essentially has to come back in and repopulate the Earth. But I don't know. I find it. I think people have their work cut out for them to make this make sense in a single year of the flood, especially given the time that it would take to recover from it. You know what I mean? Anyways, last slide. If the support for so many mammal groups and birds can be demonstrated, the support of their evolution, what's out of bounds? And I have to ask too, for when you respond to this, because I know you will. I think that it is totally paramount to find that line, right? To say, here's how you tell a bird from a dinosaur. Because when you have a bus-sized looking T-Rex covered in little down with a wishbone, what do you do with that? How do you place that? Anyways, shall we do these super chats, or do you have any questions?
Let's definitely do super chats.
Let's do them.
Before
All right,
I
folks.
expire.
Before you what?
Before I expire.
I know it. We got from Doc Dino, question for both. Do either of you think you could take a Deinonychus in a fight? My favorite dinosaur and a super important genus for this whole discussion. Also looking forward to tomorrow, Will. Oh,
Yeah,
are you guys chatting tomorrow? Cool.
We are. We are. We're chatting about Mark Armitage.
Interesting.
Yes. So
okay.
I'm super excited for that.
All right, hold on here. Let me see here for a sec, Will. And I feel like you need to see what a Deinonychus looks like to know whether or not you would take one in a fight. You think you could take one of those in a fight? Not me.
I do not.
I'm toast in that kind of situation. All right, stop that shared screen. Thank you, Doc. From Real Richie Estrada, for $10, Eric, I enjoyed your April segment on how psychedelics coincides with human evolution, except it doesn't. Will you ever do a long-form video on the subject? Do you or Will have any fun drug stories? Man, I don't do any drugs. I don't smoke. I smoked marijuana in college, but I don't anymore. I had a paranoid episode, and it became too much for me. But yes, I'll probably do a Stone Date video eventually. Will, fun drug experience that you want to share?
No fun drug stories. I've never tried marijuana. I don't even drink alcohol, so a little boring.
He's a meat guy.
Yes, that's right.
From Rob Squared for $5. Oh snap, learning. Will, question, when's the final experiment for moon landing deniers? When are you going to the moon?
So no plans to go to the moon. I actually would not go to the moon. If anybody's wondering, that is too much of a risk. I'm not willing to take that risk. That's terrifying for me.
Kindred spirit. I'm also scared of space.
By the way, moon landing deniers, I think, all have one thing in common. which is, this word has a really negative connotation, but it doesn't have to be, but it's ignorance. They don't understand something, whether it's they don't understand photography, they don't understand rocket science, they don't understand size and distance. It always comes down to ignorance for all moon landing deniers. That's what they all have in common.
We have from Bugmaster8647 for $5. Of all the fossils currently recognized by mainstream science as transitional, what percentage do you think are fraudulent, misidentified, etc.? If this is a question for me, I think it's probably for Will.
Yeah, I think it's for me too. So I don't know what this list is comprised of all the fossils recognized by mainstream science as transitional. In terms of fraudulent, I think that the fraudulent cases have reduced significantly from the past. Misidentified, I think, is very highly likely. Like I was thinking about something this week, which is that when I was on my whale trip, they did a whale talk on the evolution of whales. Now, it paled in comparison to Erica's, but they said something at the very beginning, which I loved. And they said, whale science is pure speculation. They said, we can never truly understand what's in their mind. We can never truly understand why they do what they do, why they don't do what they do. People might find this so fascinating. I do. The humpback whales in the entire Atlantic have a song they all sing. No one knows how they all get it. And every year they drop off the ending and add a new beginning, and they all know it every year. So there's 3 parts to the song. 2 parts are from the year before, and it just keeps moving down the chain. They just don't understand. So in terms of misidentification, I think there's clearly going to be misidentification, because there's something about the past that is inherently difficult, which is we can't go back and understand what happened in the past. So we have to try to figure out with what we have, what happened. But I think we always have to be aware of that limitation.
I think that's a good answer. From Sylvan Epiglottal Stop for 100 Argentinian pesos. I know evolution and biogenesis are real because no loving God would create Cotyledonous. Have you seen this guy?
No.
You're going to love this. This animal is crazy. This is a little mammal-like reptile that had that size of a head. This poor dude, right? Is that not the saddest thing? I love it. I think it's adorable. They just don't make them like this anymore. So true.
I want to know how this person knows what a loving God would do or not do. That's my super chat back.
Oh, they're yanking your chain. We got Russ Falconer 7917 for 10 pounds. Whales undulate their spine up and down when they swim, but fish move laterally side to side. This suggests that whales evolved from land animals and kept the same basic way of moving their spine.
I concur.
It's wait, what'd you say?
I don't understand. I don't see land animals undulating.
So you know when have you ever seen an otter swim?
Maybe, I can't recall it.
When they swim like this. So they move their body like an up and down little snake, kind of. Same with seals. So all land animals, when they get in the water, like none of them swim side to side like a fish does. They all swim up and down, which is argued to be support for the heritage of cetaceans. We have Coffee Slipper 555 for 10 euros for Erica. How do you feel about one of your mods insulting people in chat, me, and threatening to ban them for absolutely no reason, not even apologizing? Was looking forward to the stream, but no. Coffee Slipper, I pay zero attention to the stream because I can't when I'm posting it. So I will look into your assertion here, but outside of that, I cannot say anything. Thank you for the 10 euros. If you have been wrongly booted, I will investigate it and rectify it. If not, then I don't know what to say. Thank you for the super chat. From Petite Flowers 5259 for $20. It's trivially easy to cherry pick the data to find so-called problems, but it's not an honest way to come to a conclusion. There's a reason actual experts look at all the data points supporting the consensus. think that one's for you, Will.
Yeah. So I don't really know how to respond. Here's what I'll say is that you're never going to win me over by appealing to a consensus. Never, 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 never. So if people want to just take whatever is the consensus and believe it, go for it. But if you look back through history, you're going to be wrong so much of the time. Let me give you guys a really cool story. There's a guy named Dave Feldman. This is cutting edge stuff. It hasn't really reached the mainstream yet. He's an engineer. He is not a scientist. He's not a doctor. He has no medical degrees. He is completely upending LDL cholesterol. He is stating that he can prove every single person in the medical community is wrong about LDL cholesterol. And he's done it. And he's done it by taking his own blood every single day. And there's a new documentary he just came out with last week called The Cholesterol Code. That stuff I love, which is doing real science, challenging the status quo. And I think at the heart of science should be challenging the status quo. And so the other issue is that I quoted experts in my presentation at the beginning, and those are all people who disagree with me and who are not creationists and who support evolution. And they're experts too. So when we get to this game of like putting experts on a scale and saying which side tips, that's just not going to do it for me for what it's worth.
I think rather than, I mean, I agree that brute expertise, it's relatively fallacious. However, I don't think it should be taken as a rule, but I do think that it holds some weight. For example, let me give you an example that's going to hit home for you. I'm not a biblical scholar and I'm not an archaeologist, but when I look at the arguments for whether or not Jesus was a real person, I see a ton of people saying the answer is yes, Christian or otherwise. And I see a handful of people saying the answer is no. Knowing nothing about the subject, I err on the side of consensus because, not being an archaeologist myself, I'm wagering that all of their expertise is going to get closer to the truth than not, unless I'm presented with a reason to believe otherwise. So I hope that you sort of take that the same way, as a guideline, but not a rule.
Yeah, I think it's a good starting place. The problem is I think people pick and choose when they're going to follow a consensus. For example, they surveyed biologists. Wait, was it biologists? Yeah, I think it was biologists. I'm forgetting. I wish I didn't forget. And 95% of them say that life begins at conception. And getting people to agree with that is like pulling teeth. And I know from personal experience.
Yeah, I mean, I think that's wild. I don't know anybody who would say otherwise. I think that people will argue whether life and personhood are the same thing, but life beginning at conception, that's a biochemical thing. So I find that shocking.
Exactly, I agree.
We have from Rosina for 562. Did I infer correctly that Will isn't too familiar with Kent Hovind? The YEC so bad that big YEC orgs tell people to ignore his arguments.
Okay, so no, I am familiar with Kent Hovind. In my opinion, he has completely ruined his reputation. And I'm sorry, he has. There's too many issues with, I'm going from memory here, but I think there's issues with fake degrees at fake schools. There's issues with evading taxes. There's issues with some sort of, verbal abuse, maybe other types of abuse of spouses, jail time. I just think he's ruined his reputation. So what I want people to hear, and this is actually me trying to kind of help you guys a little bit, is that when I see debunking channels, and again, Erica's excluded on this, she talks about Kent Hovind the least. But when I see these channels focus on Kent Hovind, I see them as looking for who's the easiest guy to put down versus going after the top arguments. So again, excited but not surprised that Erica is already going through Carl Werner stuff.
You'll probably be getting an email from me where I'm going to take the picture, because again, I don't have the hard copy of his Well Evolution stuff, but I'm probably just going to go through that section of his book because I'm not there yet in my reread, but I think it's worth going through. And I think his stuff is worth going through. Here's one thing I will say about Carl Werner. His pictures are gorgeous. The pictures in these books, some of the photos in them are really, really good. However, big asterisk, those pictures are being used to say things that are, at least when they're in my area, not true. But that doesn't mean that he doesn't deserve to, that doesn't mean that you shouldn't go through it with a fine-tooth comb.
Also, I'm going to ask him permission. He has a separate piece on whale evolution that I'm not sure he's published that I'll ask him permission to send to you.
Yeah, I would love that.
It's
I
like
really would.
It's like an addendum based on the new stuff that's come out.
Yeah, that would be really great because if memories, you correct me if I'm wrong because you probably looked at it more recently, but he mostly covers like the classics, but there's some pretty significant transitionals missing that I would like to see that I don't think I have in my copy.
Okay, great.
From Bugmaster8647 for $10. Will, I think you're very good at finding inconsistencies in the evidence for evolution. If you applied the same diligence to physics or astronomy or chemistry, would you be able to do the same?
Maybe. I don't really know. Yeah, I don't know. Tough to say.
We have from Rossi for $10. Will, you accept microevolution? If instead of looking backwards in time, we look forwards in time, what limits on evolution would you expect to see over millions of years of microevolution?
Really good question. I've never thought about this, but let me think. Okay. Here's a good one. I have a son who has an extra tooth. Okay. And I've been thinking about this because of you, Erica, and because of evolution. It is a freaking disaster. I'm telling you right now, it's a freaking disaster. He has one extra tooth, okay? And it's a mess. It's an extra baby and an extra adult. And the nightmare that this is causing for his mouth, his future, his life, like what we have to do, what we have to spend is like crazy. And of course, we're going to do it because we love our son and we want to have the best life possible. When I look at that, which is now looking forwards in time on a present day event, one extra tooth is such a disaster. When we talk about evolution, we're just like, oh yeah, they had teeth, but then they started losing them and now they don't. Now they just have a beak without teeth. Like, I'm like, I can't picture this. Like, I can't understand how you could ever lose teeth and be okay. Or gain teeth and be okay. So it's difficult. So when I look forward, I struggle to see how if one extra tooth is going to cause this many problems, how we're ever going to get somewhere else. So that's my thoughts.
I think that is a great point, but I think it has to be contextualized in all of the data. Because you're right, one extra tooth, that could be horrible. In fact, even things that seem really, really good could be horrible. Like, let's say you have a population of people living in like a desert, like they're a desert sort of tribe of people. And you have one person who's born with double muscling disease or double muscling syndrome, which causes, when it's found in other mammals, you're extra beefy. Like you've got these huge muscles, you're really strong. That sounds great. That sounds like that's going to be really helpful because you're twice as strong as everybody else. Except muscles take a lot of energy to fuel. And if you're living in a tribal situation where food is maybe come and go, that might end up dooming you because you might have one slightly longer drought, you don't get enough food, and you thus die of starvation way faster than everyone else because your body takes more to fuel it. However, if that same person is dropped into a situation, maybe like a rainforest type environment where food is abundant all the time, you can very easily see how that beefy guy is going to get all the ladies and every one of his kids is going to have that characteristic. And then that is going to come to eventually characterize the population. So in the case of this extra tooth, an impacted tooth is a bad thing. Period. Like impacted teeth cause problems, right? But double muscling disorder doesn't always cause problems. Lactose tolerance doesn't cause problems. Bone density increases don't cause problems. Being able to hold your breath longer, like a more efficient spleen, doesn't cause problems. Sometimes even people are born with like extra fingers, for example, like they have polydactyly. It causes them no issues whatsoever. But it also doesn't give them a huge benefit, right? So like we wouldn't expect for it to go in any direction. It is completely at the mercy of one, what it does to the individual, and two, the environment itself. So I mean, we're seeing this in real time with the elephants that I mentioned, right? Where they're like losing their tusks, which is a bad thing, except if you exclusively hunt elephants with tusks, in which case it suddenly becomes a good thing because maybe you're not protecting against predators as well, except for the main predator that will kill you instantly if you've got big, beautiful tusks. So this
Right.
context is super, super important. The selection stuff is the backbone of this, which is, why I went over it first. So I think if you're sort of questioning, like, how do these things arrive and then proliferate into the population, think of those anoles. In one generation, the toe pads of these anoles got gigantic, like twice the size or whatever, which doesn't seem like a big deal unless you look at their little hands and see the actual difference. Or the big beefy heads of the Podmercaru lizards, or the rats or the pocket mice that completely change color. I mean, there's a lot of stuff that gets passed over in the singular examples. And I think you have to keep the big picture.
Mm-hmm.
From Rosina for $1.99, Catarrhine monkeys remain gorgeous. So true, Rosina. Thank you very much. From Junebugs for $10, thank you for sharing your knowledge and passion for this topic, Erica. It's my pleasure. You and your channel are a huge part of why I want to study primatology. That's phenomenal to further my education. Congratulations. That is epic. And I'm so happy to be a part of it. We have from 10th Web. This is a little sassy, Will, but I think you can handle it. Will, would you consider giving half of your time at the start to showing your understanding of the previous lecture before going into debunk mode?
Yeah, I can consider that. I'm dedicating a lot of time as it is to not only research, but also prepare the presentation, but I can definitely think about that for sure.
I could probably do a better job of like engaging too. From Joe Kick 91 for $20, loving this series. Kudos to you both. Question for Will, especially after learning about carbon dating, do you think there is a sort of barrier when it comes to conveying how we know what we know? Some things go against intuition.
Yeah, the biggest barrier is understanding the past. That's the biggest barrier. It's just difficult. And the longer that past is, the more difficult it is. In terms of carbon dating, I learned mainly from John, Age of Rocks channel, that carbon dating is a mess for various reasons. And so I'm a little bummed because I was kind of obsessed with carbon dating, but he's more into other forms of radiometric dating. But carbon dating is a mess. So bringing that up in this question is kind of weird because that is a barrier. We can't understand using carbon dating like we can with other methods of radiometric dating because the atmosphere being different in the past changes the carbon dating. So yeah, it's tough.
If I may, where are you at on radiometric dating in general right now? What do you think of it?
I apologize to John, but we spent like 2 sessions together only talking about carbon dating because I was obsessed with it.
Yeah.
And so we haven't got to the other stuff yet. And now I'm working on getting on Joel Duff's channel. I'm working on talking to you and Fuzz. I scheduled with Dr. Dino. It's just so hard. So to get back with him, I want to, I just need to find the time.
Yeah, I hope you do. Because it seemed like after we'd done all that your main like thing keeping you from being old Earth instead of undecided was the dinosaur soft tissue. It seemed like you were on board with radiometric dating, but maybe I've got that wrong.
Yeah, I don't know enough about it
yet.
I feel really good on the carbon dating piece, and now I understand it's a mess. So that's kind of where I'm at.
All right, we have from Flatulent Dragon for $20. Hovind gets a lot of coverage since he's the OG Young Earth Creationist communicator. At it since the late 90s with a video series and debates on TV. Watch The Weakness of Kent Hovind for info and logic. Hello, my name is Kent Hovind for fun. He has been at it for a long time.
Yeah. So again, you guys do whatever you got to do. You guys do you. But what I'm trying to help is the perspective of a creationist is going after Kent Hovind is because you want to avoid going after the actual PhD creationists that have good arguments. That's what we interpret it as. So do whatever you want to do.
I'm just going to say, well, the crew that I roll with, I mean, I can't think of a single one of my buddies that hasn't had a on YouTube debate with like a PhD creationist. It's the real stuff here.
Yes, definitely.
From Rosina for $4.99, was it horse evolution that disproved orthogenesis? Yes. So this, well, just for your information, so in evolution for a very long time, there was this idea that one thing evolves into another thing, in this perfect line, right? And that's what the fossil record represents. at this point in time, and really for quite some time, that idea has been rejected in favor of we can't know for sure who the direct ancestor was. And so that's why you often see these branching patterns and say, this character or this animal has characteristics that are really similar to what we would expect from the common ancestor. We can't say that for sure because we're not there. We can only say that it's similar to it. It's a part of the group that eventually begets the following lineage, except when we get the DNA. And we've got some of that for hominids.
I want to say something really quick because I'm monitoring the comments and they do not like that I talked about PhD creationists. So I want to tell you guys something. First time I met with John, again, Age of Rocks channel, he's brilliant. He told me something that was so refreshing and it made me take him way more serious. Okay, you guys ready for this? I hope I'm not throwing him under the bus. I don't think I am.
We love John around here. You're not throwing him under the bus.
He told me that Steve Austin, who I'm a fan of, a creationist geologist, PhD geologist, he told me that he's a good scientist. He's like, Will, Steve Austin is a good scientist. He publishes papers. He does a really good job. I was like, whoa, that was news to my ears. Now, he doesn't agree with other creationists. Like he doesn't like, I think it was Baumgartner and maybe one other guy. But that to me just is honesty. And here I have a guy who is completely opposed to creation telling me actually Steve Austin is a good one. He does good work. And so as soon as I heard that, I was like, okay, thank you. That's refreshing because when all you hear is every creationist is an idiot, they don't really have PhDs. If they do, they just got them at bad universities and they don't publish papers. Like when that's all you hear, it's hard to take that seriously. And so I spent literally hours with him one-on-one. We didn't publish this anywhere and he was teaching me and I was learning and it was amazing.
John, I love John. I think John's great. But I mean, it's, gosh, this isn't going to be a surprise, hopefully for anybody in my audience, but like, I think it's worth looking at the ideas that were better put forward. And there are certainly creationists that I like a lot and there are ones that I don't, but I mean, that's just life. We have, this person's just getting your goat. From Arrow Dodger from 99, hello, Will, is us, the woke Darwinist evolutionist mafia, protector of the evolution conspiracy. We are here to silence you by putting dog ears in all of your books and undoing your laundry.
You know what's really funny about this is I guarantee you this person doesn't know me, but I hate dog earing in books. I hate it.
Or they do, and there is an of the woke Darwinist evolutionist mafia. Yeah,
my daughter dog ears, and I'm just like, what are you doing? I failed as a parent.
We have from Scoot Boot for $20 or sorry for $10. Love that you guys are doing it. This again, it is our pleasure. Okay, Will, I'm reading this one. This one is sassy to you. I'm reading it. They donated, and mostly I'm reading it because I have a comment. From Brob88 for £5. Erica, here's literally mountains of evidence. Will, yes, but have you considered that this guy said some stuff? We appreciate your patience, Erica. I have something to say about this. Carl Werner has devoted like a decade plus of his life to documenting what he perceives as major flaws in evolution. I have read all his books. I understand where he's coming from. I could not possibly disagree more with what he says and especially how he's saying it, but I can understand why, if you read what he's put forward, why you would find it to be convincing, especially first pass. So I don't fault Will for reading his stuff, especially because his books are very professionally produced. I don't fault Will for finding what he said at least intriguing. I am a little frustrated because some of this stuff I did cover directly in my presentation, but my presentations are like 100+ slides long. So I do understand if stuff was missed, which is why I'm going to have a bit at the beginning of my next slideshow where we are just going to go directly through this. And I hope, and in fact, I'm just going to ask you point blank, Will, I think I asked this already, but I'm going to rephrase it. If I can show you that he's incorrect on some of this stuff, will you find the case more convincing?
Yes. I also want to make sure you and I connect over email in the next few days. So you just have a really concise list of like the 5 or 6 things.
Please.
I need.
That would be amazing. That would be awesome.
Okay.
We have from, I already did this one. We have from Where's Waldo for $10 Canadian. I understand that you have more time to research creationist rebuttals between videos than the length of each session, Will, but can you spend that time reviewing the lesson too? Just food for thought. I'm going to let you answer that.
Okay, this is going to surprise people. I do not research creationist rebuttals when I'm doing my preparation with Erica. I rewatch every lesson at least once. And as I'm doing research, the only creationist content I will consume is if it comes up naturally in, say, a Google search or talking to AI and they mention it, or in a YouTube search. So I am not doing that. I've told Erica behind the scenes, I have friends at AIG, I have friends at CMI, I have friends at ICR. I'm intentionally not reaching out to any of them for this. I'm friends with Donnie Badinsky. I'm not reaching out to them because I'm here to learn. And so this time I was fully transparent. For the first time, I reached out to a creationist. Here's who it was. Here's why I did it. So that's literally how I'm doing this.
We have from Southern Skeptics 543-4999, Will, Archaeopteryx has every trait that defines an animal as a theropod dinosaur. It only has about half the traits that define modern birds. How can it be a bird but not a theropod dinosaur?
So I don't know that it has every trait that defines an animal as a theropod dinosaur. That's number one. So I either have to research that or I have to assume that you're correct. One of the issues I'm having is that it seems semi-arbitrary in how we determine which characteristics we're going to choose to group things together. Okay. So if I say, this is just an example off the top of my head, I know it's not the best, but if I say, how do we group animals that lay eggs? Okay. Just tell me right now, how do we group them? You can't. We have mammals that lay eggs. Okay. We have birds that lay eggs. We have reptiles that lay eggs. So I feel like we have such complex creatures with almost countless features that we can just pick whatever we want and say, okay, here's how they go together. And so the biggest thing I would say about Archaeopteryx, which I know very little about, is I believe it's very small. And so that's my first hesitancy to call it a theropod, because the theropods that I'm intimately familiar with, like T-Rex, are massive. So that's all I can really say off the cuff.
Let me say something to this really quick, because this is potentially a really, really important concept. So hopefully this will drill in. It's all the traits. The way we decide how animals fall into bins and what categories define a bin is by looking at all of the traits. So like take a rat and a monkey. Why is the monkey a primate and why is the rat a rat if there are some characteristics that we could use to unite the two of them together, right? Both of them have incisors, like big prominent incisor teeth. Both of them have 5 fingers and hands that can grasp, right? So if we're defining a group by grasping hands, wouldn't you group primates and rodents together, like to the exclusion of a non-grasping animal like a cat or a dog? The answer is that animals are grouped by all of their characteristics. So the reason why Archaeopteryx is a theropod dinosaur is because when you look at every characteristic that it has, it shares the most of them with the theropod dinosaur to the exclusion of all of the other categories at that level. So for instance, you might have heard like, you've heard like humans are apes before, right? Like we're apes. The reason humans are classified as apes is because if you take humans out of the equation, like pretend humans are a totally separate thing, we're not animals at all. And then you ask the question, what makes a chimpanzee an ape and not, a old world monkey like a baboon? And the reason is, well, they don't have tails. They have short, stiff lower backs, right? They have long arms compared to their legs, or actually really compared to their torsos. They have bigger brains than baboons do compared to their body size. And they have a more upright posture. Those are the characteristics that take a chimpanzee and make it different from a baboon. Everything else, virtually, they share, physiologically speaking, right? Baboons, though, have tails and they hold their bodies like this, and they don't have as big brains, and they don't have a short, stiff lower back, and they've got shorter arms. So now you can ask the question, where does a human fall? Humans fall in with the apes because we have those characters too, even if we're removed from it. So when you're asking the question like, oh, well, we could group animals by how they lay eggs, or we could group them by the types of teeth that they have, or we could group them by the length of their arms, or by the length of their vertebral column, or whether they have teeth or not. No, the way we group animals is by all of their characteristics. And when we take every characteristic that Archaeopteryx has, from the tiniest curve of its claw to the length of its tail to the types of teeth in its mouth, those are what characterize it as a theropod dinosaur, because it shares way more of all of its characteristics with dinosaurs than it does with later, more derived birds. So you have to think of it like a filtering process. If you take in, it's kind of like if you want to compare books and say I've got two manuscripts and I'm trying to decide which manuscript is most similar to which other manuscript. I can do it page by page, and maybe it shares one page with, there was a copying error, and maybe I have a copy of Pride and Prejudice, and in the middle of it has a paper from Frankenstein, right? And if I took those two papers from Frankenstein and said, is Pride and Prejudice more similar to Frankenstein based on this one page? No, it's more similar to Pride and Prejudice because it's mostly Pride and Prejudice. Almost all of the pages are Pride and Prejudice. One is Frankenstein. So that's why you have to take the whole thing into account.
Okay, I'm going to rewatch this. There's something in philosophy and theology known as the eternal regression problem. Yeah. And it's making me think about it. So because then we have to say, well, what's a theropod dinosaur?
Yep.
And then what's that? So what I'm hearing is that everything is everything.
No, because as you get more specific, as you move down that phylogenetic tree, you're becoming more specific than the previous group was. So you're all those previous things. So remember when I had at the beginning of this, those boxes that enclose those cartoons? And I said, okay, humans are hominids. Why are we hominids? Well, because we have short, stiff lower backs and big brains, and we have long arms compared to our torso length, and we take forever to grow up, all these characteristics. Okay, so we're hominids. But we're also primates. Well, why are we primates? Well, we're primates because we have grasping dexterous hands, because we have binocular color vision, because we have flexible ankles, all of these other characteristics. Us being primates doesn't make us not hominids. We're both of those things. Primates is a bigger category than hominid is. Mm-hmm. And we're also mammals, right? Because we have 3 inner ear bones, and females of our species produce milk to feed our young, and we have hair all over our bodies. But we're also primates, and we're also hominids. So we're mammals and primates and hominids. That's more specific. And then we're also chordates, because we have a notochord in our back. So we're chordates and mammals and primates and hominids. And that's why it's a regression all the way to the biggest category of all, which is it alive?
Mm-hmm. But isn't it true that humans are fish in the same way that a bird is a dinosaur?
Well, there's
I've heard that from multiple people.
Yeah, so we're fish in the sense that the category for fish, Sarcopterygiae, means that you have specific structures in your wrists and in your shoulders, really, I guess is a better way of putting it. So yeah, technically they are, but saying it like we're fish is like a crude way of putting it. That's no different than that we're mammals, right? Like we're mammals because we descend from mammals, and we're fish because we descend from fish, and we're eukaryotes because we descend from multicellular organisms.
I love the phrasing descending from. I can confidently state I will never say or accept that humans are apes, that humans are fish, that birds are dinosaurs. What I might accept is that dinosaurs or birds descended from dinosaurs, humans descended from apes, etc.
I cannot wait until we talk about human evolution, because it is impossible to define in totality an ape in a way that includes chimps and bonobos and gorillas and orangutans and excludes humans. You can't do it.
Okay.
Genetically, that would be great. Thank you. So genetically, when you sequence the full genome, absolutely every single little base pair, end to end, not a single thing missing. Chimpanzees, like chimps, share more with humans than they do with gorillas. So there's no way to group these guys by characteristics or by genetics that includes chimps and excludes humans. And the reason is because we carry that genetic baggage.
Yeah, challenge accepted. I'm excited.
It's gonna be, I'm telling you, dude, here's my thing. You can say humans aren't apes or birds aren't dinosaurs, but you have to change the definition of what those are.
Well, Hold on for a second. I think words have meaning, and I think when we say things like that, we actually lose the meaning of the word. Like, for example, if I go order from a restaurant, I want fish.
Yeah.
Are they going to bring me human flesh? Never, because the word fish has a meaning, and it's not humans.
But the word fish is different from the word sarcopterygian, which is what humans are. Sarcopterygian is just, or fish is just a colloquial word for sarcopterygian. Because fish also means, like actinopterygian also means fish. And so does teleost, right? Like those are all types of fish. So when you say fish, you could mean a million different things, but like it's kind of in the same way that it's like technically, thank you so much. Technically the way that we define what a monkey is, right, in science, by the definition for Catarrhini, which is the actual scientific word for old world monkey, humans are monkeys too. The way that monkeys are defined, like the way that old world monkeys, every species excluding humans are defined as separate from new world monkeys, is by downward facing nostrils and details of the ectotympanic tube in the inner ear, and tons of little minutiae of the bones and teeth. And then you take humans and you say, where do humans fall? They fall with the catarrhines. Like we have those traits too. So like you can, if you want to define humans as not apes, it has to be on the basis of something that's completely non-physical. Like it has to be humans have a soul, or humans have soul is really the only thing that I think you could do. Because like even, and we'll talk about this later too, but like even the minutia of behavior, you've like the roots of language are found in non-human primates. The roots of morality, like they have proto-moral systems where they punish rule breakers for doing things that they're not supposed to do. And they practice altruism for reasons that, like you were talking about whales the other day or earlier today, and how we can't really get in their head and understand why they do what they do. We've documented published accounts of chimpanzees risking their lives for unrelated individuals, like wading into water when they know they can't swim. There's weird stuff here that's hard to put your finger on, but it's like, you're right, words have meaning. What does the word ape mean? What is or the word sarcopterygian or the word dinosaur? Well, to be a dinosaur, you have to have an open acetabulum, and you have to have more than 3 sacral vertebrae, and you have to have an upright posture with legs below you. Take birds totally out of the question. Just pretend like we're defining what's a dinosaur as compared to all these other prehistoric animals. That's how they defined it. And then we ran into the problem because birds meet that same criteria. People started dissecting them and they were like, oh no, birds have these too. So that's why they fall into that category.
Okay.
Anyways, we can get more into it another time. We have from MXDAW for €11.99. Big fan of both channel and series for both. Lab makeup plate film showing bacteria across increasing doses of antibiotics. If yes, what do you think? I have. It's really cool.
I have not.
I'll send it to you.
All right.
Okay, from Rosina for $4.99. Will, check out giving feathers to crocodiles. Multiples are required for scale to feather conversion. We went over some of that, but I'll send that one to them too if that's a different one. From Rosina for $4.99, a chicken fossil near a T-Rex fossil in the same strata. Time travel confirmed.
Here's a question. Would a modern bird with a dinosaur be a creationist prediction here?
I think a modern bird with the first dinosaur. It would have to be with the first dinosaur, like the very earliest dinosaurs. And
why?
The reason why... Awesome question. So I have a slide about this in the last PowerPoint. Do dogs descend from wolves?
I don't know. It sounds reasonable.
We know they did, right? Like, come on, dogs descend from. You can sequence their genome, like they're literally closer than most pairs of animals. Like they're way more similar than lions are to tigers, for example.
I have a weird theory on dogs, but keep going.
I don't even know what to say about that, Will. Okay. Dogs do descend from wolves, insofar as we can tell. That's a wild point to make. But okay, how about this? We'll do this example, then we'll do another one. So dogs descend from wolves, but wolves are still here, right?
Mm-hmm.
You don't have to go extinct. Just your ancestors don't have to go extinct just because you're around, population-wise. Like your grandparent is your grandparent. gave birth to one of your parents, and then your parent gave birth to you, and both of them can still live for a long period of time, even though you're born. So I'm trying to think of an example.
But as in your presentation today, it was taking millions and millions of years to see these tiny changes, like little feathers and things.
So it was in part, but like these changes are small, but they're not nothing. And in addition to that, like, first of all, let me think of the best way to phrase this. The changes are substantial, but they don't become selected for unless there's a need in that environment. Like, if you remember all the way back when we were talking about mutations, remember we were talking about foxes, right? And foxes that live in like a regular forest. If it suddenly gets colder in that forest, like let's say the climate starts to change and we start to enter into an ice age. Those foxes have variation in their gene pool. Like, we know this. You can go out and measure foxes or right now, and you can take a pair of calipers, I have a pair over here, and measure the length of their fur. They're going to vary a little bit. You could do the same with bird beaks. You could do the same with toad spots, whatever you want. Animals vary. So if it suddenly gets colder, which of those foxes do you think is going to have more success? The ones with longer fur, or the ones with shorter fur, or the ones with regular length fur?
Longer,
right. So over time, they're going to start getting longer and longer fur. Yeah?
Mm-hmm.
What if the climate doesn't change?
I don't know.
They stay the same, right? Genetic drift will play a little bit of a role. Like, there's going to be some changes here and there that just by nature of mutations accumulating over time. But by and large, unless there's a pressure, organisms aren't going to change drastically. This is why you see, like, remember we were talking about how after the dinosaurs go extinct, mammals explode in diversity. And the reason is because every ecological role that those dinosaurs used to fill is gone. It's wide open and available for them to take for themselves. Big carnivores, big herbivores, swimming creatures, like every potential role that you could want to have is no longer filled by a dinosaur. And so organisms can specialize out into those areas. It's kind of like if there's like mass layoffs at a company, all of a sudden all these roles open up and they can hire new people into those roles.
Mm-hmm.
So in the case of our dinosaurs, it's like in the case of flight really developing from non-avian dinosaurs, there's no rush. Like, no one is saying, hurry up, develop flight. You have 150 plus million years to develop flight, to develop different types of feathers, to lose the teeth, to get them back. Right? Some dinosaurs lost their teeth independently. Some didn't. Sometimes feathers show up in dinosaurs that would never learn to fly. They would never yield flying descendants. Sometimes they do. It's a direct prediction of evolution that there is no stated end goal, and that organisms and the variation within them is at the mercy of the environment. I think it's a wonderful, really a perfect mechanism for keeping life well adapted to the environment in which it lives in. But if the environment doesn't change, there's no need to move in a given direction. So flight taking a while to develop is not at all problematic. I mean, it could go as fast or as slow as the environment would demand. Does that make sense?
It does. I struggle with rapid evolution, if that's a proper term. It doesn't make any sense to me. Just fixity I struggle with, and fixity itself seems to me would take so long. And also, like, the changes are so small. It's like then I have to wrap my mind around, can this be selected for, because it's such a tiny change. Like, here's an example. Humpbacks in the Atlantic and the Pacific are identical. That doesn't make sense to me from an evolutionary perspective. Anybody that's an expert in humpbacks is going to tell me, well, Will, in the Pacific, their top of their fins are blacker than the top of the fins in the Atlantic. That's correct. That's the only difference. So it just doesn't make sense to me. Like, for example, because we know they don't cross, they don't go from one ocean to the other. Why can't we see what's changing in one group that's not in the other and see this evolution happening? And I'll be told, well, Will, it's too slow for that. It's too small. Okay, great. If it's too small to see, how could it be selected for? It's tough.
It's more that it's too slow to see for us because they live as long as we do. You know what I mean? Like
Mhm.
take we're going to talk about this next time because I'm going to talk about the evolution of multicellularity. But we've evolved multicellularity in the lab twice. 2 times we've evolved multicellularity in a lab from single cellular ancestors. And the reason we can watch this happen in a lab is because their generation time is like a couple of days. And so we can see it occur. You know, likewise, we were able to see in a single lifetime, if you'll recall from the mutations episode, we were able to see in a lifetime peppered moths completely change color. We were able to see in a century elephants shift to being primarily tuskless. And the reason was because all of the tusked ones were killed and only the ones without tusks were left to reproduce. So it was basically an instant change acting on variation that was already there. In this, we saw the same thing with the anoles, right? Like that have those finger pads to help them hold on better. One major hurricane swept through the area and wiped out all of the ones with small finger pads, and it just left the ones with the big ones. So if the variation is there and the selective pressure is there, the change mathematically will happen. And we've observed this occur when the generation times are small enough. Now, if you want to say, I want to observe evolution happen in my lifetime in animals that live as long as I do, that's never going to happen. Because you can't observe it. You don't live long enough, and neither do I. But what you can do is you can say, okay, if these animals live for long periods of time, like if they have long lifespans, like there are other large animals, large-bodied animals that have long lifespans, like us, for example, what we can do is make predictions about what we would expect to see if an environment changed in a certain direction. Like, for example, after the dinosaur mass extinction, what would we expect animals to evolve into? What would we expect them to look like? How would we expect organisms to adapt? And then we can go make that prediction on paper ahead of time, and then we can go look to see what the fossil record actually shows us and make predictions about long-term evolution in that way. And then what we can do is say, okay, well, we see what looks to be a transition here. Is that transition possible, right? So in the case of bird evolution, we have birds now, and we have animals with feathers that look a whole lot like Velociraptor living in the past. How do we explain the evolution of flight? Well, we would expect that in between the two of them, we should have an animal that looks like this, right? Then we go look. Lo and behold, we find the animal. It's Archaeopteryx. Archaeopteryx has all of these transitional features that we would expect from an animal that is midway between these two states of being, not just physically, but in time too. Okay, step 3. Can we show that mutations can create the types of features that we see in this animal? So like, can we show that there's something you can do genetically to go from Velociraptor to Archaeopteryx, or to Archaeopteryx to modern birds? Yes, we can. We can tinker around in their genome. We can get teeth. We can get rid of teeth. We can elongate the pelvis. We can unfuse the pelvis. We can fuse it. Like, you can do all of these tweaks on living organisms that cause them to look different. Okay, can we show that those mutations aren't lethal? Yes, we can, because these are the stages that the animal literally goes through as it's developing. If you stop it at any given point, it's gonna be at that point. So if you can show all of those things to be the case, if you can show that the variation for it exists, if you can show that it's not lethal, if you can show that it can happen, if you can show that in the fossil record it looks like it did happen, short of a time machine, that's the best support for something occurring that you could possibly get. I mean, you're setting out these predictions ahead of time and finding them to the degree, to the best possible degree, I guess I would say. And I'll say too, you can show in the lab that it's possible for this type of change to happen in organisms that live for short enough periods of time that you can observe them evolve something like multicellularity. I understand that it's like it's not an easy thing to wrap your head around, but I think it's really, really important to keep big picture in mind here, and keep in mind how the scientific method works, how these predictions are being made beforehand, and how they're coming to fruition across thousands of papers, across decades of work. Because that's what I think makes the case the most compelling. Anyways.
Makes sense.
From Bugmaster 8647 for $5. Erica, to be fair, sometimes a single data point does debunk the entire model, e.g. the Michelson-Morley experiment debunked the luminiferous ether. I don't know what that is, but that is fair enough. Thank you for your donation. From Rosina for $4.99, does Will have issues with birds being dinosaurs like humans and whales are mammals?
Yes, I do. Humans and whales are existing today together. So that's the difference. That's where I'm struggling.
Yeah, I think to fix this, imagine if you had a dinosaur existing today, any dinosaur, what character, like would birds be classified as dinosaurs then?
If the dinosaurs look like Jurassic Park, no.
Yep, that's not true.
Okay.
Sorry, you cut
I
off.
haven't seen a bird without feathers, so I guess I'll put it that way. And so if the dinosaurs like in Jurassic Park, which don't have feathers, I would not classify them as the same.
Do you think feathers are the linchpin?
I do.
Okay. So so then the homework is laid out for itself. You got to investigate Tyrannus and Velociraptor and Therizinosaurs, and if they sufficiently do have feathers, then you're going to be like, birds are dinosaurs.
I think so, yeah.
Chill. All right. From Keithward 6439 for $9.99. Just wanted to say thanks, much respected to you both, and thanks for allowing us to take this course with you. Our pleasure. From High Eve 001 for $5, what's the use in half a wing? An arm is half a wing. If you can't figure out a use for an unfeathered arm, you need to think harder. Winky face. Thank you very much for the donation. Sorry, we have a lot of super chats, so I'm zooming through them a little bit. From World's Prettiest Corpse for $9.99. Great lesson. Question for Will. Has seeing science challenge young Earth creationist ideas affected your other ideas you have, scientific or faith-based, not your whole worldview, but any elements that you've been rethinking?
I don't think so. Like, I obviously knew this tension existed between evolution and young Earth creationism. I would say that the other areas like origin of life, origin of the universe, I don't see science challenging those at all. Stephen Meyer's got a documentary coming out next week called The Story of Everything, which I'm super excited about. They focus on those issues because I think that they can make a stronger case. But no, I've enjoyed this. Evolution is far more robust than I thought. It's far more robust than I was taught. And so I'm doing the right thing in learning it from the source as opposed to learning it from a debunker.
That's the truth. From Elig 1703 for $10, I studied anthro, graduated in 2005. Career tangent took me to a non-academic direction. That was my original plan. So great to learn all the updates since I studied. Appreciate you both. Again, our pleasure. We have $10 from Blackmore 278. Would evidence of life on another celestial body change your view on young Earth creationism? There's a NASA mission going to Europa, a moon on Jupiter that has water geysers and subsurface oceans, which could have life.
I would say no. I don't think so. I mean, let me put it this way: the atheist / agnostic / naturalism side can't even explain life on Earth, and so if they can't explain it here, I don't see how they're going to explain it elsewhere. There was an interesting young Earth creationist who died probably a year ago. His name was Walt Brown, and by the way, creationists make predictions that come true. Okay, so I don't necessarily take a prediction that comes true as affirmation of what their view is on either side. But he made a very interesting prediction, which I can't articulate. I'd have to look it up. But he made a prediction that we would find something in space that has only ever been found on Earth. And that's because he believed the flood broke open the crust of the Earth and shot parts of the Earth into space. And his prediction came true. And it was very, very specific as to what he said we would find based on the mid-oceanic ridge, which is he believes is the crack from where the crust broke open. So there was something along the mid-oceanic ridge that's only found there. He predicted this would be found in space and that it originated in Earth, and that prediction came true. So when things are found in space, I run it through that filter as well, which is maybe it came from Earth.
I am very familiar with Walt Brown's hydroplate model.
Awesome.
I know it. I know it like the back of my hand. I don't know how familiar you are with it, but do you know?
Not.
Okay. He thinks that every crater, I suppose you say that every crater in our solar system came from Earth rock ejected during the fountains of the Great Deep exploding. If that were the case, the size, someone did the math, it wasn't me, I think it was Glenn Kubin. The Earth would have to be like multiple times larger than it is right now to account for all of that mass. And to eject it, Walt estimates that you would need the energy equivalent of 5,000 trillion hydrogen bombs. It's a lot of energy. I don't know where he's getting that from. And that might be a problem for the Ark. From GK Pseudo for $10, these lectures are genuinely what I look forward to every month, more than anything else on YouTube. Keep up the great work. Our pleasure, my friend. And thank you for your donation. From World's Prettiest Corpse for $1.99 for both, what's your favorite bird and why is it a corvid? I said mine in the beginning, bearded vulture.
Mine is a curl-crested aracari, which I'll probably have a picture of in our next session that I took.
Ah, good. I was going to ask if you'd taken it. From Southern Skeptic 543 for $4.99, Will, I did a video about Answers in Genesis labeling Archaeopteryx as a dinosaur and then labeling it as a bird after feathers were found. What are your thoughts on that?
Haven't seen your video. Here's my thoughts. Please email me that video to thefinalexperiment2024@gmail.com. I will watch it. I will commit to that. That to me is a big deal. There are two ways to handle something like this. I don't know how they did it. One way is to act like you never said what you did and to just change your mind. The other way is to admit, hey, we got this wrong and we're admitting it. And so I hope they did the latter, but I'll watch it.
I've seen it. It's a great video. Southern Skeptic actually eyeballed my presentation today before I actually pitched it. He really knows what he's talking about. I will say this. If Velociraptor is a bird instead of a dinosaur, will that seriously impact how you conceive of what counts as a bird? Because if Velociraptor is a bird, what's preventing like Tyrannus from being a bird? You know what I mean?
Yeah, no, a velociraptor, like if a velociraptor has feathers like Archaeopteryx, that's going to be significant for me. I just wasn't aware of that.
Sweet. We have Blackmore 278 for $5. In one of the newer Jurassic Park movies, Dominion, they have a feathered dino. I don't recommend watching them since the new movies are garbage. I haven't seen any of the new ones.
Yeah, the new movies are garbage. They're not worth the time. But the originals are amazing. The original Jurassic Park is one of the greatest achievements in cinematic history when it comes to graphics. When you watch that movie today, it looks amazing. And I think it came out in like 1995. Yeah. And there, in my opinion, there was nothing at that point that was anywhere close to it. And it's still enjoyable today.
I co-sign that. I think Jurassic Park rocks. From Rosary as 5900 for $4.99. Loving this series so much. I've been fascinated with natural history my whole life and still learn so many new things every month. Me too, my friend. Thank you for your donation. From Anthrax Crab 2222 for $9.99. Will, if you were convinced of evolution, would this alter your faith? Brother, you got to keep up with these shows. We get this question every single time. As far as I can tell, the only thing evolution touches is the manner in which death enters the world. I'm theistic Evo believer, by the way. So they're
cool.
Christian themselves as well.
So the answer is no, it wouldn't alter my faith. I've stated this before, and I think it's worth stating again. The two things that I'm most confident in that are hotly debated are the existence of God and whether or not we have free will. I'm actually adding a third, which I'm super excited to talk to people about. I just haven't had anybody to talk to about, not even my wife yet, which is I'm adding to a third. I'm fully convinced, and I think I can prove it to pretty much anyone, that we are not just a body, that we actually also have a soul. So anyway, if evolution is true and I became convinced of evolution, all that would tell me is that, okay, this is how God chose to handle life on Earth. Whether it's guided or not is a different story, but it's either something he's allowing, something he's tinkering with or whatever. That's a separate question. But no, the existence of God to me is solid, absolutely solid.
We have from Keats 231 for $5. Love the series. Question for Will. When you were researching cetaceans, where did you draw the line, if you did, between obvious whales and non-whales?
Yeah, so this is a tough line to draw. Many things called whales are not really whales. Killer whales are not whales. I think pilot whales are not whales. I know people know this, but the whale shark is not a whale. I don't really draw a line at this point. The toothed whale, baleen whale line is pretty interesting to me. But there's so many cetaceans. I haven't even researched all of them yet. So it's
There are a lot of them, yeah.
it's fun. It's fun. Actually, I forgot to mention something, which is that on my way to the whale trip, I took my son to a park that's kind of like SeaWorld, which is what people would be familiar with. It's called Ocean World, and it's in the Dominican Republic. And I told my son, I said, I want to go early in the morning. I want to be the first one in the park because animals act differently in the morning. They're more excited. They're more lively. And so we were like the first ones in the park, and there was nobody there. And we walked to where the dolphins are, the captive dolphins. And I didn't even know if we'd see any, but I just knew where they were at. As soon as we walked up to this area, a dolphin swam over. By the way, I have a video of this if you don't believe me. A dolphin swam over to me, and I said hi. It turned on its side and waved hi with its flipper. Then it went down, came up, and threw a rock to me.
They're so brilliant.
Out of its mouth. I immediately started filming on my phone because I was like, this dolphin wants to play. I threw the rock back in the water. It would go get it, come back, and it would throw it right back to me into my hand. And so this went on for like a few minutes, and it was phenomenal. Like cetaceans are brilliant, and they're relational. I love them so much.
They are really cool. From prehistoric over 279 Canadian dollars, Rhea whales orca subpopulations avoid inbreeding. I believe that. From Southern Skeptic 543 for $4.99, Will, absolutely all birds today have 11 or more sacral vertebrae. In the Mesozoic, there are no fossils of birds with more than 11. Thoughts on that?
I don't have thoughts, and I'm going to be honest with you. It's because I don't understand the significance of this. One of my struggles with evolution is it seems like no matter what happens, it's proof of evolution. So if something increases in quantity, that's proof of evolution. If it decreases in quantity, it's proof of evolution. If it's bigger, that's proof of evolution. If it gets smaller, that's proof of evolution. And so I probably don't understand the significance of this. And if you want to email me more, I'll read your email.
I will say this is going to be brief. The significance is exclusively in what you're proposing is the ancestor and the descendant, right? Like if I propose, like let's say I propose humans evolved from an ape that lived a long time ago, right? And I show you the fossil of the ape and it has a little brain and big teeth and it walks around on its knuckles. For example, if I say that, then it's my job as the person proposing that we evolved from that thing to show fossils of our traits showing up through the geologic column with those ancient traits too, right? So I should show the brain getting bigger in subsequent fossils, right? And the teeth getting smaller and standing up and walking upright, yeah? Mm-hmm. If I'm saying that we come from that. So I think what Southern Skeptic here is saying is that if birds descend from dinosaurs and all birds have 11 or more vertebrae, then we would expect that the earliest birds wouldn't have the same number as we have today. You should see it go from the number that early dinosaurs have increasing to now, if they evolve from them. That's my understanding.
Okay, I'll think about that.
From Aaron Marks 9366, Will, would you say that the concept of kinds is your main contention with the theory of evolution? If not, what would you say is the main point of incompatibility with the Bible and evolution? You're not listening to the questions.
Not really. I think it's going to be impossible to understand kinds in the same way it's impossible to know what Luca was. I think that problem exists on both sides. So that's not really, it's not really an issue that I have. The main point of incompatibility between the Bible and evolution, that's a tough one. I would say a woodenly literal interpretation of the Bible would exclude evolution. But I also know that when you interpret things that way, it can get you into trouble. And so maybe, I mean, the Bible is so hard to understand. It is, so old. And again, the past here rears its ugly head. Understanding what the words meant, what they meant in those in their contexts, what figures of speech they had back then is so difficult. So I am very open to misunderstanding the Bible without a doubt. And I have a little bit of a different view on the Bible than most Christians as well. I'm not convinced we have the entire Bible. I think books have gone missing. So there's a lot there to where I prioritize things in the present that I can know are true over interpretations of the Bible that would render things that are just observably true as false, if that makes sense.
We have an unbelievable biggest super chat that I think we've ever gotten here for $500 from Nothing But Seals. Gotta love that Tyrannus. Second only behind Spinosaurus for my favorite dino. Been loving this whole series, although I'm curious, Will, how would size prevent such an animal from being a bird on size, having seen the differences between an ostrich and hummingbirds?
Yes. Okay. So an ostrich can't fly. So this is kind of proving my point. Only small birds can fly. So that's why I brought up the size issue for me. So understanding the size of these fossils is going to be important because when I think of a theropod, and I'm not a theropod expert, but when I think of like, a T-Rex and other dinosaurs like Edmontosaurus and things of that nature, the thought of those having feathers and being in the line of the transition from dinosaurs to birds is tough for me to swallow for sure. But something small like Archaeopteryx, which is pretty small, I have no issues right now before I even look into this stating that I think Archaeopteryx is definitely a bird. But who knows? We'll see.
I think, yeah. I mean, I'm just telling you ahead of time. What I'm going to ask is, how do you tell the difference? Right? Like if I bring you a fossil and it's got a bunch of characteristics, how do you, Will Duffy, say this is a bird or this is not a bird or this is a dinosaur? You know what I mean? Thank you. Nothing.
I'll strive to answer.
Perfect. This is an unbelievably generous super chat. Thank you. It's stuff like this that helps, makes it worth it in part, just because it means people are enjoying it enough to donate that amount of money. Again, all the money from super chats does go to our respective charities. From 10th Web for €5, Will, is an X-ray a picture?
I would say yes, but I would say that image was not an X-ray either. So I still wouldn't consider that one a picture.
It is just waves, though, right? Like seismic, like you bounce sound waves down and you get back a picture in the same way. Like X-rays work the same way. It's just bouncing waves to get a topography. So I don't think that's consistent.
Well, the colors are being added, and that's why I'm struggling to call it a picture. Like with an X-ray, if it's black and white and our bones are white, I don't have as big of an issue there. That's
not true. Marrow is red. In an X-ray, sometimes you can see marrow and it shows up white, but it's actually red. I'm coming to your house, Will. From Hyper Gamer 3396 for $10. I haven't looked into it very far, but I've heard we can use aspects of the iridium layer to figure out what part of the solar system the Chicxulub meteor came from. That would be insane. I do not know that. For an unbelievably generous $50 from Torshell710, this is my favorite thing that's happened on the internet in years. I can't believe how much I'm learning for free. Truth is important, and I'm so grateful for you both. Thank you very much. This is incredibly generous, and again, it's our pleasure. From Rosina for $4.99, SciShow did an episode on the impact event earlier today. I recommend it. Also, it took about 30,000 years to kill off all the species that went extinct. I listened to this while I was at the gym before our meeting today. It's very good, and I will send it to Will. From Anthrax Crab 2222 from $9.99, Erica, 2 nerd hypotheticals. Would it alter our evolutionary theory if we found microbes on Mars or Europa that shared our mitochondrial or DNA RNA setup, or met Star Trek-esque aliens, i.e. weirdly similar humanoids? Both of those would be insane. I mean, first of all, it would mean that either we all share a common ancestor, or life started a bunch of different times, which has interesting implications for everybody. If humanoid aliens were real and came to Earth, that would turn everything on its head for a lot of different people. If we found microbes on Mars or Europa that shared our mitochondrial or DNA, RNA setup, that would also be insane. And I don't know what would be crazier, if it did or if it didn't, right? Because again, you have this question of like common ancestor between stuff on different planets or not. I don't know. That would make an insane research program. From Where's Waldo for $5 Canadian. But can we all agree no loving God would make Dendrogaster? Where's Waldo? I looked this thing up yesterday. So, Will, there's this animal called Dendrogaster. It's a crustacean. It looks nothing like a crustacean. It looks like a bunch of organs. It's a parasite that infects starfish specifically. It blew my mind when I learned about it the other day. It's insane. From Bugmaster8647 for $2. If you thought that's cool, check out Anomalocars. I know about Anomalocars, and I do think it's very cool. Thank you, Bugmaster. From Where's Waldo for $5 Canadian. Consensus is pretty consistently more accurate than previous consensus. I do think that is true.
Well, that means previous consensus was wrong, and current consensus will be wrong or less accurate.
Yeah, but the idea is that we're converging on being more right instead of less right, I think.
Yeah, and that's fine going with the flow. I think there's nothing wrong with that. It's just not who I am.
From Bugmaster8647 for $10, taking your own blood every day is a study with one participant. Such studies are statistically insignificant. This is about the guy you were talking about earlier. Are statistically insignificant. Maybe your hypothesis is right, or maybe you've got weird blood.
So let me elaborate on this a little bit more. And again, he's going to be right. I'm telling you guys right now, he's going to be right. He discovered what's known as a lean mass hyperresponder, which I actually am as well. That's how I know about this. He could not get the medical community to do a study on this. And again, I just hate that kind of stuff. That to me is anti-science, not science. So he fundraised and did his own study. And I believe it was 100 people that he did it with. It might have been through Harvard. I don't remember. So anyway, he's taking the baton here and doing it as an engineer. I have a mind kind of like that, where I love to spreadsheet things, test things, and that's what he's doing. And so again, it's just a really cool story. He's going to take on literally probably the one of the biggest consensuses you could have, which is a 100% consensus by everyone in the medical community is stating that he's wrong and he's going to be right, and he's not even a scientist. So I love stories like that.
I cannot speak to that. I don't know anything about the subject.
Yeah.
We have from Xandor for $5. Will, how are you feeling at this point in the learning experience? Are you experiencing doubt, confidence, trepidation, excitement?
Yeah. So I'm feeling a little overwhelmed, but that's okay. I'm used to biting off more than I can chew. I like to consider myself as someone that has integrity. And so what I agreed with Erica to do at the very beginning, I'm going to follow through, and I'm going to do to the very end. So I'm taking this very seriously. I dedicate time to this. I, have to say no to my family sometimes because it's like, no, I got to work on it. It's just now known to my family as Erica. It's like, Dad, what are you going to go do? I'm going to go work on Erica. Okay. So anyway, yeah, I don't know if any of those words are words that I would, use at this point. I do love to learn, and that I'm enjoying, because you can't not learn when you look into these things. So it's, again, people make fun of me in the comments, and I don't really care, but every session I do with Erica, it's 80 to 90% new information for me. So you guys can make fun of me for that. That's fine. I've decided to spend my time on other things, such as researching, finances and investing, studying the Bible, studying my own personal health. I have not taken the time to study biology and evolution, but I am learning, and learning anything is exciting for me. So thank you.
I think that's all you can ask. I really do. I mean, I think that we're all learners in most things. So having that kind of attitude really only ever ends well for people. I try to have it myself as well. God, no, truly, if I were to, I could not tell you the first single iota of a thing about finance. I don't know anything about it. So from Rossi for $5, I think you responded to them earlier. Will, disappointed in looking forward in time answer. A mutation not being beneficial is only evidence of the process of evolution.
All right, so let me elaborate on that. So the reason I brought up my son having an extra tooth is because evolution has to state that at some point with some creature, they got teeth. So that means it had to have been beneficial in the evolution paradigm. So I'm not saying that his example is what I'm talking about. I'm saying it's what got me to think about it and realized, okay, like some animal, maybe even a human, I don't know, like got more teeth at one point. And so it's like, I'm trying to wrap my mind around how is getting more teeth a benefit when this is such a disaster? And how is losing teeth a benefit when losing teeth is a disaster? The last thing I want to do is lose teeth.
I think what, again, is important to remember, because like we derive teeth from the same types of cells as animals derive, like as sharks, for example, derive the sharp, rough skin on their bodies. Like it's the same sort of primordial cell. It's weird. And you can tweak, as we did with the feathers, you can tweak aspects of these cells to get them to express in different ways. So it's a really important concept to keep in mind. And I know I keep emphasizing this, but it's like not all mutations are good. And whether or not it's good depends on the context. And whether or not it's going to proliferate to the rest of the population depends on the context too. So it's like the mutation itself needs to be good, and then it needs to be good in that particular environment. Like it needs to be not lethal, I should say. And then it needs to be, which is fine because most mutations do nothing at all. Some of them are bad, some of them are good, most of them do nothing. But in order to proliferate, it has to be to provide some kind of benefit. Go back and check out our mutation slideshow again, and go to the slide that has the little green shield bug on it, and look at that equation again about how mathematically, and this is the math derived from those peppered moths. So the math was derived from a real world example. A 1% benefit can proliferate to the rest of the population in like 10,000 years. I mean, that's a long time, especially for a critter that has like a year-long generation time. But for a 1% benefit, and then you think about what would a benefit be of like warm plumage? Like your scales are all accidentally downy plumage instead. Like that's a huge benefit as long as it doesn't kill you. From Sumerains 7583 for $5. The point of Will swimming by undulating. Cheetahs are an example of a land animal that undulates when they run. Look at videos. I didn't know they did that, but that's really cool. I guess that makes sense because their bodies are kind of like, their spines kind of look like a slinky when they're moving at such high speeds. Okay, we have from Sylvan Epiglottal Stop for 100 Argentinian pesos, I think. I do agree that Kent Hovind is low-hanging fruit, but every time I see a response to Creationist, comments say that those are low-hanging fruit and not the real deal. It seems impossible to find high-hanging fruits. We have, I mean, I think we're all on the same page with Kent Hovind. I don't have to win any. There's nobody here or in the comment section that needs to be convinced of that. From the weirdo CKAM for $2, motion to start a WTF is having time club. Yeah, that's true. None of us have any time to do anything these days. That's true. From Donald Janays 678 for $12.34 Canadian dollars. Will, organic material in a fossil might change one's understanding of that fossil's age, but even if evolution is completely disproven, a much stronger claim that does not preclude an old Earth.
I agree.
I
agree. I think the important thing is that evolution does need the time.
No, that is absolutely true. Like the time is absolutely a necessity. I think it's really hard sell at this point. Here's what I'll say. I think if the soft tissue stuff is your linchpin, I put money on you being an old Earth creationist by the end of this series because I think there's a really good explanation for it that exists. But I guess I won't hold my breath.
Okay.
From Where is Waldo for 10 Canadian dollars, my comment on creationist PhDs was that they speak outside of their field on evolution. What does Steve Austin say about his field as it relates to evolution?
I don't know. He's a geologist, so I don't know what he would say about evolution. I have no idea. I haven't read all of his stuff. I mean, As far as I know, there's PhD young Earth creationists in almost all fields of science.
I'm going to tell you again, the one that there isn't, or at least the one that I've noticed that there isn't, is no one studies human evolution. Like there's not a
Yeah,
creationist.
I remember you telling me that, but I don't see why they would.
Well, there's a really, really, really good reason that you're going to see very shortly when we get into the hominin stuff. Because they're, like, you know how we talked about a lot of fossils today?
Mm-hmm.
There's more fossils that, at least that I'm familiar with, for human evolution than I'm familiar with for bird evolution. Like,
my only point was, if they don't believe in human evolution, why would they study it, you know?
Because I think it's one of the, well, that's true, but it's not studying human evolution. You're trying to sort these creatures to understand which ones are human and which ones aren't. You know what I mean? Like, no one has ever, like, let me give you an example. There are several creationists who have specifically gone into the areas that they've gone into because they're young Earth creationists wanting to make sense of it. So, like, you can find testimonies from people like Nathaniel Jeanson, who's a developmental biologist, who specifically was like, we need somebody with this area of expertise in young Earth creationism, so I'm going to do it. And so he went and got his PhD in it. That is not an uncommon story. No one's ever done that for human evolution. No one's ever been like, I'm going to go into human evolution and learn as much as I can about it so that I can show why it's wrong.
I'm not doing it.
No, and the people who have tried to do it are like, fair enough. It's very hard.
Yeah.
We have Hang Thashi, 6024 for $5. Good to Gibbon. What was the dinosaur nest where they found the dinosaurs turning to crack through the eggshell just like modern birds before they hatch? It might be the one that I mentioned, the city potty one, but I'm not sure. Thank you for your donation. From Danish Debater 5805 for 200 Danish kroner, I think. Just a thanks to both of you. Thank you very much. We have Bugmaster 8647 for $10. I think Hovind is a bit like Aquinas of YECs. He either pioneered or popularized all the bad arguments that people keep reusing, so it makes sense to go after those arguments at the source. I am not familiar with the similarities between Aquinas and Hovind, so I will leave that to you, Will.
It's not a good comparison at all. I hear completely new arguments. I have way more respect for Eric Hovind, which is Kent Hovind's son, than I do Kent Hovind. So,
you know, Eric invited me to, I mentioned that it's weird this has come up twice, like in relatively quick succession. Eric invited me a couple of years ago to talk to a class that he was teaching about human evolution because he wanted them to see the best evidence for human evolution. So I came.
That's amazing.
Yeah, I came. I gave my presentation. I don't know what they thought. I never heard back from it. I mean, they were really nice and polite, but I never heard back from it, and I was not invited back. So I hope I did an okay job. I was nice, but I think it was a lot of information.
Yeah, it's great.
It was like one of these, so they were probably like, "We're not doing that again." We got Word and Witness 1, $9.99. Love the series. As a pastor, I want to ask Will, what's the biggest theological issue with evolution that you have or have thought about?
Okay, so I've said this before, but I'll say it again. I really dislike the phrase "humans are apes." Again, I love when Erica says humans descended from apes. That to me is reasonable, but the idea that humans are apes, like, we teach our kids that they're not animals, that they should not act like animals. We use examples of what animals do, including apes, to each other, and we say this is exactly what you don't do. We have a conscience, and so I will never be on board with saying humans are apes. So that's a theological issue that I could state right there.
Man, you are not going to have fun with that's a big case that I make. So we'll see. I mean, again, I want to be clear. If your reasoning is non-physical, if it's like a soul kind of thing, I can't argue against that, and I'm not going to try. But what I will say is that, you know, if we are being consistent with how we categorize things, and I think you're going to find there's a very rich tradition of very Christian men being cool with this through time. Humans have all the characteristics that we use to define apes today. So it's a hard, or maybe it would make you more comfortable to say hominids, which is the Sarcopterygian word for ape, which is to say man-like. From IA Figueroa 91 for $2, gets a gibbon. Have you looked at the Issa Valley study with the Savannah chimps? Yes, I have. It's very, very interesting. These chimpanzees in Issa Valley are known for using spears to hunt at a rate that's a little bit higher than some of the other chimps, if memory serves. And they also walk upright more often than other chimps, which is interesting because some people think that the savanna environment is what in part caused ancestors to stand up. You did. I knew when you said this that we were going to get one about this. From World's Prettiest Corpse for $1.99. Please don't use AI at all. It has no place in science.
I'm going to keep using it. It's a very valuable tool.
We have from Blackmore 278 for $10. The taxonomic level that includes all egg-laying organisms is in the kingdom Animalia: insects, birds, fish, mammals, reptiles, etc. No organism outside of the kingdom Animalia can lay eggs. Mm-hmm. That's true. I have a feeling this is going to be a point that we come back to a couple of times. From Desk Frame 7331 for $5 Australian. The only option I had for lunch today was sushi. It wasn't what I wanted, but I rolled with it. You will be banned if you continue to make jokes like that in this hollowed of all places. For 25 Canadian dollars, my first time watching on the stream. Really excited to watch from the top tomorrow after work. Will, looking forward to the future. What is a topic Erica has talked about that you are looking forward to learning about?
That's an interesting question. It's asking me about the past, and then it's talking about looking forward. How about this? For next, are we doing mammals next time?
We are doing evolution of mammals and of fish to land tetrapods.
Okay, cool. There's a recent fossil I heard about that I feel like is an out of place fossil that's in the mammal world, so I'll probably bring that up. So that's what I'm excited about. Sweet.
We have from Rosina for $4.99. If fish exists as a scientific term, we are all lobe-finned fish. You can't escape your clade, Will.
I'm not a fish, so.
We have from Michael Nastenko for $20. I don't know what that currency is. Will, by your logic, and we did this one already. By your logic, ostrich and hummingbird can be grouped together. Erica, awesome series. Happy to do so. Happy to be here. Happy to help. We have from Bugmaster 8647 for $10. Will, think of it this way. You are a human of European descent. So am I. But that doesn't mean that you, I, or that I'm... Wait. But that doesn't mean I'm you or that Italians are French, even though they're all Europeans. Mm-hmm. That's actually a good way. They're sort of saying this for the birds or dinosaurs type thing, like and the categories that we use. I actually think that's a good example. We have from Sylvan Epiglottal Stop for 100 Argentinian pesos. If you want to talk about words and definitions, you might want to schedule a series with that language YouTuber, Tapper Dinosaur, who is gentle and modern, though not an ape. Yeah. Haha, the linguist. I'm never going to escape that one. From Petio Lareeds for $5. Tomatoes are fruits botanically, but in the context of my kitchen or your fish restaurants, we're using colloquial definitions. Neither definition is wrong. That's actually a great way of considering this, because tomatoes are fruits botanically, like the way we define a fruit in science, like with how they form seeds and how they flower and things like that. Tomatoes are fruits, but no one thinks of a tomato as a fruit. When we cook, we don't treat tomatoes as fruits. In that same way, humans are fish and humans are apes. That's a great way of thinking of it. From Ozymandians for $5. Missed the stream because I was dealing with car troubles. Hope everyone learned a lot today. Thank you very much for the donation all the same, and I hope you enjoy rewatching it. From Where's Waldo for $5 Canadian dollars. Erica showing why she's my favorite teacher. I don't know what I was saying when you did this, but I hope I was doing something cool. From Icky Goat 222 for $5. Will, what would you need to substantiate evolution to your utmost satisfaction? Also love the final experiment, and Eric loved the channel.
Awesome. I don't think I know that. I think if I knew that, I would just tell Erica. I think when you look at a mind change, it's something that happens over time, and ideas have to be planted and thought about, and they have to begin to resonate, and then you learn new things and you apply them back to what you learned. So I just don't know what that is. I don't know.
We have I didn't know this, from Shion Pier for $9.99. We know humpbacks don't go from one ocean to another. In 2024, a humpback was found off the coast of Africa in the Indian Ocean that was previously spotted off the coast of Colombia.
So
Didn't
I
know
was talking about the Atlantic and the Pacific. And again, please, someone tell me if I'm wrong, but I don't think I am. That's what I was referring to, which is all the land masses of North and South America in between the two oceans.
We have from Ray Gatto for $5. Oh, Ray Gatto. Hi, my cat says meow, feeling fine and feline. I do love seeing Ray Gatto's cat, though. Thank you for your donation. From Tigacle for $5. Hi, Erica. Love your videos, and you introduced me to Hawaii Part 2. That's a great album. I suggest showing him a video of a chicken walking with a counterweight tail. Yeah, that's really cool. So I'll send a video of this to you, Will. But if you strap a fake dinosaur tail onto a chicken, they walk in the same way that dinosaurs walked based off of the footprint trails that we have of them. Like they change their stride length to match a dinosaur of the same size. It's really funky and cute. I'll send you a video. From Zamcrim for $5. I'm sorry, it's really it's really disheartening to hear Will say dogs aren't descended from wolves. Feels like going backwards. By the way, love you, America. I'm so curious. What's your
I did not deny that at all. So here's my weird theory about dogs. I think God created dogs to have extra room for variation, knowing they would be loved by humans as pets. I think the argument probably is going to be artificial selection is what created that, but I don't think you're going to get that kind of variety with, say, a zebra. I don't think if we had pet zebras and we had artificial selection, we're going to end up with all of the extreme colors and variations that we do and sizes that we do with dogs. So I actually look at that. I actually look at dogs as something that God put in them that he didn't put in other animals. That's my weird theory.
That is, yeah, I don't know what to say about that. Because there's a lot of support for dogs from wolves. Like a lot.
No. And I'm not denying that. I just wanted to be honest that it's not something I looked into. It sounds reasonable, but I don't want to be like, yeah, I know all about that. Yeah.
Yeah, that's, I mean, I might have to, I don't know. I might have to include something on that because that's very, that's like a unique position that I've never heard before. Like most, like I think I've only ever heard one other creationist suppose something similar. Well, actually, I know of a creationist who proposed that all dog breeds are different creations, which nobody agrees with. But yeah, I thought that was weird. But because I mean, there's like as insofar as you can document a domestication event, like we have like wolf dog bones, you know what I mean, that we can genetically test and like.
Yeah, what I'm saying doesn't is not at odds with the idea that dogs descended from wolves. Like what I'm saying is
I see. Yeah. I think I see what you're saying. Oh my gosh.
What I'm saying is if there was only one pair of wolves on the ark, I think all of the variation we have of dogs could come from that by God's design.
I totally get what you're saying now. So you do think dogs are domesticated wolves, but they were a special pair of organisms that had more diversity in them compared to other. Okay. I thought you were saying that dogs don't come from wolves at all. And that like, and I was like, dude, I don't know what to say about that. Like, I genuinely don't know how to respond. Okay. The other hypothesis, we can actually have a conversation about that. That's more heartening. Okay. From Bugmaster8647 for $2. Well, I'd love to hear your proof of the soul.
Yeah. I'm so glad you asked. It's out of body experiences. So I've never heard any decent response to out-of-body experiences. There's now thousands of them. So if you want, you can try to explain each one away, but that will be an exercise in futility. I'll give you two. There was a woman who was put under for a surgery in a hospital. And while she was on the operating table, she exited her body. And she was floating above the room and stated things, saw things in the room from the vantage point of the ceiling. One of them was a red sticker on the top of the fan blade in the room. She then floated outside of the hospital. And as she was ascending, she noticed a shoe on a window ledge on the outside of the hospital building. And so when she came to from surgery, she talked about this experience with the doctors and the nurses present. They verified the red sticker on the top of the fan blade, which no one knew about. And a nurse was super curious about the shoe. She described it as a man's shoe on his right foot that was blue, that had the lace underneath the shoe. So she started going floor by floor, looking out the windows. When she got to the 3rd floor, she found that shoe. So that's number one. Number two, which is more convincing to me. It's I shouldn't say that. It's closer to me because he's now a pastor in Colorado. There was a boy, I believe his name, I don't want to say his name, so I'm going to get it wrong. There was a boy who was under for surgery, and he came out of his body during surgery, and he noticed that his mom and his dad were not together. They were in different parts of the hospital. He noticed his mom was alone and crying. He noticed his dad was on the cell phone, and he could hear what his dad was saying. And so after, actually, that story gets even crazier. He actually went to heaven and met his sister, which he did not have a sister. Saw her, got her name and everything. When he came back, he asked his dad, by the way, I think he was 5 when this happened. He asked his dad, why were you on the cell phone and not with mom? He asked his mom, why were you away from dad and crying? And he's like, and by the way, I met my sister. She's a redhead. Here's her name. Why didn't you guys ever tell me I have a sister? And they had a miscarriage prior to him, and they had never told him about that. And so because of all of those things, they kind of freaked out because every single thing checked off. It was all exactly right. There are thousands and thousands of these out-of-body experiences that have details that cannot be explained by anything, as far as I can tell. The only thing that I think people can say is that everyone is lying. The doctors are lying, the nurses are lying, the people are lying, the parents are lying. And if that's the route you want to go, I'm totally fine with that. That's what flat earthers do. They say everybody that goes to space is lying, everybody who works for NASA is lying. So that's fine. But it's completely inexplicable. I see some comments in the chat right now saying that the boy lied, and that's not true. That's a different boy. So this one is now a pastor in Colorado, which is where I live. He's about 45 minutes away. He just did a recent interview, which is like 25 years later. I think he's 30 years old now. He's really never received anything for this. He's like, it's what happened. I told my story, and that's that. So anyway, if you look into these out-of-body experiences, you cannot explain them. There's one more, which I just forgot about. A doctor in Florida who was doing a surgery. I believe it was an open heart surgery. That guy had an out-of-body experience. And when he came back out of the surgery, he asked why the doctor crawled underneath the operating table. And that was because something had been unplugged. And so he literally had to crawl under the table to plug it back in. And so these things can't be known. There's no explanation for them other than we are not just a body. And so when they come out of their body, that's whatever you want to call it, it's not physical. And they are able to have verified, confirmed things that they see and experience. That's literally impossible if they're just a body that's on the operating table unconscious. So there's the proof.
I would love to look into some of those because I've not ever really taken the time to look into those or NDEs and people. I see them come up all the time, and I've just not had the time. But I will take a look for sure.
Cool.
From Joseph Grasser 3746 for $1, just nothing. That's it. Thank you very much. From Joseph Grasser. Oh, this is the actual one for $5. What does Will think of whales' signature whistles?
I don't know what that is, unfortunately.
Maybe they have I know marmosets have marmosets are little monkeys and they have names for each other, like specific calls for specific individuals. I would bet it's something like that. We have from Word and Witness 1 for $19.99. I've got to ask, what do you mean by some books have gone missing, like Letters of Paul that reference to Laodicea, or like others that you think were excluded from canon?
Yeah, it's not something I've spent a lot of time thinking about, because it's just a waste of time in my mind. But I believe in 1 Corinthians, Paul mentions a previous letter. And so maybe First Corinthians is actually Second Corinthians, Second Corinthians is actually Third Corinthians. I just think that it's too extreme of a position to take, which there's extremists in all areas of life, but there's a very small group of Christians that believe that the Bible that we have is exactly what God wanted, and he's preserved every single word down to every single letter, jot and tittle. And that just to me is clearly not the case. There's so many different translations. There's so many different versions. There's different manuscripts. Trying to figure out exactly what the Bible is an incredibly hard, probably an impossible task. And it's not beyond the realm of possibility to me that there were letters that have gone missing, for sure.
All right, we're getting close to the end here. So we've got Sylvan Epiglottal stop for 100 Argentinian pesos again. If you want to talk about the size of birds and flying, I recommend you check out the size of condors, and for fossils, Argentavas. Yeah, Haast's eagle is also huge and could fly. There's some big flyers. I'll send you some pics of that too. Well, it's really cool. For 100 smackaroos, thank you very much, Gingy2329. Very, very generous. How does Will explain mitochondria and them having different DNA structures compared to human DNA? We have not gotten to endosymbiosis yet, so that might be a little bit heady, but by all means.
I don't know what this is asking, unfortunately.
Okay, Gingy, I will jot this down for sure because this deserves a wonderful answer, and we will be sure to talk about this in the next lecture because we will be talking about endosymbiosis then. Thank you very much. And then we will re-ask the question then. From Ethan McIntyre, 7148 for $10. Human selected for dog traits. Humans selected for dog traits. Nature won't. Alive is even more arbitrary than taxonomy. It's descriptive. But you are both alive and fundamentally made of dead matter. Leap to alive, not huge? Question mark. I know viruses occupy a weird, not quite alive, not quite dead space as well.
Yeah, so humans selected for dog traits, nature won't. Great. I'm saying if humans wanted to select for zebra traits, I don't think they're going to get the variety that dogs get. That's all I'm saying. I don't think they're going to get very many changes at all. In terms of leap to alive, not huge. No, it's massive. We can't. Number one, we struggle to define life. Number two, we struggle to define death. And number three, we can take the most incredible situation, which is someone who has just died. You literally have everything you need for a human life, the entire body, and we can't bring it back to life. So it's like, that's very significant to me. Plus, in life itself is digital information. Digital information always comes from a mind.
We will talk a little bit more about that next time. Not necessarily abiogenesis, but certainly simple stuff to complex stuff. From New Coding Guy, 17Q for $5. Found this while studying for my Bio 2 exam. Super excited to binge it. Will, do you have any sources for proving a soul? I'm curious, as I'm an agnostic. We did talk about this a little bit, but by all means.
Yeah. I would look up John Burke, Burke. As far as I know, I like him more than anybody else. As far as I know, he went into researching out-of-body experiences 100% atheist, 100% skeptical. There's no way these are true. And now it's like his entire life because there just isn't any explanation. There's things that are completely inexplicable. So that if you want to have a resource, check out John Burke. He has a book called Imagine Heaven. There's a documentary, which is very hard to watch. You can only watch it on Angel Studios, called After Death, which is mainly about him. And then he also has a YouTube channel. So that's a good place to start.
Okay, this one needs a little bit of backing for it. So earlier, we were doing discussions about whether or not humans are apes, and I mentioned that there were men of God who have grappled with this. So before the theory of evolution was put to paper by Darwin and Wallace in 1859, like a century earlier, you had Linnaeus. You remember Linnaeus, the guy who devised kingdom, phylum, class, order, family, genus, species?
Yeah. He was a creationist.
He was a creationist, and his whole entire goal was to classify creation. That's all he wanted to do. He was a phenomenal naturalist, absolutely brilliant. This is a quote from him that's really famous. If I were to call man ape or vice versa, I should bring down all the theologians on my head, but perhaps I should still do it according to the rules of science. And the reason he said this is because he got a hold of an orangutan and a gibbon, I believe it was, body from the local zoo. And when he tallied up all the similarities and differences, he was like, they have all the stuff that humans have. So his whole problem was, he was like, we're made of the same stuff. Physically, we are the same thing. And so he settled on, interestingly enough, he elevated other apes to the human group, and he called us anthropomorpha, or the man-like creatures. So he was like, they're similar to humans, but they're not humans. And so humans, we shared a group, but humans were like the odd man out. Like we were shared in that group, but more specifically something different. We'll talk about that when we get there.
Okay.
From Ethan McIntyre 7148 for $10. If clades were arbitrary, different lines of evidence would produce conflicting groups. Instead, anatomy, fossils, and DNA repeatedly place birds within theropod dinosaurs and humans within apes. That's true. And we can talk more about that next time. Or when we talk about humans for sure. We have from Billy Ray Syrup for $4.99. Missing wisdom teeth is extremely common in human, and jaw size decreased. As jaws decreased in size to make room for large brains, there was an advantage for losing teeth.
I don't think that's true.
So potentially, but I actually think it has very little to do with large brains and more to do with the diet of modern humans. Because tribal groups that don't eat soft stuff, they actually have no dental issues because their jaws are naturally like capable of handling tougher foods because they eat it earlier. Wolff's Law states that bone will remodel in response to stressors. And so they just have like no dental issues. Now, the chin might be responsible for the retraction of the jaw, but more on that later. Okay, we have $10 from Whitney Battle 4315. If all life forms that ever lived on Earth lived simultaneously over the last 10,000 years, Adam and Eve would have been drowning in trilobites and conodonts and ammonites and synapsids. It would be a lot of biomass. That's true. We have two more. We have one from Shion Pride for $4.99. The humpback from Colombia could have gone west or east to get to Tanzania, and either way, it's further than merely going to the Atlantic. # gene flow. It's up to you if you want to say anything.
No, I don't think so. I don't think so. Thanks.
We have Xandor for $5. I don't know what this means.
It says with
out of body.
Yeah, out of body experiences.
Got it. Why do people always see their version of the afterlife? Tribal societies never see Christian heaven. Just curious. Well, it's
not true. It's absolutely not true. So you got to look into it some more. The experience, well, first of all, an out-of-body experience and a near-death experience are different. You have to understand the key distinctions there. And I don't know if I came up with this. I highly doubt it. I've just never heard it. But I think we need to add DEs, which is death experiences, because people have definitely died as well. But anyway, this is a myth. So there's one guy who I've watched his story, and he actually went to what I would describe as hell, and he was an atheist. So there are patterns with out-of-body experiences, which John Burke is really kind of a pioneer in. He's personally researched over 1,500 of these. And so he started to notice patterns, and the patterns are incredibly fascinating. But let's just make the case here. I'm not saying that out-of-body experiences prove Christianity. What I'm saying is they prove that we are not just a body. I have not heard any solid answer at all. And so if you have one, let me know. But these people experience things that they literally can't, because they're on the operating table among doctors, multiple doctors and nurses. Like they're explaining things that are happening outside the hospital. They're explaining things that are happening outside the room. They're seeing things on the roof of the building. Like you just can't explain that. And now there's thousands of them documented. So it's definitely worth looking into.
All right. That's it. Folks, thank you so much for being with us for 5 hours. This was a beast of one, but I had fun. And I think we had a lot of stuff to kind of get through. The next one is scheduled for May 27th, around this same time. Let me double check. It's actually May 27th, but I think it is.
1 hour
27th?
earlier, by the way.
1 hour earlier at 5 p.m. May
Central.
27th Central. Yeah, 5:27 Central. You'll get some reminders from me. We're going to be doing mammals in general from sort of reptilian ancestors. We're going to do tetrapods from fish, and from Sarcopterygian fish. And we're going to do a little bit on multicellularity. And we're going to cover a little bit of stuff at the beginning here. I will say, too, in the meantime, Will's having conversations with all sorts of people. He's going to be talking with Dapper, Dino, and Doc tomorrow, I think over on Dapper's channel with regard to Mark Armitage's Triceratops horn. I don't know if you guys are doing that live or what the plan is.
I think it's live.
Okay, cool. And then Will and I are going to be having a conversation with Fuzz Rana, who's a biochemist. He's going to be talking with us about soft tissue, dinosaur and soft tissue. I think Will's going to have a conversation at some point with Joel Duff, who's also a soft tissue guy. He's going the distance, folks. You got to give credit where credit is due. He's talking with everybody. I don't know. We'll see what happens at the end, but I'm excited to keep on going. So until next time, take care of yourselves, and we'll see you then. Ending the stream. It's going to take a minute. Bye.